Blockchain, the revolutionary technology that powers cryptocurrency, is reshaping how we secure and verify digital transactions. At the core of this innovation is a blockchain developer, a skilled architect who creates decentralized solutions. These developers create and implement distributed ledgers which provides transparency and security in our digital interactions. So join us on our journey to learn about the fundamentals of blockchain and how blockchain developers can help shape and secure decentralized digital future. With that being said, hello everyone and welcome to this video on the Blockchain Developer full course by Edureka. But before we get started, let's take a moment to outline the agenda for today's session. Let's start by understanding what blockchain is, then move on to the exploration of blockchain technology. Next, we'll look at how blockchains work, followed by a comprehensive blockchain development training that covers development requirements and platforms. We'll then cover over how to become a blockchain developer and look at some real-world applications. Moving forward, we'll learn about cryptocurrency, better understand its dynamic impact on decentralized financial ecosystems. Then we'll also cover topics including Ethereum, smart contracts, and Bitcoin blockchain. We'll also compare Ethereum to Bitcoin and hash graphs to blockchain, discuss Hyperledger, and explore what IOTA is. Finally, we'll explore top 10 reasons to learn blockchain and conclude a discussion of frequently asked blockchain interview questions and answers. But before we begin, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also visit the Edureka website for the Blockchain Developer Certification course, the link to which is given in the description box below.
Welcome to our blockchain tutorial. Blockchain is the technology that runs Bitcoin. Before understanding blockchain and Bitcoin, let me take you through the issues we face in the current banking systems. Banks charge huge transaction fees. Fake currencies create the problem of double spending. There is a long time involved in banking. And finally, banks can collapse anytime, such as the 2008 financial crisis. Digital wallets such as PayPal, Citrus, and Paytm solve some of these issues. They allow us instant transfers. Nevertheless, they are still dependent on banks. Bitcoin was the first system to solve all these issues. It is the revolutionary cryptocurrency, which is a digital payment system running on the blockchain technology. Bitcoin has the following features. No transaction fees are required. All transactions are completed within minutes. It is decentralized in that no one person owns the blockchain network. It can never be manipulated or hacked because of the basic structure of a blockchain. Let me now show you a simple Bitcoin transaction. We have James who wants to send 500 Bitcoins to Kevin. This transaction is verified by miners Lisa and Robert. They then start a race to solve a complex mathematical puzzle called proof of work. Suppose Lisa here solves it first. She adds her block containing the transaction to the existing blockchain. She is given 12.5 Bitcoins as a reward. This is what we call as Bitcoin mining. Blockchain is a public distributed database holding encrypted ledgers. This means a block is the current part of a blockchain which records the recent transactions. Once it is verified, it becomes a permanent part of the growing blockchain. Blockchain runs on three important technologies. Distributed machines on the peer-to-peer network help in maintaining the consistency of the public ledger. Blockchain uses private key cryptography to secure identities and hash functions to make the blockchain immutable. The mathematical principle of proof of work ensures that the nodes automatically and continuously agree to the current state of the ledger. Now that we have understood the basic concepts, let us explore a few of the real-life applications of blockchain. Follow My Vote aims to change the way we vote, becoming the world's first open-source online voting solution. Arcade City is the groundwork for a true decentralized ride-sharing service, often called Uber Killer. Showcard stores your identity onto Bitcoin's blockchain for easy verification.
what exactly is blockchain? Now, blockchain is the core technology that brought in the most popular cryptocurrency known as Bitcoin system. To put it quite simply, blockchain brought in a platform wherein people could exchange these cryptocurrencies as such. Now, as the name suggests, a blockchain basically is a chain from different blocks. But you might be wondering what exactly is present inside this block. Now, to give you a simple understanding, this block contains the details of all the transactions that happen using Bitcoins. So you combine all these transactions and then store it into a block, which then gets linked correspondingly. At every given fixed interval of time, there is a new block created. The present scenario helps you create a new block somewhere in 15 to 20 minutes. But again, this is something that keeps varying with respect to that. Now, the blockchain system in itself is not present at one single position. It's distributed across a peer-to-peer network, and anyone who wishes to join this network is free to do that. So what you're doing by joining the blockchain network is that you're downloading the complete ledger of transactions that have happened on the blockchain system. Now, don't worry when I say it's complete list of ledgers which have transaction details, because all the data present here is completely encrypted. So your personal data does not get affected here. Now, how that happens we'll be learning up in the upcoming slides. So let's move forward and talk about the various features of blockchain. So the first cool feature of blockchain is that it uses a distributed public ledger. Now, what do I mean by distributed public ledger is that all the transactions that happen on the blockchain system is stored on a ledger. And this ledger is completely public as well as distributed across the whole network. But hold on, you don't have to worry yet. All the data that is present in this ledger is just transaction details. That is the transaction ID number. But trust me, even if you do take the transaction IDs from here, you cannot hack into anyone's account and steal their balance. So it also ensures that you're completely anonymous. And this is achieved using the hash encryption that is part of the blockchain feature. Now, the hash encryption is a unidirectional encryption method where you feed the input and the output is completely unique. So from this output, you cannot guess what exactly was the input as well. So this in turn makes it completely secure. Apart from that, there is a concept known as proof of work. Now, proof of work basically is used as a means to validate the new blocks that get created. And finally, there are some incentives provided to those who will create the new block as well. So let's deep dive into each one of them and understand them in more detail. Now, as I had mentioned here, we use a distributed ledger. What do I mean by distributed ledger is that everyone who's part of the system gets a copy of the ledger system. And there's no central ledger system existing. It's because it's distributed through across anyone who's part of the blockchain system. Now, you might be wondering, if you have a copy to the ledger, can you not just modify the ledger and make profit out of it? Definitely not. This is where the peer-to-peer network of blockchain system comes into hand. Because what happens is, even if you try to manipulate a ledger, it is only reflected in your ledger. When you try to send across to everyone that these are the transactions that have happened in the ledger, then what happens is, since the majority of the people that are part of this group have the copy of the original ledger, the fake transactions or the invalid transactions get rejected. And this completely ensures that no fake transactions or invalid transactions are part of the blockchain system as well. And since it is spread across everyone who's part of the blockchain system, so even if you lose your copy of the ledger, you can always download it from one of the other people holding on to the ledger. So the blockchain system will help you do that without a problem. Now, I'm sure you might be wondering, even if I get the details of transaction, would it not be possible to hack their account from all the information present there? The answer is no. Because firstly, the ledger contains details of only the transactions, the amount of transaction being happening, as well as the timestamp when the transaction has initiated. Now, even the transaction ID that is part of the ledger is completely encrypted, and this encrypted value actually is a hashed output value. So let's talk about the hashed value next. Now, to give you a better understanding of how the hash function works, let's take an example here. Let's say I'm going to give hello world as an input to the hash function. It is going to give me a corresponding output. Now, looking at this output, I'm quite sure none of you can guess that hello world was the input. And this algorithm is so complex that even if you make a slight change with respect to the input, the output value completely changes. Let me show you that with this. Now here what I'm doing is, along with my hello world, I'm just putting an exclamation mark. But when you look at the output, it is totally different from our previous output. So here the hash value has completely changed. This in turn ensures that the output value is completely safe and secure, and it's just a unidirectional encryption that keeps happening. So this way what happens is no one can actually find out the details that is being passed through the hashing algorithm. So a decryption cannot happen in this place. Similarly, what I would do is I'll just change the capital H and capital W to small h and small w. That time what happens is it again completely changes with respect to the same. So as I had mentioned, it's not easy for you to just look at the output value and decide what the input value is. Now in the blockchain system, we use a SHA-256 encryption methodology, and unlike most other encryption algorithms, a hash function cannot be decrypted. That is, from the output you cannot decrypt the input. Now imagine all your details, personal details, would be hashed. Then wouldn't you feel secure at least to one level? Definitely, even I would feel that. But apart from that, you also used a group of encryption technologies like the public key private key encryption system on these hash values as well. So that adds on another layer of security as well to the blockchain details. So even if someone tries a brute force approach to guess all the values, he may be able to encrypt the data that is being encrypted with the public key or the private key. So he may be able to get the hash value which I have encrypted using my public key or private key, but at the same time he cannot decrypt it any further because this is a unidirectional hash function. Then he has to try out every possible value that is there out there to get the correct answer. So you can see here it occupies more than 53 places. So that's a huge number where you need to guess all the possible inputs to just get the output. So the complexity again increases as a whole. Now you might be still wondering, okay, I've understood how the distributed ledger works. I've understood how the data present in this ledger is secure as well. But then who adds this data to the block, or who creates the new block for the blockchain system? That is the job of a Bitcoin miner. Now, how does he do that? Is basically he solves a mathematical complex puzzles. Now, to give you a better understanding of what exactly is present in a block, there are mainly three major things that are part of a block. The first part is the hash of the previous value. That is the previous block that was present. You're going to take the hash address of that. That has to be included into the present block. This is mainly to ensure that we have a chain of blocks, and that's exactly where the name came in the blockchain system. Apart from that, it also has block data. Now block data has the details with respect to all the transactions that have happened in the interval when the last block was added. So as I had mentioned earlier, the interval between the creation of blocks is somewhere between 15 to 20 minutes. So all the transactions that have been taken place in that time frame and have been verified by the miner can be added to this block. So again, you use a hashing algorithm here as well. So this again ensures that no one can decrypt your data. Finally comes the concept of nodes. This is the part which makes blockchain system interesting. Okay. Now these people known as miners mainly do two major tasks. One is that they verify all the transactions that are part of the transaction pool. Now there are millions of transactions that come in every instant on the blockchain transaction pool. So they pick up a few of them and they start verifying. Now there's always the case where someone is trying to send bitcoins when they don't have the sufficient balance. Now this needs to be identified and rejected, and that's exactly is what a blockchain miner would be doing. He'd reject all these fake transactions and ensure only the valid transactions are part of the blockchain. Apart from doing this, he'll also start building the new block. Now while he's building the new block, he needs to compute something known as the nonce. Now the nonce basically is a value that you need to try to achieve by using a hit and trial method. Basically you need to just guess the value of nonce. Now hold on, it's not as simple as you think, because given the present scenario, in the year 2016 you had to compute close to 20 quadrillion values of nonce before you got the final solution. Now once you get the correct value of nonce, now it's always predefined what the value of nonce should be for every block. So once you've successfully guessed it, so you can tell everyone, I have successfully computed the value of nonce and my block is complete. So I'm adding it to the blockchain. Now this value of nonce in itself is a proof of work. This means that you have invested your resource and you are completely correct with respect to the values present in the blockchain. Because automatically when you are creating a block, only valid transactions are added to it. So thereby all the transactions present in this block also are valid as such. So it basically is a challenge that you need to overcome where you need to compute a specific value. So it's a guess game. Now you might be wondering, why would anyone actually waste their time solving these mathematical puzzles? That is because they get a specific incentive. Now every miner who validates a block, that is who creates a block which goes on to become a part of the blockchain system, gets a reward of 12.5 bitcoins. Now 12.5 bitcoins is not a small amount. Given today's market value of Bitcoin being close to $3,500 a Bitcoin, it would be close to $44,000 that you make from mining a new block. Imagine, $44,000 is a very huge amount. But the problem is that no individual today can create a block by himself or herself as such, because the resource needed to compute these values, as I had mentioned, you need to try out at least 20 quadrillion values. Now imagine guessing 20 quadrillion values, and that too in a time frame of just 10 or 15 minutes. Now this is why what happens today is that miners come together and form something known as a pool. Now pool basically is same as the groups that we form. Here what happens is that they share the responsibility of finding the values, and then what happens is, based on the resource that each one has contributed, the reward gets distributed accordingly. Sounds interesting, right? Great. Now one thing you need to understand is that the generation of bitcoins happens only in this way. That is, only by creating new blocks can you have newer bitcoins come into the system. Okay, because there is no other way where you can create bitcoins. The bitcoins are only provided as rewards for mining, and there can be only 21 million bitcoins in the world. This is mainly because the maximum range that Bitcoin values can take. And it is believed that given the present scenario, the last Bitcoin is going to be mined by 2140. So if you are looking to move into this market, now would be a really good time, seeing as to how the Bitcoin market is growing as well. So I hope you guys have got quite an insight into the blockchain system and the Bitcoin system as well. So any doubts still here? Great. Moving forward, let's talk about the Hyperledger fabric. The Hyperledger project is managed by the Linux Foundation and is something like a cross-platform collaboration approach. Here you have organizations working in different domains coming together and working on the same ground. Now the Hyperledger is one of the most trending technologies today. So if you are looking to move into the Bitcoin and the blockchain domain, then Hyperledger is something that I would definitely recommend that you look into. Now the reason why it is being so popular is because the Hyperledger project helps provide people with private as well as public blockchains for their needs and requirements. Basically, you don't need to worry about setting up the blockchain. Hyperledger would help you do that as well, thereby reducing the effort that you need to put in, as well as the complexity of bringing people on board and giving them the resource needed to set up the blockchain. Once you've given them your requirements, they help you in creating a private blockchain as part of the main blockchain itself. Now the advantage of this is, in future, let's say there are two companies who have their data present on the Hyperledger and they want to communicate this data. Then it becomes quite easy. Rather than connecting them to your servers or putting all your data on cloud, you just need to connect these two blockchains, thereby completely sharing the data that you want. At the same time, you can set the permissions, thereby ensuring you let them see only what you want to. Now moving on from here, let's talk about a use case of how blockchain can be implemented in the stock market. Now the stock trading system has been dated back to 1602, where the first public stock was of East India Company. Okay, although it has been around for 400 years, the conventional system is something that has still not changed. It is still almost the same as it was back then. There have been few minor changes, however there was no major change to the system as well. Now talking about the issues with the current system, there are depositories as well as agents. Now these people of contact, these points of contacts themselves are failing, because we always hear certain frauds happening between agents. There are instances where you cannot completely trust them, or even certain organizations as well. Apart from that, the registration, transferring of stocks as well as distributions, everything involve a certain fees associated with it. So every transaction that you would be performing in itself has a separate transaction fees attached to it. Finally, there's also the administrative fees that comes within, which is always growing. Now, if you worked with stocks, then I'm quite sure that you are familiar with all these challenges as well. Now, the major issue with respect to the current system, let's take the first issue itself. Now, there are mainly two problems here. The first is the regulator, that is the person who manages all this, and then you have the clearing house. Now, every stock exchange, let's say NIFT or Sensex, has its own clearing house. And at times what happens is clearing house in itself becomes the single point of contact where the failure for the whole system takes place. So some corruption here can in itself make the whole system crumble. And there have been issues over the centuries when this single point of contact themselves has been the source for all the frauds that we see. Now let's talk about our problem statement. What we need to do is design a blockchain solution to solve the issue of centralized stock exchange system. That is, one central authority governing and managing this should be broken down to decentralized problems. Now the problems with respect to a centralized stock exchange can be that one single organization is taking the money of all others and dumping it for its own profit. There have been a lot of cases like that. Apart from that, the extensive use of market depth is one major concern that happens. Increasing price to earn ratio is also another major concern because all this is completely governed by the central stock exchange. So what we're going to do is that we're going to introduce a blockchain that stores all the transactions made by these regulators, and this ledger would completely be visible to everyone. At any stage, anyone who's part of the public can also view this ledger by just being part of the blockchain system. And anyone who wants to get a verification with respect to how they are doing, they can get an understanding from seeing these blockchain systems as well. Now, this brings in a lot of transparency with respect to how the system works because the blockchain becomes completely visible to the public. So we get a clear-cut idea of what exactly is happening. Because here what happens in today's market is that it's all controlled by one central authority and we have to put our complete trust on them that they would not betray us. But again, times have told us where there have been certain issues. Now this in turn will bring in a lot of transparency as well as increase the trust of the system. And more the trust of the system increases, more will people invest into the system, thereby increasing the value of the system. Now, let's say someone wants to transfer certain amount of stocks from their account to someone else, or they want to sell it. Then what happens is it gets broadcasted across the network, wherein the network of nodes, these could be regulators who validate these transactions. Finally, once they have identified this transaction to be valid, what they'll do is they'll add it to a block and increase the blockchain's length. Now, this block could have just one transaction or even multiple transactions depending on its capacity. So I hope you guys are clear here. Okay, great. Moving on from here, let's try to understand where exactly is blockchain being used apart from the banking domain. Now, as I had mentioned, banking is one of the major domains where blockchains can be implemented and is being implemented as well. Similarly, you have payment and transfer industry where you're transferring certain amount to your friend, family, or even some stranger where you want to make a payment. Definitely the blockchain system can be used. Healthcare is another major domain where you can create a centralized blockchain system where it holds the complete details of the patients, thereby reducing the amount of paperwork and completely keeping the secure data of the patients as well. Law enforcement would also be a useful domain. So here what you can do is that you can completely share the data of all the criminals. It could also bring some awareness to the public, giving them knowledge of the common thieves in their area. Also make it quite easy for interagencies to share their data. Then you have voting domain. Now voting domain, I will talk about it extensively in the upcoming slides. Transportation is another domain. Online music, you can ensure that the piracy of online music is completely reduced. Real estate market is something else that is going to get revolutionized with blockchain. Now all these domains are just the beginning. There are multiple domains where blockchain can be used. And trust me guys, every given day there is newer technologies being used. So this is the right time for you to move into the blockchain market if you're looking to get a good career here. Now in the banking domain, what happens is by implementing blockchain, you can basically cut across $20 billion worth middleman cost. Now this $20 billion includes the middleman transaction fees that you provide to various banks and financial organizations. Now wouldn't you like to get rid of all the transaction fees that you have to pay every now and then? Definitely I would like to. Apart from that, hacking into the details of the customers becomes completely impossible because as I had mentioned, the blockchain ledger stores only the transaction details, not the account details. Thereby, even if you hack into the ledger, get some details of the transactions, you cannot get the idea of who has made how much transaction and how much balance do they hold in their account. Now, since it is running on a blockchain system, the issue of double spending as well as financial crisis gets reduced to a complete minimum. This is mainly because we follow decentralized approach, and here every transaction is validated and verified before getting approved. So the next domain is payment and transfer domain. Here basically what happens is you have complete security with respect to your details. Now let's take an example of Paytm, which is one of the most popular payment application today in the market, in India at least. Here what happens is you need to either share your mobile number with the user or you need to show them their QR code. But when you do that, what happens is that firstly you're sharing your personal number with someone else. Secondly, what happens is that they get the details of who has to receive the money, and this in turn causes certain amount of confusion as well as is some amount of breach of security as well. But by using Bitcoin wallets, what you can do is you just need to provide them with a QR code or your private key. Thereby what happens is no one completely gets any idea of who exactly is receiving the money. At the same time, you're completely sure no one has your personal details. Now there is an upside and a downside to this. You've heard of the upside. Now let me just give you an idea of the downside to it. If most of you have been aware of the news, there was recently a ransomware attack that had taken. There what happened was the perpetrators had requested payment in mode of Bitcoins and they had given their Bitcoin wallet address. Now since Bitcoin system maintains a complete anonymity with respect to the user details, no one really knew who exactly did that money go to, and it became hard for the law enforcement agencies to track them. Now, one of the major reasons that Bitcoin and blockchain system can be used for payment and transfer domain is because there's no fixed transaction fees attached to it. There are certain blockchains and cryptocurrency systems that add an additional transaction fees, but you always have the option of either paying a minimal transaction fees or no transaction fees at all. It's completely left up to the user. Here you don't need to basically set up your bank accounts. We all know the hassle of setting up a bank account. Here all you need to do is download a Bitcoin wallet and then you're ready to go as such. As I had mentioned earlier as well, the anonymity factor comes into this picture. You've seen both the good and the bad side. Good is that no one can really know who you are, but there's also a bad side when you use it for the wrong purpose. Coming to the voting domain, now this is one interesting thing that I would like to bring to your attention. If implemented correctly, we can use the blockchain system to create an online voting system wherein everyone who has a valid voter's ID can vote, and there could be no issue of vote frauds or lost records or even foul plays that happen. Because we know the blockchain system is completely secure and cannot be manipulated. Apart from that, the hashing algorithm can ensure that no double voting happens as well, because everyone is going to get a unique identification number for their vote, and this in turn cannot be duplicated as such. This in turn will definitely lead to an increase of turnout. Imagine having the ability of voting for your favorite candidate just from an application in your phone. Wouldn't that be handy? Great. Moving on from here, let's look at some of the blockchain applications that are completely revolutionizing the industry as such. First is Follow My Vote. Follow My Vote is being the first online blockchain solution for various people to identify themselves and cast their online vote. Now it is a work in progress, but definitely we can expect a result soon. Now SureCard is another revolutionary product that is built on the blockchain system. Here you can completely store all your valid identification cards and then provide link to this for any verification or validation as such, thereby completely ensuring that no one can manipulate it, as well as giving you complete access to who views it as well. Then you have Arcade City. Now Arcade City is one of the most upcoming technologies in the blockchain system in the field of transportation. Now this also believed to be an Uber killer because it helps user to maintain their anonymity as well as perform carpooling as such. Then you have 𝐓𝐫𝐞𝐻, which provides you an immutable blockchain ledger, and this is mainly used for diamond transactions and validation. So today when you go into most popular diamond merchants, I'm quite sure you can find them using 𝐓𝐫𝐞𝐻 to maintain a ledger of all the diamonds transactions involved. Then you have your Brooklyn microgrid, which basically is a platform for buying and selling energy that they produce from their rooftop solar panels. Interesting, right? Finally, you have BitShares, which basically is a high performance decentralized trading platforms on Bitcoin. Now the item of trade can be anything as per your choice, but again it is quite growing as such. Now these are just some of the revolutionary ideas that have just started in the blockchain system. So if you do have some idea, I would definitely recommend that you start away, because this is one of the greatest time for people who are moving into the blockchain and Bitcoin technology. Great. So moving forward, let's look at today's demo for the session. Now in today's session, what we'll basically be doing is that we'll be creating a smart contract on the Ethereum Remix browser. Now before we go on to talk about what exactly is a smart contract, let me talk a bit about Solidity programming language. Now if you are looking to work on Ethereum as well as create various smart contracts, then Solidity is one of the most important languages that you need to be aware of. Now Solidity is an object-oriented language like JavaScript, but it also supports inheritance libraries as well as various user-defined types as such. Okay, now these are just some of the basic features of Solidity. If you want to know and learn more about Solidity, I would recommend that you look at their official website, that is solidity.readthedocs.io. So let me just show you the page. Now this is the official homepage of Solidity, and if you are looking to explore this language more, this is the best place that I would suggest that you get started with. Okay, coming back to our slides. Okay, now using Solidity you can create contracts for various different purposes. Now as I had mentioned earlier, you can create a contract that would help you for voting. Let's say even if you want to create a complex contract, let's say there's a condition that you want that multiple people have to sign before the contract becomes true. And in a real world scenario that is true. So all such thing can be done with Solidity. Okay, now coming on to today's demo session, what we're going to do is that we're going to create a smart contract. Now smart contract word may seem a bit complex to you, so let me put it quite simply. A smart contract basically is a program which helps you either transfer your digital currencies or an asset as such between two parties, wherein you are specifying the conditions as such. Now let's look at the example here, what happens. So let's say there are two parties who have come to an understanding where they're trading certain asset with respect to that same. Once they have understood this, they'll go on to form a smart contract which will then be added to the blockchain. Now once this contract has been added to the blockchain, anyone can view this contract and verify it as well. Now this becomes highly essential while you're trading your real estate through digital transactions. Now let's say tomorrow you want to see who has owned the property before the present owner. So that can be really helpful if the contract was present on the blockchain, and it becomes completely easy for anyone to verify it, as well as at the same time it avoids the need for paper transactions. Now let me show you how the smart contract works. So this is what your Ethereum block browser would look like. Okay, so here you have details of the block, the transaction size and timestamp. Okay, now all the code that you're going to write in Solidity is going to be written in this Remix Solidity IDE. Okay, so all you have to do is just search for Remix Ethereum. Okay, so this will give you a search. The first one that you see, Remix Solidity IDE, this is what you want. Okay, so here you have the sample code. Okay, here you have the contract details, the environment from the input, the accounts present in the environment, the gas limit as well as the value. Okay, so first let me change the value of injected Web3. It has to be Web3 provider. I'm getting this notification. Let me click on OK. Here it says it's going to communicate with my port 8545. Now at my 8545 port, there's also the application known as test RPC running, which has the complete list of all the accounts as well as their private key present. So 8545 is going to be the port at which these two applications are going to communicate. So here let me just click on OK. Now I'm getting a security warning. Let me load this. It may take some time, so I request you to be a bit patient. Now once you've selected on which account you want to create the smart contract, then all you need to do is just click on create option present here. Okay. Now again, as I had mentioned, this may take some time, so I request you to be a bit patient. Great. So now here you can see the cost of this transaction, how much has it cost me to complete this contract transaction. And if you see in the account that has been reduced, earlier it was 1 Ether, now it has reduced correspondingly. Another way to validate this is to see it in your test RPC command. Now test RPC is a continuous running program, so it may not be that easy to get the details. Now if you see here, there is the transaction ID for the smart contract that we have just inserted, the contract ID that has been present for the injection, as well as the amount of gas or resource that has been consumed for creation of this contract, which block is this contract present in, as well as the timestamp as to when this was injected. That is with respect to the block. Now what you need to understand is with respect to this program. This is a basic simple program that is used for calculating votes based on delegates. So when you're inserting a transaction, basically means that you're inserting a vote with respect to that same. Okay, now let's go back to our Ethereum browser and let me show you how the transaction looks like. Here you have a new block which has one transaction and a corresponding timestamp. So if you click on the block number, here you can see the block number, the received time, okay, the difficulty and the nonce have been set to 0, and correspondingly the gas limit and the miner details. So here you can see the detail of the transaction, the hash for this transaction, okay, from whom has this transaction come to and to whom it is going. So 0x0 is just being set so that it is going into the system. So with this, I hope you've understood how we can actually push a simple contract into an account and how that transaction would be reflected in our Ethereum block explorer. So again, you have the hash for the transaction present here, you have the from address, you have the to address here, as well as the gas or the resource that cost for this transaction to complete.
So now let's move into our agenda, like what are we going to cover related to this blockchain technology and what, like, so just try to understand, like you will just understand the gist of it, like what am I trying to talk, like what are the problems, not at a very deep level you will be able to understand, but I will just make you aware like where we are, what are we trying to do with this blockchain and how this is important, where are we going to target this technology. All of these things you will just have an understanding right now, so that it would be easier for you to know like what am I going to do once I complete this technology, once I complete my 36 hours of training, where I would be and where I will be using this technology to the maximum extent. So these are some points which I want to bring it up to you. So if you could observe here, when I talk about the blockchain, okay, so when I say about the blockchain technology here, right, very important thing which every one of you need to understand is this blockchain technology which is being present, it is going to target your data. That's it. So now how it is going to target your data is what you need to understand. Okay, so now how your blockchain is going to target your data. So here when I say data, right, it can be any data. It doesn't matter whether it is a structured data or whether it is an unstructured data, it doesn't matter. But the point which I just want to highlight it here in this case is your blockchain technology is there to make sure that whatever data you are having, right, it is being protected in a more secure, safe, and in a transparent way. Only for that reason we are using the blockchain technology. Now you may think that, okay, oh, it's only for that purpose, but actually it's not so easy as we think. There are a lot of complex things which are being present under this technology, and there are also things which have been very easy also. See, any technology, if you take it up, there are mixture of things, like some things will be very easy, some things will be very much complex. But again, that is the reason why we are providing you this training, to make sure that everything would be very simpler and you can make the things in a very simple pattern. You can understand the things and then you can do the things in a better way. That is the reason why this technology is very much important for us. But before you learn about the blockchain technology, first thing what you need to understand here is, what is this technology? With this technology, where am I going to target? Now let me say, if I learn blockchain technology, I'll learn all the concepts, great. But tomorrow when I ask you this question, hey, you learned about the blockchain technology, right? Can you say me that where is this technology gonna be useful? You can't just explain the concepts to them because nobody is bothered about the concept right now. I want to know first, where is this technology will be useful? Your technology will be useful in protecting your data. Okay, so you need to use your blockchain technology in order to ensure that you protect your data in a more safe and in a secure way. So now you may ask me this question, that do we don't have any other mechanism where we can protect our data? Yes, there is lots of mechanisms which are being present, like where you can protect your data. There is no problem. But the point which I want to highlight right now to you is, even though there are so many mechanisms being present in order to protect the data, but still it is not been in a safe and in a secure way. The reason is, recently you have seen Twitter got hacked, Facebook has hacked multiple times, WhatsApp was been hacked several number of times. See, that is the level of transparency which is being present right now, right? you could see that lots of times the data is getting hacked. So how to protect it? What we can do? That's where this blockchain technology comes into limelight. Blockchain technology has come into limelight. Why industries, why organizations, why you, me, every one of us, why we are trying to invest our time? Only because this blockchain technology is protecting the data in a more safe and in a secure way, so that nobody would be able to dare to attack the data. Even if they try to do it, they will not be successful in doing it, because such is the significance of this technology. Now you may think in your mind that what is that which is present under this technology which is actually making it so strong in order to protect the data. Definitely there are the points which have been present, which I will let you know slowly. But yeah, these are the important points which you actually need to consider. Okay, so without considering these points, right, so you will not be in a position to understand that why am I learning this technology. So first I want to make this point very clear to you before I dig deeper, and then before I go ahead and try to provide you other important points. Okay, so I hope this has given you a good clarity, like where are we going to use this technology and in which component is this technology going to play a very vital role. Okay, so we are going to protect our data in a much safer way and in a much secure way, so that if anybody tries to come and attack my data, they will not be successful in doing it. That is the one of the biggest advantage which we are going to get out of this technology. That is the reason why many organizations and many entities are trying to work towards this technology. So now let me go ahead and try to put it up, like what are the issues which are being present with the current banking systems. Okay, so if I would just go ahead, so simply if you could just see this picture itself, we could be able to understand like what is the biggest issue with the current banking system. First of all, these banks which are being present, right, so these banks are actually here intermediaries. Okay, so this act as your intermediaries. Now let me say if Chandler wants to send some amount of money to Joy, okay, then what is going to happen? See, there would be a bank which would come up between the Chandler and Joy. So bank, what it is going to do, it is going to settle the transaction on behalf of the Chandler, like, and that money will be immediately credited to Joy, right? So now here what is going to happen is this bank will act as authoritative over here. Okay, it would settle the transaction and ensure that the transaction is being settled to the other person. So for doing that, they would also take some amount of transaction fees. Okay, so that they would ensure that the transaction is being done appropriately, which the transaction fee is sometimes is really high. Let me say if you do a normal transaction, you will not feel it, but when you want to do some international transactions, then you see that there would be a higher amount of fees would be charged from you. That is the reason why many people try to avoid using these foreign transactions. They would look for different approaches where they can reduce the transaction fee. But whereas in this case, like if you could see, this is the problem with the banking system. They help us out. Okay, they will act as an intermediary, and they would also take a higher amount of transaction fee, which is actually a big problem for us. Now if you could see recently, the JP Morgan, Bank of America, Wells Fargo, like all of them, they have almost collected around $6 billion in terms of transaction fee only. So which is actually, if you could see how much amount of money they are trying to get from this transaction fee. Indeed, let me say that is your money, right? It is your money which you have kept in the bank, and when you are trying to send your money to another person, on top of that they are taking some amount of transaction fee also. So which I would suggest that this is one of the biggest problem even with the banking system right now. So what we are trying to talk here is, with the help of the blockchain technology, when we start implementing this blockchain technology, right, you will be able to see that there would not be any intermediaries coming into the picture. This concept itself is totally eliminated when you implement the blockchain technology. There is no scope, or there is no way for the intermediaries to enter into the system. Okay, so everything here is a peer to peer. Peer to peer means, let me say here, one peer is Chandler, okay, and another peer here is your Joe. Okay, your Joy and Chandler are two peers. Now if they want to settle the transaction using the blockchain, so blockchain has certain cryptocurrencies, if you are aware of it or not. So there is some cryptocurrencies like, let me say you, Bitcoin, okay, and then there is something like Ethereum. So all of these things are actually being present, Bitcoin, Ethereum, and in the world there are almost like 12,000 cryptocurrencies approximately using the blockchain technology. But out of them, Bitcoin and Ethereum are only the famous ones. Rest of all of those things are still there, but they are not so popular as Bitcoin and Ethereum. Now let me say if you want to transfer Bitcoin from Chandler to Joy, so it will always be between Chandler and Joy only. There would not be any bank present between you, because as you are using the blockchain technology, those cryptocurrencies are being designed using the blockchain technology, and they are also the global cryptocurrencies. In India also you find out Bitcoin, and in the America also you find out the Bitcoin, and maybe if you go to Australia also it is your Bitcoin only. Okay, everywhere it is Bitcoin only, because it is a global cryptocurrency. It is not like our traditional way, like in India you find out rupee, and in Australia you go and try to find out your Australian dollar. So and if you go to Japan you will find out yen. So like this is not like that. It is a global cryptocurrency which can be used anywhere at any part of the world. Okay, so here this intermediaries concept is not at all there. If Chandler wants to settle any transaction to Joy, it will be directly between Chandler and Joy, and this third party will be totally eliminated, provided if you use the blockchain technology. So which is one of the biggest advantage which you are trying to get with the help of the blockchain technology, where it will totally eliminate the intermediaries who have been present between us. There will be no regulatory body. Now if Chandler wants to settle, it is between Chandler and Joy only, so that they can settle the transaction in the form of a peer-to-peer method, rather than having this third party in between us. Let me say if you want to send emergency some amount of money, and if your bank servers are not working, then you can't do anything even though you have the money in your bank. That is not going to give you any benefit. So because we are very much dependent on this banking system, that is the reason why this blockchain technology has totally removed this entire intermediary concept. If you have anything, then you need to talk directly to another person, and it is between you and the other person. That's it. Nobody will be involved between you and the other person. That is what we call it as our peer-to-peer model. Okay, so that is the I have highlighted the issue right now to you, and this issue has been eradicated with the help of the blockchain technology by removing this intermediaries in between us, by bringing up a concept called as a P2P. You can call this as a P2P, or you can also call this as a peer-to-peer. Both mean the same. Okay, it's called as a peer-to-peer model. Okay, so again with the issues with the current banking system, there is also higher chances for double spending. Double spending means, let me say, sometimes if you hack the bank servers, just for an example, so let me say you have only in your account $500 only. Okay, but what you can actually try to do, you can just, if you hack bank servers, then you can just go ahead and try to change in whatever way you want it, right? So let me say you still have $500, but you can just go ahead and try to double spend it. Like you will be sending to $400 and $500 to another person. Total is how much? 900, right? But how much do you have? 500. Because you have hacked the bank server, so you can do the transactions in whatever way you want it. Even this is also one of the issue with the current banking system, because the banking servers and everything is not so safe and transparent. Even if one of the servers got hacked or compromised, right? That's it. You can play with the banking system, and you can play with the entire money which has been present, and like it will take even sometimes like years to find out like who is that person who has done this. And even it will take some even a lot of time for the banks to also understand like which server has impact and what has happened. So it's really, you could see that Lehman Bank which has been present, right? If you know about it, Lehman Bank, and there are also other banks which has actually faced these issues, like where things have become very complicated, and finally they have shut down their operations. Now Lehman Bank is no more operational. It has been shut down in the year 2008. It totally got bankrupted, and finally it was totally dismantled at that point of time. So things are not like easy with the current banking system. So as I mentioned, like intermediaries are taking up higher transaction fees. Double spending is another issue here. See, as I said, bank transactions are prone to double spending. And you know that here, if you could see, banks are also becoming like they are actually facing a lot of crisis. One of the biggest crisis, you know, is your NPA, your non-performing assets, we call it as. You see the examples of Vijay Mallya, Nirav Modi, all of these people, they have taken a lot of NPAs from the banks. Okay, like they have taken the loan, but they have never repaid back. Now when you know that the money has never been repaid back to the loan, I mean to your bank, then how will they run their operations? They can't run the operations, because let me say I gave you money, and in return if you don't pay me the money, then how would I sustain? Same way is the banking also. So if I give you some amount of money, and if you don't return me back, then there is no point, right? How can I run my operations then? So that is what is your NPS, your non-performing assets. It is increasing tremendously, especially in India. That is the reason you see that there are lots of banks getting merged in order to ensure that banks can sustain. So this NPA is one of the biggest issues, and who is going to face the consequences? It is only we are going to face the consequences, because ultimately when the banks are bankrupted, right, then automatically your money will all be clotted over there, and it will be very difficult for us to get those money. The recent example, if you know, PMC Bank, your Punjab Maharashtra Cooperative Bank, if you don't know, you can just surf it in the internet. You will be able to find out your Punjab Maharashtra Cooperative Bank, like the problem which they have faced and how it has actually created a biggest issue. So you know that on a daily basis, even though you have 1 lakh in your account, you are not eligible to take that money. On a daily basis, you have to take around 1,000 or 2,000 only, because the bank has faced a major crisis, and you have to agree to whatever the RBI, which is our let me say regulatory body for all the banks in India. So whatever they say, you have to follow it, even though the money, even though it is your money which is present in the banking system. So such is our dependency towards these banks, and even if they face any crisis or any issues also, we have to face the consequences. So that is the reason why blockchain has identified all this sort of things, like what are the issues which have been currently right now, and how I can go ahead and try to get rid of all these problems, and how we can eliminate these intermediaries who are being present in between the system. That's where all these challenges which you could see right now, which I'm explaining, right, all these challenges have been eliminated, or it can be removed and eradicated with the help of the blockchain technology altogether. Okay, so this is one of the biggest problems with the current banking system, like NPA, non-performing assets, and one of the major bank like Punjab Maharashtra Cooperative Bank, it got bankrupted, and there are so many other banks also. Like if you could see PNB, Punjab National Bank, even it's not bankrupted, but still it has faced a lot of like losses and everything. But finally, all of them, they got merged and all. So this is a problem which even the government is also facing in terms of current banking systems. So all this can be eradicated and removed just by ensuring that we are using the blockchain technology to the maximum extent, by totally eliminating and removing them. And we can bring in our P2P concept, which we call it as our peer-to-peer mechanism. Okay, so how Bitcoin solves these issues? Okay, let's see that, as I already have explained to you, right, like how we can remove the third parties and intermediaries. Let's go and try to identify like how we can solve these issues and all. So Bitcoin has solved these issues we had with the centralized banks here. So if you could see how Bitcoin has actually solved this problem, is one is decentralized power. When I say decentralized power means, just see here. So now your bank which is being present, right, what is going to happen? Let me say you are having an account in an SBI. Okay, so now SBI will have all your information as well as other customers information. Everyone's information will be in the SBI only. Now SBI will have one single server, that is your centralized server, we call it as. Okay, so this is your centralized server. Now let me say this is centralized server means there will be only single central server. Any information, anything if you want to pass or anything if you want to retrieve, right, everything will be done from that centralized server only. Okay, so let me say due to any unforeseen situations or due to any natural disaster, or if anything happens, if this centralized server has been gone, then how are you going to sustain? What are you going to do? How you can ensure that this centralized server can be brought up? So it is very difficult. Just having single centralized server means there is a higher chances for single point of failure. If the server is gone and if the server is no more used, then entire data will be disrupted and you can't bring up the data, and it will be extremely difficult. So that is the concept of centralized server. Like it is actually very difficult for the blockchain technology to go with a centralized server where there is a higher chances for the single point of failure. Now let me say if any hacker tries to come and attack this server, right, that's it, all the data is in his control only. So technology doesn't want to encourage this. Blockchain technology, they don't want to go with the centralized server at all. They want to ensure everything would be in the form of a decentralized mechanism. Now when I say decentralized mechanism, it says that you will not have a single server here, you will have multiple servers. So there is no concept called a centralized server inside the blockchain technology. Everything here is decentralized. When I say decentralized here, right, let me say the participants who have joined in this webinar, every one of you, if you have your own laptop, right, that is a single node, we call it as. Now Prashant is a single node. In the same way other people who are being present, right, even all of you all are the single nodes here. Okay, so like this, let me say there are multiple nodes which will be present. Node is nothing but you can also call it as a server also. So now data, once it gets injected into first server, right, automatically the data will be replicated to multiple nodes which are being present in the system. Okay, so now what is the benefit of that? Let me say even if one server goes down, right, there are multiple servers which can cope up the traffic until and unless 51% of the systems are not attacked, right? You are safe. Nothing is going to happen. Okay, this is a very important point you need to consider, that whatever the servers or nodes which have been present here, everything here is decentralized. There is no single point of failure over here. Even if one goes down, there are multiple which are being present, or in order to disturb it, then you have to attack 51%. Even this will also become difficult for the hacker. Even if hacker tries to come and attack a single server, he will not be successful until and unless he attacks the 51% of the servers. See how drastically the technology has changed the process. If you see in SBI, even if a single server is gone, that's it. The entire data will be in the hacker's hand. But whereas over here, he has to attack at least 51% of the nodes to make sure that he is successful in it. Okay, so such is the level of decentralization which we can actually try to bring in and make sure that nobody would be able to attack the system. Even if they try to do, it will be extremely difficult, and you need a lot of computation power to go ahead and try to attack it. Okay, so without that computation power, right, you will not be able to attack. That is one of the important point which you need to consider. So you need to ensure that there is a lots of computation power for you in order to attack 51% of the nodes. Okay, and along with that, it is immutable. When I say immutable, right, what is immutable in this case? Immutable means once the data is present inside the blockchain, that data can never be changed nor never be erased. It is tamper proof, we call it as. Okay, so when I say immutable, it is tamper proof, that once the data is present inside the blockchain, nobody can actually try to tamper that record. Either you as a owner nor the other person who can access that data, nobody can try to change that data, as it is immutable. Okay, that is one of the strong property of the blockchain. Once the data is inserted, so you need to be extremely careful whenever you insert the data inside the blockchain. Okay, as it is immutable, so it is tamper proof, so that nobody would actually try to attack the data in the system. Even if they try to do, they'll not be successful, because you can't edit or you can't change any data once it is present inside the blockchain. Public ledger here, as it is a public ledger, that means because Bitcoin, and as we are talking about Bitcoin is being used by everyone. That is the reason why we call it as the public ledger, and it is accessible to everyone. Okay, so that is the important thing which you need to know. And no double spending. Why there is no double spending? The reason here is, see, in the decentralized power, what is going to happen? The data is getting replicated to multiple nodes. Now here multiple nodes will go ahead and try to verify and validate whether it is the right type of a transaction or not. Okay, so that is the reason why what is going to happen here is there wouldn't be any double spending mechanism also coming into the picture, because every node will validate that whether it is the right type of a transaction or not. Then only it will verify and say it is right. Let me say you have 500 rupee in your account and you have sent 1000, then it will not allow you. Okay, because you have only 500, how you can send more? So it will validate, the nodes will validate your balance, and it will check that whether you're sending equal to your balance or less than balance, then it is fine. If you're sending anything more than that, then it will not allow you. It will stop you there only, saying that you will not be able to do it. In that way, we are also eradicating this double spending problem, and as well as it is immutable, so that no data, once any data is present inside the blockchain, nobody can actually try to come and tamper that record, as it is immutable. Decentralized, there is no single server like where you can have a single point of failure. Everything here is distributed and decentralized, so that if anybody wants to attack also, it will be very much difficult for them until and unless they attack 51% of the systems. Otherwise they will not be able to do anything, and it is a public ledger, so that anybody can come and try to use this Bitcoin at any point of time. So this is how Bitcoin is trying to solve these issues with the help of the blockchain technology, like whatever I have discussed right now, the issues which we have with our centralized banking system. Okay, so these are some of the benefits which we are going to get as part of our blockchain technology. Like why it is so strong? Because of the decentralization and because of the immutability, and you're not getting a chance to double spend it. And at the same time, public ledger. Double spend means like you have 500, and if you're taking this 500 and if you're sending it to two persons, only one transaction will be valid, another transaction should be rejected, because by that time your account will be having zero. You have already sent 500, then automatically the other transaction should be rejected. Now let me say you have 500, and for both the persons, if you're able to send 500, then that means there's a double spending, right? So you have only 500, but you're sending 1000 rupee. 500 to one person, 500 to another person, because you have hacked the server. Whereas here you're not getting a chance to hack the server, because everything is decentralized. You need to attack 51% of the nodes, then only you will be successful. For that, you need to have a higher amount of computation power. Then only you will be able to do it. Otherwise, you will not be successful in doing it. Okay, this is how you can actually solve your issues with the Bitcoin. And as I said you, right, the best part here is like your transaction fee is also zero. Okay, so you don't need to pay any transaction fee, because as you know, Bitcoin is what? It is your blockchain technology. Using your blockchain technology only, the Bitcoin was been designed, right? So here what is going to happen? It is a peer-to-peer concept. So the transaction fee will be zero, or otherwise it is up to you. If you want to put any transaction fee, you can also put it up. It is up to you. Okay, it's optional. Either you can go with a zero. Even if you go with zero also, nobody is going to question you anything, or otherwise your transaction fee can also be optional. If you want to provide any transaction fee, it is up to you. You can also go ahead and try to provide it. There is no problem. Okay, so this is also another important point which you need to understand. And let's see how the Bitcoin transactions would generally look like. Okay, so if I would just go here, as I already said you, using the blockchain technology only, we have actually derived our Bitcoin. Not only Bitcoin, we have also got Ethereum and other cryptocurrencies also have come into limelight with the help of the blockchain technology. But the point which I want to highlight is Bitcoin is your first application. There may be multiple applications which have come around this blockchain technology, but the first application is your Bitcoin. Using the blockchain technology, the first application which came into limelight is our Bitcoin. Okay, so if you could just see here, so this is how your blockchain would basically look like. Okay, so this is your entire blockchain. These are your set of blocks which are being created in the form of a chain pattern, and whenever the next block will be created, right, that will add to our existing chain which is present. Okay, to our existing chain, our block would fall and it would be added to our existing blockchain which is already available. Okay, so that's what it is trying to say. In this way, there are lots of blocks which will get created. Okay, like till now I could say that there are around millions of blocks which are already being created. Okay, it started in the year 2008, 2009, I would say the first block was being created in the Bitcoin, and till right now it is 2022, and still the blocks are getting created and it is getting added to the existing blockchain which is already present. Okay, so these are also some of the points which you need to know. So where every time a block would be created and it would be falling inside the blockchain. Now you may ask me this question, that what is being present inside this blockchain? There are transactions. You can deal with a lot of transactions, whatever you're trying to do. All those transactions would be present inside this blockchain. And along with transactions, you can also store some of the data also, like it may be your land details, your house details, or any product confidential information also. You can put it in inside this blockchain, so there is no problem. Okay, and your Bitcoin is your first decentralized digital currency. As I said, as it is the first application of your blockchain technology, it uses a very good cryptography to make sure that it is safe and secure. Okay, and then as I said, it is a peer-to-peer concept, like where if you want to transfer, there wouldn't be any third parties and intermediaries, so you can transfer the amount with the help of the peer-to-peer mechanism. Like one peer will be you and the other peer will be the next person whom you want to transfer that amount. Okay, so then finally the ledger is being produced by people using software that solves the mathematical problems. Simply, if I would say, now you know that okay, there are blocks being present inside the blockchain, but who is responsible for creating the blocks inside the blockchain? This is the important thing which you actually need to understand. Now, who is responsible for creating the blocks inside the blockchain? Here I would just say you that like miners are actually responsible for creating the blocks inside the blockchain. So how they are going to create the blocks? They are going to solve a mathematical puzzle. Okay, they have to solve a mathematical puzzle, then only they will be allowed to create the block inside the blockchain. Now let me say there are a number of participants over here. Now if I give you a puzzle, so the person who is going to crack the puzzle first, he will be able to create the block inside the blockchain. I would just say, instead of Prashant, you can replace it with the Bitcoin software. So there would be a Bitcoin software present. This Bitcoin software, it is going to create a puzzle, and rest of the people who have joined this webinar, right? Assume you all are miners. Now all the miners should crack that puzzle in order to make sure that you win. Once you win, there will be only one winner who has found out that puzzle very quick. That person will be eligible to create the block inside the blockchain. That is what we call it as here. Your ledger is getting produced by people who are using software that solves the mathematical problem. So you need to, as a miner, you need to use a mining software from which you can do mining and you need to solve the mathematical puzzle which is being provided by the Bitcoin software, and whosoever is going to win that puzzle very quickly, that person will be eligible to create the block inside the blockchain. That's it. Okay, that is how the blocks are getting created inside the blockchain with the help of the miners. Okay, so this is all about your Bitcoin. And let me say you that if I want to transfer some amount of Bitcoin, like let me say you that where James wants to send some amount of Bitcoins to Kevin over here, like how much? Let me say 500 Bitcoins over here. So now what is going to happen? As I said you, here there are miners. In this case, Robert and Lisa are the miners. Okay, Robert and Lisa, what they are going to do is, so they will verify, miners will go ahead and try to verify this transaction, that whether really James have those 500 Bitcoins or not, and whether Kevin will be able to get the transfer appropriately or not. Okay, the validation would be done with the help of the miners, and this is how we are eliminating this double spending problem, which I already highlighted, right? This double spending problem will be eliminated with the help of the miners who are going to validate this transaction, saying that whether this is a right type of a transaction or a wrong type of transaction. That's what I'm trying to highlight it over here. Okay, so same concept as I already said you. So okay, so here you will be able to see in the blocks what is that which is being present. You will be able to see a list of transactions being present under it. Here, this is the thing. You can see that the list of transactions which are being present, right? All of these things would be present inside your block. Your average block size is 1 MB. So you can't have all the data in every, I mean to say in single block, you will not be having entire information. You can have the data up to 1 MB. Average block size is 1 MB. So hardly you can have around 1 to 5,000 transactions in between this. Okay, so you will be having all these transactions being present inside your block. So in that way you will be able to see all your transactions being registered inside your blockchain. So here if you could see it, this is what we call ledger. Ledger means it is a set of transactions which are being present under your block, and once your block gets added into your blockchain, then we say that our transactions are confirmed. Until your block is not fallen inside the blockchain, right, your transactions are not confirmed. So your block needs to be fallen inside the blockchain, then only we will say that our transactions are being confirmed. Okay, ledger is nothing but it is a set of transactions which have been present in a sequential pattern. Okay, so that's how all your transactions would be present inside your blockchain, as I've tried to highlight it right now to you. Okay, so yeah, now again the same concept. So what is going to happen here? So I would just say you that even the miners who are being present, Lisa and Robert who are there, right, they are miners. Even they will also validate that whether the list of the ledger which is there, right, where we have a list of transactions, even miners are going to validate even each and every single transaction, that whether it is a right type of transaction or not. Once they give the approval, then only it will be considered, then only those transactions inside the blockchain will be considered. Let me say if they don't accept it, then the block will not fall inside the blockchain. So let me say there are 10 miners, just for an example. Okay, out of this 10 miners, at least if 6 miners agree that saying that everything is appropriate, all the transactions are right, then it will be accepted. That means 51%. Okay, at least if 51% of the miners agree saying that yes, everything is appropriate, then automatically the block will fall inside the blockchain. Let me say 51% of them, they don't agree, then the block will not fall inside the blockchain. Once the block doesn't fall inside the blockchain, that means the transactions are not confirmed. Until and unless your block falls inside the blockchain, your transactions will not be confirmed. And once the block falls inside the blockchain, right, then finally your transactions are said to be confirmed. Okay, even the miners are also responsible to validate the list of transactions which are also being present inside the block. That is their duty and the responsibility to do it. Okay, so that's what I'm trying to highlight here. The Lisa and Robert who have been present as a miners, they will validate the transactions which have been present inside a block. Okay, so then what is going to happen here? Once the block is been validated, right, then what is going to happen? As I said, like once the validation and everything is done, then what is going to happen? Already in the existing blockchain, the block will fall. Okay, once everything is accepted and once everyone approve, the miners saying that yes, in our case Lisa and Robert, once they say that yes, everything is appropriate, then the block will fall inside the blockchain, then the transactions will be confirmed. Until then the transaction is not be confirmed. Okay, so then what is going to happen? Immediately you'll see that the money will be transferred to Kevin's Bitcoin account because it got confirmed, right? Miners have validated it and they said that it is right. So automatically it will be confirmed. Once it is confirmed, then you will see that the money will be credited from James to Kevin, the whatever the 500 Bitcoins which we were discussing of. Okay, so that will be immediately sent, and this is solving the problem of double spending. As you know that miners are validating everything appropriately, so there is no chance of double spending happening over here. Okay, and finally, as I said, like here if you could see, like let me say my like Robert and Lisa, both of them are present. Now as I said you, if you remember, there may be multiple miners, who are being present, but out of them there will be only one winner, right, who is going to create the block inside the blockchain. So in our case we have Lisa and Robert, so we can just assume that Lisa is our winner. Okay, Lisa has cracked the puzzle from the Bitcoin software. Let us assume that Lisa is the winner. So automatically what is going to happen is Lisa will get some credit. Okay, because she has kept a lot of efforts and then she has found out that particular puzzle, right? And then only she was able to create that block inside the blockchain. For that, what is going to happen is your Bitcoin software which is present, right? Your Bitcoin software will give you some credit for doing the efforts. So right now it's been mentioned as 12.5 bitcoins, but instead I would say 6.25 bitcoins is what is being given as a reward to you. As a miner, if you go ahead and try to crack that puzzle from the Bitcoin software, you will be eligible to create the block inside the blockchain, and along with that you will be given a reward of 6.25 bitcoins because of the efforts which you have kept. From the Bitcoin software you will be getting it, not other person will be giving you, neither Robert nor James nor Kevin, nobody is going to give you. You will get this money directly from your Bitcoin software for doing all your efforts. So 6.25 bitcoins, not 12.5. As of now it is 6.25 bitcoins, which will be provided to the Lisa because she is the winner. Just an assumption. And then finally you know that the current block will automatically fall inside the blockchain. Your transaction will be confirmed and it will be called as a permanent blockchain. Okay, because it is present inside the blockchain. Okay, so that's how you can also see that if there is any winner who is going to win, then definitely they will be getting some benefit from the Bitcoin software. Along with that, that miner is also responsible for creating the block inside the blockchain. Validation will also happen in order to ensure that there wouldn't be any double spending problem. And finally, whatever the block will be there, once the validation and everything is successful, once 51% of the people accept it, then the block will fall inside the blockchain. So then the transactions are said to be confirmed without any issues. Okay, so this is the important point you need to consider. So now how blockchain achieves the Bitcoin solution. Okay, let's see like how blockchain is going to achieve the Bitcoin solution. Let me say if someone requests a transaction to do. Let me say if someone like Alice requests some transaction for Prashant. Alice says that, hey Prashant, please send me 2 bitcoins. Then let me say Alice has requested a transaction to me. The next step will be, if you could observe here, the transaction will be broadcasted to the network. That means what is going to happen, as I already said you here, everything is decentralized and distributed. So automatically once the data comes into this node, automatically the data will be replicated to multiple nodes which are being present inside the system, so that everyone will have the same data. That Alice is requesting the transaction to whom? Prashant. Now Prashant has initiated the transaction to Alice, let me say 2 bitcoins. Now that will be recorded in the decentralized pattern in a multiple nodes. Then the validation will be done by multiple nodes that whether really Prashant is having 2 bitcoins. So they will validate, and once the validation is successful, right, then what is going to happen, the transaction will be part of a new block, and finally that block will be added inside the blockchain, and then we can say that the transaction is completed. So this is a cycle. Okay, transaction would be sent, it will be replicated to multiple nodes or servers, you can call it as, and then these nodes and every servers which is being present right inside the network, they will go ahead and try to validate it. They will say that whether everything is appropriate or not, and then the transaction by that time will be present inside the block. Once they agree, then the transaction will fall inside the blockchain. Once they don't agree, then the transaction will, I mean say that block will not be added inside the blockchain. So once the block is added inside the blockchain, then what do you know, that your transactions will automatically be confirmed over here. Once your transactions are being confirmed, then you can say that your transaction is being completed successfully. Okay, that is how your entire flow diagram of the blockchain would actually be present. Okay, so I hope I've given you an understanding related to this flow diagram of the blockchain technology. Yeah, again, it's the same concept. Okay, so it's again the same thing. Like I could say that this is your first block, your growing blockchain, and then your block, once it falls inside the blockchain, then only the transactions will be confirmed, and you can say that it is a part of your blockchain technology. Okay, same thing, the same things are being again highlighted, like new blocks will be created, it will be added inside the blockchain, and then it will be confirmed. Okay, so blockchain are being actually the blockchain is being built from three technologies, like as you know, one is your private key cryptography, another one is p2p network, is your peer-to-peer network, and the third one is blockchain program. You can write your own blockchain programs and you can customize it in whatever way you want it. Let's see what are those. Here blockchain uses something called as a private key cryptography to secure all your identities and all. So simple as I would just say you, like let me say if you have a wallet, like where you have some bitcoins present inside your wallet. Now how you can preserve this wallet? Basically you will have your own private key. So using that private key you will be entering into your wallet, right? So without using that private key you will not be able to accept it, right? So that is the private key is a way like how you can secure. In the same way for your internet banking and all, you'll have your passwords, right, which you will not be sharing to anyone. If they know that, then they will be able to enter into your account and they will take away your entire amount. In the same way here also blockchain uses some private key cryptography which should always be preserved and in a very safe and in a secure way. It should be only with you. Okay, so you should not ensure that those keys are being shared to anyone, because if they are able to access that key, then they will definitely enter into your wallet and they will grab away all the coins which are being present as part of your wallet. Okay, so this is one of the important thing, and we also use some hash functions also to make the blockchain immutable. So hash functions means here we use some cryptography, which is an advanced concept which will be covered in a very detailed way in our training. So hash functions here means I could say some cryptography we will be using to make sure that our blockchain is more immutable and it is more difficult to be hacked. Okay, peer to peer, as I already said, like it would be done without the help of any third parties and intermediaries. Okay, and here you can make sure that your program, you can write your programs and you can create your own protocols. Now let me say, as I said you, right, let me say if there is a 4 nodes, now the data will be replicated to all the 4 nodes successfully, because that is the significance of the blockchain technology. Right, now how they are going to accept it, there will be some protocols present in all these nodes. Using this protocol they will accept the data. Let me say if they're not accepting the data, then that will be difficult, right? So basically every system or every node which is present in the blockchain network will have some like what we call, we have some protocols being present under it. Like some of the protocols, if I would say, like there would be some whisper protocol or gossip protocol. These are all protocols which we can use inside these nodes in order to make sure that whatever data comes they can accept it, so that the data will be replicated synchronously. That is your protocols which we can design using our programs inside the blockchain. So these are three important things which you need to consider, like private key cryptography, p2p machines like a peer-to-peer network, no intermediaries. Private key, you should put it safe and secure so that nobody would able to attack it. And then you can also have your own blockchain program, like where you can create your own protocols like whisper and gossip, so that the nodes can go ahead and try to accept the data. Okay, so private key cryptography, if I would say, this is asymmetric algorithm. When I say asymmetric algorithm, what does that indicate? Asymmetric algorithm will have two keys by default, that is your public key and your private key. Okay, your asymmetric algorithm which is being present, right, it will have two keys, your public and private key. So you can make sure that whenever you're talking about asymmetric algorithm, it will come up with two different keys, that is your public and private. It is simple, public key can be shared with anyone. So let me say if somebody wants to send you some amount of money in terms of bitcoin, then you can go ahead and try to share them your public key, so they will be automatically sending it to your public key. And then you can use this private key and you can enter into your account. Private key is confidential, which you should not share, like your password. Private key, using your private key, you need to enter into your wallet and you can use that money wherever you want it. But using private key only, you will be allowed to enter into your wallet. Okay, this is asymmetric algorithm, like where you will be having your own public and private keys. Okay, so you can ensure that using public key, you can just go ahead and try to provide this public key to anyone so that they can send you some amount of money. private key is always confidential, which should not be shared with anyone. So this is what we call it as our private key cryptography. So we are using this asymmetric algorithm to ensure that our private key and public key is getting generated. Okay, asymmetric algorithm means where you can have two keys. P2P network, as I already have said you, the same mechanism again. So first of all, let me say if Bobby wants to pay 5 coins to Cindy. Okay, so what is going to happen? First it will strike the first node, and then later it will be verified, and once it is accepted, then it will go to B node and C node, and again B and C node will verify it. Again they will transfer to the respective nodes. In this way everything will get distributed. Whatever the data which is present, they will be distributed and it will be validated also. In this way we are also reducing our double spending problem, and we are making the system more transparent enough. Okay, so see here, same thing, whatever I've explained to you, the same has been highlighted over here. So it will be rapidly going ahead, and it would be the transactions would be spreaded across all the nodes which have been present in the network. Okay, and every node will be independently verifying it, and then only if they accept, then they will go ahead and try to distribute to other nodes which are being present to it. Okay, so as I said you, so everything here is in the form of a distributed pattern. Okay, so whatever transactions you do, it would be distributed to multiple nodes. Okay, so there is no centralized concept here. This is eliminated, like where you will have only one in one single server all of these things here. Andy will have its own distributed server, Bobby, Derby, Cindy, every one of them, they would be able to see that the data is distributed here rather than having in a single centralized server. So if this single centralized server at any point of time, if it goes down, then it will be very difficult to cope up. So that is the reason why here everything is being distributed. Okay, so that's what it is trying to say. And again, digital signature, it's simply nothing but it is just trying to show you the flow. Let me say if somebody sends you some amount of money to you, how you can ensure that you can access that money. Let me say if Prashant has sent you around 100 rupee to your account, how you can verify and say me, you have to enter into your account, and then you need to see that whether Prashant has sent to you or not. How you will be entering into your account? By using your password, your net banking password and all, or either your code with pin code, whatever, like not a pin, if I would say passcode, which you would have set it up, right? Using that also you can enter into it. In the same way here also, what you can do is you can either use the digital signatures. Okay, digital signatures also you can use, like for example, like a checkbook. In the checkbook you pay some amount of money and you sign it saying that it is you. In the same way you can also digitally sign, and you can provide some transactions, even that is also been allowed over here. And whenever you want to access the money, if other person has sent you, you have to use your private key and you need to enter into your account and you need to verify it. Okay, so that is also another important thing which I want to highlight it to you. So blockchain program, if you want to create your own blockchains, okay, in any customized program, if you want to write it on your own, then how you can do that? Here is the way. So you can do it in your own way by implementing the any language you can use, but I would say Solidity is the most preferential language. Now if you want to create anything inside the blockchain, then Solidity is the most preferred programming language. You don't need to worry about it. The basics and advanced topics of Solidity, each and everything will be taken care in our session. Okay, in our training session we will take care of all these things, so you don't need to worry about it. Even if you don't have the programming skills, or even if you are not aware of this Solidity programming, it doesn't matter. I will ensure that you get the best out of the Solidity programming language, starting from basics to advanced. But Solidity is the most preferential language in order to create your own set of applications using the blockchain technology. Okay, so this is also another important point which I just want to put it up to you. And as I said, the blockchain transactions, so everything here is being distributed, and you can just have a look into every transaction in the form of a node. You can validate, and then you can verify, and then you can accept it. And the same data will be replicated to multiple nodes. Okay, so here, as I said, transactions are being basically verified by the miners. Okay, the transactions which have been present, they have been verified by the miners, and who actually ensured that they would solve the complex math puzzles in order to become a winner. Okay, so here the mathematical principle ensures that the nodes are automatically and continuously agree to the current state of the ledger. As I already have mentioned, right, there are some protocols like Whisper and Gossip protocols which you can use and ensure that all of your nodes are in the current state and they're accepting all the data, they're distributing, and they're validating all the data whether it is right or wrong. Okay, so again, if anybody attempts to corrupt the transaction inside the nodes, let me say if somebody has attacked this node. Okay, so even if he attacks this particular node, right, he will not be successful in doing that because he needs to attack at least 51% of the nodes, that is majority of the nodes, to become a successful hacker, which is indeed a very, very difficult job because you need a lots of computation power to go ahead and try to break these nodes. So that is the reason why we are giving that guarantee, saying that no hacker if can actually go ahead and try to attack, but even if they try to do it also, it will be extremely difficult for them because all the data is getting replicated synchronously, and if anybody wants to come and try to attack, it will be very difficult for them to do it. Okay, it is 51% of the systems they need to attack in order to do anything inside it, and which has not been proven till now, and many people have dared to do, but they have not been successful in doing it. Okay, so this is also another important point which you need to consider. There are different types of blockchains, like you have your public blockchain, private blockchain, and then consortium blockchain. Public blockchain means which is visible to everyone. You, me, every one of us can use this blockchain. Like most of the important blockchain in terms of public domain means, I would just say you that your Bitcoin, okay, and your Ethereum, all the cryptocurrencies are basically in the public blockchain only, because if these are not in public domain, right, people will not understand what it is and they will not invest. If they don't invest, then the coin value will go down. So obviously major cryptocurrencies will be in the public domain so that anybody can try to come and invest and they can know more about this blockchains, if I would say. So that is what we generally call it as our public blockchain, okay, whatever which is being present. And then we have our private blockchain also present. Okay, so private blockchain means it is only used at the enterprise level. Okay, so at the enterprise level which is actually being used, so like especially in the industries, especially in the industries which have been present, right, there we would be using this private blockchain. And then consortium blockchain which is present, right, here you will have multiple leaders who will actually be handling this blockchain technology. Like let me say in the private entity you will have only single organization which will own that blockchain technology. Like for example Reliance will only handle this blockchain. In consortium blockchain you will have multiple leaders present here. Okay, so when I say multiple leaders, right, like for example like you can say Microsoft, Amazon, and Google, all of them can actually go ahead and try to take a common decision. That is where we use the consortium blockchain. And if it is a private blockchain, only single entity will handle it. And if it is a public blockchain, it is open to everyone. Anybody can come and try to invest or access this blockchain. Okay, that's how the blockchain types are being segregated into public, private, and consortium blockchains. So in a nutshell, if I would say, we are using some mathematics, that means some hashing and cryptography, to create a secure ledger so that nobody would actually try to come and attack the system, which would enable the transactions to be done without the need of any intermediaries. This is what is a blockchain in a nutshell. So we are using some hashing and cryptography mechanisms, and we are taking the advantage of a distributed ledger which would do the transactions without the involvement of any third parties or intermediaries. Okay, this is in a nutshell if I would say about the blockchain technology. And if I would say the features of the blockchain, as I've already said, the same topics over here, you can make sure that your fraud resistance is high here, because as you know, everything is being validated by the miners and there is no double spending problem. And because of the decentralized mechanism, as every data is getting distributed to multiple nodes, so if anybody wants to come and attack the system also, they will not be successful in doing it, because everything here is safe and transparent and is distributed and decentralized, and it is immutable, so that nobody would actually try to come and attack. Even if they try to change anything inside the blockchain, it will not allow you to do, because it is immutable in nature. Okay, so in that way you can make sure that your fraud resistance is being totally reduced. Consistency is being present, because you know that as all the data is getting distributed to multiple nodes, so it is been consistent enough to make sure that it accepts all the new data, and it is synchronously replicating to all the nodes which have been present. Okay, there is no central authority like how we have in our traditional mechanism. There is no central authority here. Everything here is distributed and there is no intermediaries are being involved. Okay, the Bitcoin reward, as I already have said you, so it is not 12.5. If I would say right now, as I mentioned, 6.25 Bitcoin is the reward which is being provided to the miner as and when they go ahead and try to make sure that they win that puzzle, and then they will be eligible to create the block, and then they will be allowed to create those bitcoins also. Okay, I mean to say those bitcoins will be given as a reward from the Bitcoin software to that miner. Okay, what are you going to learn at Edureka? Like how our training, the 36 hours of training is being structured. If you could observe over here, okay, the first one would be like where we will be discussing about the blockchain origin, like how it started, what are the important points we need to consider. And then we will be moving on to our hands-on part. And our second module will be all about the cryptocurrency and blockchain, like how the first application of the blockchain technology is our cryptocurrency. So we will understand it in a more detailed way, and then we will be moving on with our practical aspects, like how to create a wallet, how to do transactions, how to do transfer of money, what are the different types of wallets available, who are using these bitcoins and other cryptocurrencies which are being available in the market, how to do trading. All of these things we will be discussing about it. And then your third one will be your Bitcoin platform. We will discuss about a Bitcoin platform, how it is, and then the hands-on related to it. And then we will be discussing about Bitcoin mining in a very detailed way, how the Bitcoin mining will be done, what are the hardware equipments really required, how you can do mining if you are really interested, what are the mining pools, all those concepts we'll cover. And then we will see the hands-on related to it. And then the fifth one would be the introduction to Ethereum. Like Ethereum is also one of the very famous applications of the blockchain technology. In Ethereum, we can write our Solidity code and everything. So I will explain to you like what is Ethereum, what are some of the important topics related to it. And then we will also be doing hands-on related to it. And then we will be moving towards the basics of Solidity, like how you need to understand some of the important keywords, global variables, state variables, local variables, all of those things I'll try to explain to you, some of the keywords and syntaxes and structure of the Solidity. And then we will do hands-on. Okay, and then we have an advanced Solidity concepts where we will be discussing about how to mint our own coins, how to book a hotel using cryptocurrencies. We will be writing our programs, and we will see how to conduct elections. All these things we will be able to see using advanced Solidity. Okay, and then we will be seeing how to develop a DApp using a truffle, a decentralized application. That's a hands-on. Okay, and then we will also be seeing that what is a hyperledger concept, which is an enterprise oriented blockchain. And then finally we will be able to see how to create and deploy our own private blockchain on multi-chain. Okay, so those are the topics which we are going to cover as part of our blockchain Edureka's training, like blockchain and Ethereum certification part. There are multiple use cases also which we are going to discuss as part of our training, like banking system, payment and transfers, healthcare, law enforcement, voting, payment and transfers, online music, real estate, along with this land and registry department. And then we can see many aviation sector, how we can implement the blockchain technology, agriculture sector. All of these use cases also would be discussed with you in the prospects of blockchain, like where I will be discussing everything in a very detailed way so that you can understand like how you can implement. And tomorrow whenever you get a chance, you can also go ahead and try to work on those applications. Okay, so as I said, banking system, how it is going to create a mess. So we want to ensure that we can reduce the fraud by implementing the blockchain technology towards it, so that hacking can be really impossible and nobody can try to hack the bank servers with the help of the blockchain technology. And then payment and transfers also, we are using this blockchain technology to make it more safe and secure, so that there wouldn't be any double spending problem. As I already have said, there would be miners who will be validating it, and you don't require any bank account. You just need to have a public key which you can share, and then automatically the transfer of money would be done into your account. Okay, and then your voting will be explained in a very detailed way, but right now I can just say that we will be using a blockchain technology e-voting mechanism. Recently, if you would have seen that Telangana and the Tamil Nadu government have already started implementing this blockchain technology towards e-voting. Okay, so they already have like kept the research papers, like whatever they have discussed in the meeting. So they want to start at the panchayat level, how the elections are being done. Okay, so that this prototype can be carried forward to other sectors, I mean to other elections like MLA and MP elections, general elections, how it can be helpful and how they can actually extract it a lot from it. Okay, so they're exploring more about it, and we will see that how blockchain can be beneficial for our voting mechanism in our training in a very detailed way at the prospects of the blockchain technology. And for hands-on, right, we will be using certain tools, like if I would say here, Remix is one of the tool. Okay, in the remixethereum.org, this is a tool which we will be using in order to write our solidity code. Okay, so basically if I just want to give you an example here, this is how your solidity code and everything would look like. Yeah, I will explain to you everything in a very detailed way as we come into our training, but this is our remix tool where we will be writing our entire code and everything. Okay, so and apart from that, we also have a MetaMask wallet. Okay, so this is a MetaMask wallet which we will be downloading. It just takes around 2 to 3 minutes to download this wallet. This is also very much useful in order to deploy our smart contract and everything. Okay, and along with MetaMask, we will also be having something called as the Ganache wallet. Okay, this Ganache is also important. This is for deploying a private blockchain. In order to deploy a private blockchain, you require Ganache tool, and for MetaMask, it's actually meant for your public blockchain.
So let's start with a simple definition of blockchain technology. So blockchain is a decentralized distributed public ledger system. Now let's break down the definition and understand each and every technical jargon. The first few technical terms that we encounter are decentralized and distributed. To understand what it means to be decentralized and distributed, let's start with the status quo, that is centralization. Any organization of network where decisions regarding the organizations are made by a chosen group of people is a centralized system. Presently, we are surrounded by a mass of centralized system which we use every day. Be it you want to order food from some delivery and logistics system like Zomato, or you want to book a cab through Uber, you're basically going through a third party. This third party has complete power on the rules and regulations of the system. Even though these guys have a majority of the power, they greatly rely on your trust to stay functional. For example, I'm sure you keep your money in the bank instead of just stowing it away under your bed at home because you trust the bank more than your next door neighbor. A decentralized system is exactly the opposite of a centralized system. It is when a service is ruled by no single governing authority. You're using a decentralized system right now. That is the internet. Nobody really owns the internet, and nobody is really supervising what websites can or cannot do. So that was pretty easy to understand. But what does it mean to be distributed? So to understand what a distributed system is, let's look back and analyze what has been the common reason for a majority of the data breaches of the past. So in 2013, Yahoo faced a huge data breach which affected around 3 billion users. Then in 2014, eBay faced a cyber attack which compromised the user information of around 145 million profiles. Again in 2016, Adult Friend Finder, which is also a site, was also attacked. Hackers collected around 20 years of data on 6 databases that included names, email addresses, and passwords. Now, all these attacks were successful because these companies chose to keep all their data in one basket, or if I may say, one server, which makes it very easy for a hacker to creep in and do creepy stuff. By distributing everything everywhere, a hacker would need to change the data in all the places at once. Blockchain is distributed and decentralized. This means that whatever is stored on a blockchain is distributed, and the blockchain in itself is owned by no single governing body. By distributing everything everywhere, a bad actor would need to change the data in all places at once in order to do their sneaky things. It feels weird, but by opening up and giving the data to everyone, you protect it. So what we see from breaking down the definition so far is that blockchain is some sort of a system which is owned by nobody and has no single point of functionality and instead is distributed in nature. Now let's look at the other half of the definition, which states that blockchain is a public ledger system. So first of all, let's get our heads around this whole ledger system. A ledger is a list of anything. The term ledger originates from banking as it was first coined to denote a list or a book containing financial transactions. Now, in reference to blockchain technology, what exactly is a ledger? Well, it's all the transactions that are committed on the network. To understand what I mean, let's jump back to the genesis of blockchain technology. So the birth of blockchain technology dates back to 2009, and the timing was impeccable. While the world was facing one of the toughest economic crises, a group or person under the pseudonym of Satoshi Nakamoto introduced to the public Bitcoin, a digital currency not owned by the government, but in essence, very much like fiat currency, or some of you would call cash. So in the sense, it could be spent anonymously, it could be hard to track, and it is easily trusted. Now the underlying tech that powered Bitcoin was blockchain. So any transaction that was made using Bitcoin as a currency was registered on a list called a ledger, and this ledger was then distributed to all the members that had agreed to participate in the network. Everybody could essentially keep tabs on each other's transactions, and to anybody trying to tamper with records would be easily identified due to the distributed nature of the system. Now, since the meteoric increase in both value and fame of Bitcoin, other such networks have come up, with each network trying to decentralize some service or the other. But the fundamentals of the network remain the same. Okay, so now that I've explained what it means to be a ledger, let's try and understand what it means to be public. So it is hard to fathom the power of public when it comes to blockchain, because the participants or the public, whatever you call them, is responsible for the most integral part of the system, that is validation. So let's take a scenario where a blockchain network has only 4 participants, namely A, B, C, and D. Every time one of them spends some money in Bitcoin, they broadcast the transaction down to the last detail onto the network. But how are the remaining members supposed to know what A is saying indeed is valid or not? This is handled by blockchain's unique method of validation called consensus. This means that every participating member must agree or come to consensus regarding the validity of a transaction. Every network has its own unique way of achieving consensus, and Bitcoin protocol uses a method called proof of work. The video is going to get a little more technical, as we are going to be discussing a few new technical jargons from here on, but I'll try my best to be as simplistic as possible. Now let's go back to the little scenario I had just discussed, and here A broadcasts a transaction to the rest of the network. Now let's also assume that this is not the first transaction of the network, and this particular transaction is an addition to an already ongoing list of transactions that have already been validated. Every time a new transaction is committed to the network, a new block gets created, and all these transactions are firstly hashed. So what exactly is hashing? To answer simply, hashing is a process of converting a long string into a unique string, generally of much shorter and fixed length. What is important to understand for you as a viewer is that the generated hash depends completely on the input. Even a slight change in the input will change the output hash completely. Secondly, in blockchain, a unique kind of hashing is used, and this is called cryptographic hashing, because they cannot be practically reverse engineered. So now, to get a better understanding of hashing and how it integrates into blockchain, let's think back. I had just mentioned that the list of transactions is taken together and hashed. So the output hash, or the digest, is called the block hash and stands as a unique identifier of that certain block. So suppose A were to sneakily try and change the history of transactions in a certain block, the output block hash would be changed drastically, which would easily denote that something has been tampered with. So right now our focus is to see how a function can prove that a particular list of transactions is truthful. Imagine someone shows you a list of transactions and they say, hey, I found a special number, so that when you put that number at the end of this list of transactions and apply SHA-256 to the entire thing, the first 30 bits of that output are all zeros. How tough do you think it would be to figure out that number? So let's bring in some math here. Let's say the hash is only made up of ones and zeros and is 256 characters long. In such a case, the probability that a hash happens to start with 30 successive zeros is around 1 divided by 2 raised to 30, which is about 1 in a billion. And because SHA-256 is a cryptographic hash function, the only way to find the special number is just guessing and checking. So the person trying to check validity of the block almost certainly had to go through about 1 billion different numbers before finding this special one. And once you know the number, it's really quick to verify. You just run the hash and see that there are 30 zeros. In other words, you can verify that they went through a large amount of work, but without having to go through the same effort yourself. This is called proof of work. What's important is that all of this work is intrinsically tied to the list of transactions. If you change one of those transactions even slightly, it would completely change the hash. So you'd have to go through another billion guesses to find a new proof of work, or a new number that would start with 30 zeros when tied up with the altered list. Now think back to our distributed ledger situation, where everyone is there broadcasting their transactions, and we want a way for them to agree on what block is correct. As I said, the core idea behind the original Bitcoin paper is to have everyone trust whichever ledger has the most work put into it. The way this works is to first organize a given ledger into blocks. Now, in the same way, a transaction is only considered valid when it's signed by the sender. A block is only considered valid if it has a proof of work. So let's see how proof of work is actually helping us in identifying any sort of mismatch in a transaction. So firstly, now imagine there's this list of 5 transactions between A, B, C, and D, and the block hash is whatever you see on the screen. Now, if you were to slightly change any transaction, or if you were to slightly change the order of the transaction, the complete hash is changed drastically. So this will easily tell anybody that the proof of work is wrong, as he can compare it with the other blockchains on other copies, and this is how you reach consensus that this block is not valid. Okay, so that explains how proof of work ties in with blockchain. Now, also to make sure that there's a standard order to these blocks, we'll make it so that a block has to contain the hash of the previous block as its header. So firstly, it already contains the transaction and the proof of work, which looks something like this. And now the next block will also have the block hash of the previous block. So it'll look something like this. Now, since the block hash has been chained, we can see a certain chain being formed. So instead of just calling it a ledger system, it's been commonly known as the blockchain. Okay, so the last part that's left is miners. Now, every time someone validates a certain block after putting in all the work to find the special number, the system rewards them with a network-specific cryptocurrency. Now, in the Bitcoin protocol, currently the block reward as of February 2018 is 12.5 Bitcoins. Not only does this incentivize system keep the network running, but also generate new currency. Now, some people have invested in high-performance GPUs so that they can validate new blocks quicker than the others and earn and live off the block rewards. These people are known as miners. Okay guys, I think I've covered most aspects of blockchain. We understood how blockchain is a decentralized and distributed system. We saw the public nature of blockchain and how intrinsically ties up to public participation using incentivization. We also saw how the security and integrity of the system is maintained using cryptographic hash functions tied up with a consensus mechanism.
Digital payments have replaced the whole idea of carrying cash with you. Whether you want food, groceries, cabs, or even a general service, you can pay for everything digitally, but it's not really like cash payments. Cash is untraceable, it can be spent anonymously, and more so, cash is trusted. Escaping these problems was the promise made by Bitcoin, the first cryptocurrency that had the beautiful anonymity of cash, and it was cash that was not printed by the government. Instead, it was made by a bit of code that was powered by the citizens of the internet, and you could trust it. Today, anyone can buy crypto. A few signups, smash in your credit card details, and trade in your money for digital cash. Bitcoin got so popular that by the end of 2017, it was as valuable as the big banks it stood against, and soon opened the gateway to thousands of other cryptocurrencies. Now, the backbone of all such cryptocurrency, including the Bitcoin, is blockchain. You could think of the internet as a bank for all transactions that occur. Now, unlike a bank that maintains one single copy of the transactions, blockchain distributes this copy of the list of transactions to all its participants. So whenever someone spends some money, all copies around the world get updated. This way, everybody can be sure that the ledgers are always up to date, 100% legitimate, and continuously verified. Now, maintaining this distributed ledger is a lot of work, but it's nobody's work to do so in particular. Instead, people are given incentives in terms of cryptocurrency to voluntarily validate these transactions. For the first time, you can have a distributed network to come to a consensus about the order of transactions. This allows for a trustless ledger controlled by no single authority, but instead by a network of people. It's a system that gives us a new perspective on trust by showing us that nobody alone is a trusted user. Rather, everybody together is accountable for the trust of the system. Now that is an incredibly powerful concept. People from around the world are betting their money that blockchain will not only revolutionize money, but also a plethora of other centralized services that can be potentially decentralized, like say the Internet of Things, supply chain, ownership change, and so on. A lot of countries like Estonia, Switzerland, US, and China makes use of blockchain in various domains today. So we do have code out there that solves the problem of trust on the internet. We just don't know if trust is a problem technology can solve, as long as humans are the ones operating and using it.
Current existing monetary system. Now, before we go into the existing monetary system, let's try to understand how the monetary system as a whole has changed over time. The first system that came into existence was the barter system, where you exchanged one kind of good with respect to the other instead of any fixed monetary as such. Then we had a universal ledger system where we used gold coins for exchange of goods. Now there was a certain value set for each good and then they would be exchanged with respect to gold coins. Then came the age of flat money, Here what we did was we exchanged paper currency which were cheaper than gold coins in exchange for any kinds of goods as required, and then came the age of digital banking. Now through online banking and digital banking, it became quite easy for us to purchase as well as sell our goods as per requirement. Now the current system that is existing and the one on which bitcoins as well as all cryptocurrencies are based is the decentralized digital money. Now here you have a decentralized form of monetary system where not one single entity controls the governance of the money as such. We'll be talking more about the decentralized money system ahead, but right now I hope you guys have got a simple understanding with respect to the change in the monetary system. Okay, great. It's good to see that you guys are following. Now let's try to understand how trading actually happens with respect to current existing system. What happens is all the trades or transactions as such are kept inside a book. This book or ledger is offline wherein all the details are completely stored and only people who are associated with the bookkeeping can view this. Not anyone can view the book. Now to give you a simple example, we can only see the transactions that have been made by us or involved as part of our private accounting ledger. Now this is same as your banking report wherein you can only see all the transactions related to your account as such. For this reason, we actually trust a third party or a middleman to facilitate as well as approve all our transactions. Usually it's either a bank or a financial organization to which you're associated as such. Okay, but again, there are certain issues that are present with respect to the current existing banking system, and we'll be talking about few of them one by one. Now before I go ahead, can you guys give me a quick reply as to what do you feel is wrong with respect to the current existing system? Okay, so I seem to have started getting answers. It's good to see that you guys are being quite interactive. Now let me just pick out a few of them. Here I can see fake currencies. Yes, definitely that is one of the major concerns. High transaction fees with all transactions, definitely that is one of the problems that most of us face. Because in today's monetary system, almost every transaction requires a certain added transaction fees. And not every one of us is comfortable paying that as well. Apart from that, I can also see bank frauds. Definitely that is another issue. So let me not go into that. Let's come back to our slides and let's see what we have here. Now the first issue is double spending. Now to those of you who are not familiar with what double spending basically is a fraud that is part of the digital currency system. Here by using fake digital certificates, you can actually initiate transactions when you don't have sufficient balance. Apart from that, the chances of fake currencies being part of the transaction is also another major concern, as we have seen as well. Then we also have the issue of standard transaction fees. Now let's say here Chandler is sending $10 to Joey, but there is a standard transaction fees of $2 that is associated with it. Now it may not seem a huge amount here, but let's say when you're dealing with a large transaction, then it becomes a problem as well. And if you look at the example here, according to SSN and CNN Money's report, in the year 2015, JP Morgan Chase, Bank of America and Wells Fargo earned $6 billion from just ATM and overdraft fees. Apart from this, the overall transaction fees collected in 2015 is estimated to be close to $42.5 billion. Now that's a huge amount when you look at it, $42.5 billion from only just United States in 1 year. Now again, this is from different kinds of transaction fees, and these third parties as well as financial organizations make their revenue just like this. Another problem is the transaction delays. There is a certain delay with respect to every transaction that we make. Now let's say you're sending money to a relative in US, then again it takes about 2 to 3 days. Again, the earliest is almost 1 day, but then again there are certain additional transaction fees that you have to pay to get it processed faster. So the time delay that comes with respect to transaction is another major concern. Apart from this, one of the main concern when you're trusting a third party or a bank as such is the financial crisis. Now most of us might remember the 2008 financial crisis that had happened because most financial organizations had lent out their money as subprime mortgages to people who couldn't afford to pay them. This in turn led to a huge financial crisis where the value for real estate had dropped, and that led to almost $11 trillion worth crisis. Apart from that, you had close to 10 million people who went jobless with respect to that same. Now this was a very huge number, and this was mainly because we had put all our trust into a third party and given them all our money, who in turn went and tried to get a profit out of this and caused a trouble for all of us as well. Now these are some of the major challenges that are part of the current existing banking system, and let's try to understand how bitcoins and blockchain help overcome these issues as such. But before we go ahead, I hope you guys are clear. Any questions still here? Okay, I see a lot more problems here, but let's not go into that right now as we have discussed. Let's keep these four itself in our mind and move forward with respect to that slide. Because any system that is there at present will have certain amount of flaws with respect to that. And as I had mentioned earlier, this is one of the key reasons why Bitcoin and blockchain system is so extensively being used as a parallel system for the monetary solutions. Okay, thank you, Frost. So moving forward, let's try to understand how blockchain and Bitcoins help solve these issues. Now, some of the major issues that we have talked in the previous slides are highlighted here. There's the centralized power system, there's the private ledger system, double spending, and prone to hack. So let me just summarize this once again. Now, centralized power basically means that one central authority governs the complete monetary system. Now, this could be a federal system or it could be a global system as well. One single authority controls all the power with respect to that certain monetary solution that is part of the existing system. Now, with respect to the private ledgers, as we have talked, every transaction that you make is only visible to you. The other transactions of those involved with that organization is not completely visible to you, and it's not completely transparent. Now, let's say you are paying $50,000 to a bank. You're not completely aware who exactly gets this money and what exactly they're doing with respect to that same. Although it would give you some amount of satisfaction if you knew who exactly is this money going to. But again, if this system was available earlier, then I'm quite sure we could have avoided the 2008 financial crisis where subprime mortgages were lent out. Then comes the issue of double spending. As we have discussed earlier, double spending is an issue with the digital system where by using fake digital certificates, you can initiate transactions when you don't have sufficient balance. So let's say I'm sending every one of you $500, but at the same time I have only $200 in my bank. By creating fake certificates, then I can ensure that all of you get this money, and that exactly is the challenge of double spending as well. Finally comes the issue of prone to hack. Every now and then we have heard about how the accounts of certain people associated with a financial organization or a bank have their accounts hacked and certain data modified. This could be their money being transferred out, or this could be distributed somewhere else, and so forth. Now, the first challenge of centralized power is getting hacked by using a decentralized power here. Blockchain system uses a distributed ledger system where anyone and everyone who's part of the system gets the access to the ledger and has the complete access and power with respect to the system as well. Apart from that, we follow a public ledger system here. All the transactions that are part of the blockchain are completely visible to everyone who's part of the blockchain. Then comes the issue of prone to hack. Blockchain system is completely immutable to hack, and no one till date has been able to modify or hack the system as such. Now, you might have heard about certain organizations which are associated to Bitcoin and blockchain getting hacked, but the core technology of blockchain has never been hacked as such. It's only the application built on the blockchain or the Bitcoin system that gets hacked as such. Apart from this, the issue of double spending was one of the key features that gets solved as part of the blockchain solution, because while building the blockchain system itself, this was kept in mind, and till date there has not been an issue of double spending as well. So are you guys clear with respect to how a blockchain and Bitcoin can help solve these issues? Any questions with respect to the same? Okay, so I seem to have a question here from Ajay. Ajay has asked me, if the ledger is public, can't everyone find the details with respect to the people involved in the system? Okay, Ajay, that's a very good question. So let me just address your question in this way. Since you're part of the blockchain system, only details that you get as part of the blockchain system is the transactional details. That is how much is being transferred from who to whom. But what happens is even this data that gets transmitted is completely secure and encrypted. No one can actually decrypt this data and identify who is sending to who. We use a public key private key encryption system here, which we'll be talking ahead in the slides, but the identity of everyone involved in the transaction remains highly secure as well. Although there are certain blockchain systems that use account-based system, but Bitcoin blockchain system is something that does not deal with the account details as such. Here only the details with respect to the transaction is stored. Are you clear now, Ajay? Okay, good to see that all of you are clear. But still, there is one flaw that we have not talked about that is present in the current existing system which gets tackled by the blockchain system. And this is the issue of transaction fees. In blockchain system, you either have to pay zero transaction fees or very minimal transaction fees. Now I'll be showing you how minimal the transaction fees is when we are transferring from our blockchain wallet to our personal wallet. But just to give you an idea, it's completely left to you. If you want to add a transaction fees, you can add. If not, you're completely free not to add as well. Some systems do add at times a minimal transaction fees, but this is very less when you compare to the actual existing system. Okay, so I have a question here from Shilpa. Shilpa is asking me, why should there be a transaction fees if the option of zero transaction fees is available? Okay, that's a very good question, Shilpa. Let me put it in this way. At a given instance, there are millions of Bitcoin transactions that happen globally. As I had mentioned, this is a distributed system that is spread throughout the globe. Okay, so at the given instance, there are millions of transactions that keep happening. So here you need to initiate a transaction which needs to be verified as well. So if you are attaching a fixed transaction fees with respect to your transaction, then what happens is your transaction is picked up on a priority. Now, although all transactions do get solved, but if you add a transaction fees, then what happens is your transaction is taken up on a priority level. Does that answer your question, Shilpa? Okay, that's great. Now that you've understood how the issues with respect to the current system can be tackled by the blockchain system, let's try to understand what exactly is blockchain. Now, blockchain is the core technology or the spine behind Bitcoin cryptographic system in itself. Originally introduced in 2009 by Satoshi Nakamoto as part of a white paper, the blockchain and the Bitcoin system was one of the key factors that led to the idea of decentralized digital currency system. Now, it was only in Jan 2009 when the first Bitcoin and blockchain system was implemented. Although it is still a mystery as to who Satoshi Nakamoto is, it is believed that he is a Japanese man who was born in 1974. But then again, these are just some of the rumors that are heard. But one thing is for sure, Satoshi Nakamoto is one of the most interesting men because he not only came up with such a complex system, he also holds close to 1 million bitcoins as part of today, and which is close to $2.4 billion. So that's a huge amount. And the mystery still remains. Apart from that, blockchain in itself is a technology which is a publicly distributed database. Now in these databases, what you're basically storing are encrypted ledgers. But then you might be wondering what is present in these ledgers. As I had mentioned earlier, now the ledger in itself actually holds a set of transactions which are verified and validated and have been completed after the previous block was created. Now every new block contains multiple transaction details. Now these transaction details again are hashed and encrypted and stored as part of a block. So every 10 minutes as per the current time, a new block gets created. And as you keep grouping up these blocks, it tends to become a long chain and it is called the blockchain in itself. Now, right now, even while we are speaking in this session, as per we're going in the slide itself, you can expect a new block to be created and the blockchain system to keep growing on as per the current standards. And once a block has been successfully added to the blockchain, the work on the new block starts and you keep building up the blockchain system. Now moving on, let's talk about the three basic fundamental factors based on which blockchain system was built. The first is the cryptographic technologies. Here you use a public key private key cryptographic to ensure that no one is able to identify the user, as well as you use various hashing functions which make the blockchain immutable. That is, you cannot modify anything that is part of the blockchain. Now why does this happen? We'll be discussing a bit later. Now you might be still wondering, even though it is a public system, can I not make any changes with respect to this to make some money? And let me make this clarification right now. Even though it is just transaction details, even if you're trying to modify a small part of it, let's say even a single transaction, if you're trying to modify, it does not get implicated as part of the blockchain. And this is mainly because of how effective the hash function is. Apart from this, we also use a peer-to-peer network wherein we maintain the ledger across every system which is part of the blockchain. This in turn completely ensures the consistency of the ledger. So let's say even if you're making a certain transactional modification in your system, this does not get implemented across the blockchain system because majority of the people who are part of the blockchain system actually have the original copy. And even if you want to make the modification system permanent as part of the blockchain system, you need to have at least 51% of the resource that is part of the blockchain system. Now, to make it quite simpler, now if you want to make a modification with respect to any data present in the blockchain, then you need to have more than 51% of the global resource associated to the blockchain. And as I had mentioned, blockchain is something that is distributed throughout the world, and is something that involves millions of people. So imagine having more than 51% of the resource that is being used by millions of people. A huge number, right? And this is exactly why blockchain system is highly secure as well. Apart from this, the blockchain program in itself has various protocols which ensures that any tampering or any change with respect to the blockchain system is not allowed. So we'll be talking about each one of them one by one. Let's talk about the cryptographic technologies here. So as I had mentioned, you're using a public key cryptographic here. Here basically you're going to use two keys. One is going to be private and the other is going to be public. Once you've encrypted your data using the public or the private, you can decrypt this data using the other. Now basically what happens as part of the blockchain system is that you send the details of the sender, that is you, as well as the receiver, along with the amount of bitcoins that has to be transferred. And this completely gets hashed to give you a specific hash value. Apart from this, there's also a digital signature, which is again a hashed value combination of your private key as well as the amount of bitcoins you're sending. So what you need to do is that you need to decrypt both these values and compare them. Once this is correct, then you can be ensured that this data has not been modified. And as I had mentioned earlier, this encryption is so secure that even if you change a specific semicolon or a comma that is associated as part of the key, then it makes a huge change with respect to the hash value associated. So there itself it identifies that this has been tampered and this transaction is not correct. Okay. Then you have the peer-to-peer network. Now again, peer-to-peer network is the collection of different nodes associated in the blockchain system. Here you might be wondering what exactly is a node. Node is anyone associated with the blockchain system. It can be me, it can be you. But to give you a general idea, anyone who's associated with the blockchain system is called a node. Now there are different kinds of node and we'll be talking about them as part of the next session. But just to give you a simple idea, we are a complete node. That is, anyone who has the complete blockchain downloaded to their system and has the complete ledger as well is referred to as a full node. Apart from that, there are also special nodes called miners. Now miners are basically the people who validate our transaction as well as work on building a new block. Now remember the term of miner because this is something that is important and we'll be talking in the upcoming slides. Now coming back to our peer-to-peer network, let's look at the example here. Let's say A or Andy here identifies that there's a transaction between Bobby and Cindy where Bobby is sending Cindy 5 bitcoins. Now what happens is once he's identified it, then what happens is A broadcasts it to both B and C that it has been verified. Bobby has enough balance to send it to Cindy, so you can go ahead with the transaction and I approve of this. Apart from this, once Bobby and Cindy have got the green signal, they in turn will transmit this verification signal across to all the nodes that they are connected to, and this keeps getting propagated throughout the network. So this is one of the major factors that helps when you're in part of a peer-to-peer network. You don't have to manually send it to every signal. When you send it to one specific node, they'll keep propagating it to all the nodes that they're connected to. Okay, clear till here? Any questions with respect to the first two factors? Okay, so I've got a question here from Deep. Deep is asking me what exactly was the digital signature. Deep, I'll come back to that. We'll be talking about that in the next slide. Don't worry. Okay, Ajay has another question here. Ajay is asking me what exactly gets propagated here. Okay, Ajay, so what gets propagated here is a digital signature telling everyone as part of the network that a transaction has been taken place and the ledger needs to get updated. That is, you need to deduct 5 bitcoins from Bobby's account and it has to be updated in Cindy's account. So that's exactly what gets propagated and everyone who's part of the blockchain gets this propagation data. Okay, does that answer your question, Ajay? Okay, Ajay has another question here. Ajay is asking me, can I not modify this signal and propagate it? Okay, that's a very good question, Ajay. So let me clarify this. Okay, so let me take an example here itself. So let's say as part of the propagation, one of the nodes, in this case, let's say this node, I'll call it D and I'll call him Dave. Okay, so what Dave does is Dave gets the signal that Bobby has transferred 5 bitcoins to Cindy. Okay, now what he'll do is that he'll try to modify this. He'll try to make it such that instead of Cindy, it should go to him. That is 5 bitcoins have to be transmitted to Dave instead of Cindy. Okay, now as you can see, there's already been a propagation that takes place. Now what he is trying to modify is the signal that is coming from Bobby. But at the same time, let's say here E, let me call it Eddie. Eddie has a signal. Okay, let's say Ajay, you're part of the blockchain, so I'll call this AJ. Then Let me add Frost here. Frost is F. Okay, so what happens is D, he modifies. D is Dave. He tries to modify this signal that is coming to him, and he'll send the updated signal to S, that is Shilpa here. Okay, so there's also been a signal coming from Dave to Shilpa. Okay, so this propagation takes place. This is the modified propagated signal. But then what happens is Shilpa gets two signals. One is coming from Ajay, okay, which has the correct data that is being propagated by Cindy. That is 5 bitcoins has to be transferred from Bobby to Cindy. But at the same time, she's also getting another signal from Dave that says 5 bitcoins has to be transmitted from Bobby to Dave. Now this leads to a conflict. So what happens is she requires a clarification with respect to that same. When you look at the actual transmission, only Dave is the one who's got the modified transaction details. But everyone else who's part of the blockchain network has the correct details. That is, the transaction has to be between Bobby and Cindy and not anyone else. So what happens is this false transaction gets neglected. That is, this transaction gets neglected and the correct transaction gets stored as part of this ledger. Does that answer your question now, Ajay? Are you clear with respect to how it works out? Okay, that's great to see. So any other doubts with respect to how the peer-to-peer network works? Are you guys clear with respect to the same? Okay, it's good to see that you have followed till here. Now apart from this, as part of the peer-to-peer network, we use a distributed ledger. Now to help you understand how the distributed ledger works, let's take an example here. Now here what happens is Andy is giving Bobby $10, Bobby in turn is giving Debbie $3, and Debbie in turn is giving out Cindy $1. Okay. Now if you're storing this on a central ledger, there's just one copy and this is something that is not accessible to everyone. Let's say something happens to the central copy. Let's say it gets damaged, or if someone modifies this, then it becomes problematic. But if you're using a distributed ledger system, everyone who's part of the system has a copy of this, thereby in itself ensuring that even if the one copy present it gets corrupted or gets destroyed, there is no problem and everyone else part of the system has a copy. Even if, let's say, Andy loses his copy of the ledger, he can request it from Bobby, Debbie or Cindy. Or let's say Bobby doesn't want to pay back Andy the $10, he just tries to modify what is part of his ledger. Then, so Andy can check with Debbie and Cindy and ensure that the distributed ledger cannot be modified as such. So I hope you guys are clear with respect to how the distributed ledger system works, how it's better than the existing central ledger system. Okay, so I have a question here from Rahul. Rahul is asking me, can anyone actually download the distributed ledger for blockchain system? Definitely, Rahul. Now all you need to do is that you need to sign up to BlockChain and then you can download the complete blockchain, which has the complete transaction details back from 2009 till date. Okay, so this is completely accessible to anyone and all the transactions which are part of the blockchain is completely viewable by the public. Does that answer your question, Rahul? Okay, that's great. So moving forward, let's try to talk about the digital signature. Now this is one of the major reasons which ensures that the transactions in itself cannot be modified or tampered with. Now what happens is you first feed the data, which basically has the public key of the sender, public key of the receiver, as well as how many bitcoins has to be transmitted into a hash algorithm. This in turn will give you a specific value of hash which you're going to encrypt using the private key. Once that gets encrypted, then you're going to add it as a digital signature to your document. Now, as we have discussed earlier, this document has the public key of the sender, public key of the receiver with the number of bitcoins and the digital sign network. Then you broadcast it across the peer-to-peer network, waiting for someone to verify this. Once you have broadcasted it, it is going to be received by a special node. What their job is to actually take the data present in the document, hash it, and as well as decrypt the digital signature and hash it as well. If the hash values that is obtained from decrypting as well as hashing the data present, then you compare these two hash values. If they are the same, then you can ensure that this is a valid transaction and has not been tampered with. So are you guys clear with respect to this, how this works out? Yes, Tyson, you can definitely decrypt using the private key as well, but what you need to do is that you need to encrypt it using the public key. So as we have discussed, this is an asymmetrical process. If you're encrypting using the public key, you can decrypt using the private key. If you're encrypting using the private key, then you can decrypt using the public key. Okay, that's great. So moving forward, let's talk about the blockchain program in itself. Blockchain basically was an implementation or a solution which ensured that the transmission of bitcoins can happen as well as different decentralized cryptocurrencies can use the same solution to establish a parallel transaction system. Apart from this, blockchain concept can be implemented using any programming language that you wish, and blockchain originally was written using C++ and Java. Today has evolved into different programming languages. But again, the most popular and preferred programming language to write the blockchain program is Solidity, and this is one of the most secure programming languages as well. Okay. Now what we'll do is we'll try to discuss how a Bitcoin transaction takes place and what are the different steps involved in this. Before that, are you guys clear till here? Any doubts still here? Okay, James seems to have a question here. James is asking me, can anyone create a blockchain? Definitely, James. Now, if you've attended our previous session on blockchain tutorial session, there what we have done actually is that we have created a private autonomous blockchain and we have tried to execute a certain transactions as part of the blockchain. So you can check out our blockchain tutorial session to get a better understanding of the same. Okay, that's great. So let's try to understand how a Bitcoin transaction takes place. But before that, I'm quite sure all of you must have the question as to what is a Bitcoin. Bitcoin was the first decentralized digital currency introduced in the market. As I had mentioned earlier, it was Satoshi Nakamoto in 2009 who introduced the concept of Bitcoin and blockchain together. Another major thing is that it uses various cryptographic technologies to control its creation and management. Now, what do we mean by creation and management? Now, it is a digital currency. So you might be wondering, can't anyone just create it as per their requirement? The answer to that is no. To create a Bitcoin is not quite easy. It is not something that one single entity can do. Now, this is mainly because the various cryptographic technologies and mathematical algorithms associated with creation of Bitcoin gets complex day by day. Now, there is a limited number of Bitcoins that you can create, and that is being believed to be 21 million Bitcoins. Now, what happens is that if we do not put this restriction on the creation and management of Bitcoins, then it becomes problematic and we over-exhaust this. Now, if there was no specific restrictions, then what would happen is maybe over the week, over the next week, or even today itself, people would have mined all the 21 million Bitcoins. And as on date, close to 14.5 million Bitcoins have been mined. It's only because of these restrictions with respect to the creation of Bitcoins has this process been decreased. Because every given day, there are new people who get involved in the creation of Bitcoin system, and the resources that are pooled in the Bitcoin creation system keeps growing day by day. So these controls that are being added to the creation and management are something that ensures that the last Bitcoin gets mined only by 2140. Are you guys clear? Okay, Shilpa is asking me, how do you keep control? Okay, Shilpa, to give you a better idea, there are a lot of mathematical problems that you need to solve, as well as you need to work with different algorithms. So the complexity associated with all this keeps changing on a regular basis. So over a fixed time, what happens is all the miners associated in creation of Bitcoins come together and decide on the complexity that needs to get modified. And this is something that is more like a democratic situation where everyone has a vote. So based on the vote of majority, the complexity is set and accordingly it is being planned. But as I had mentioned, with the growing complexity, it is believed that the last Bitcoin is only going to be mined in 2140. Does that answer your question, Shilpa? Okay, that's great. Now, apart from this, all the Bitcoins are created and held electronically into a peer-to-peer open ledger system. That is, the Bitcoins, even though are created, are going to be held as part of the ledger system itself. And this ledger is completely peer-to-peer. Everyone who's part of the network gets a complete copy of this ledger. And this whole system, the whole system of peer-to-peer network is known as blockchain. Finally, when we talk about the ledger in itself, this is something that gets produced by solving mathematical problems. So this is what I was talking about earlier. So you have to solve different mathematical problems to create a new block which has the complete transaction details, and that requires a different amount of resources. So again, it's not quite easy to create a new block or modify an existing block, and this in turn ensures that the ledger as well as the blockchain system is highly secure and immutable. So are you guys clear with respect to what is the Bitcoin? Okay, so Deep seems to have a question here. I like Deep's question. Deep is asking me, why does the value of Bitcoin change? Okay, Deep. So let's take it this way. If I have to speak statistically, in Jan 2017 itself, the value of Bitcoin was close to $1,100. Today, that is on 7th July, it's somewhere close to $2,800. Now this is mainly because of the belief that people put in a system. Now the more people invest into the system, the more the value keeps changing with respect to that same. So Bitcoin is something that runs around a no trust system where you don't need to put your trust on a third party, and is something that is governed by mathematical principle. Okay, so this in turn increases the value, and the more the number of people come into the system, invest their money and help the system grow, more will the value of Bitcoins and blockchain keep growing day by day. So does that answer your question, Deep? Okay, Ajay is asking me, can anyone purchase Bitcoins? Definitely, Ajay. We'll be talking about how you can purchase Bitcoin and from where in the demo part. There will also be seeing how you can transact using Bitcoins. So I request you to be a bit patient. Okay, Ajay? Moving forward, let's try to understand how a Bitcoin transaction takes place. Now let's take an example here where James has to send Kevin 500 Bitcoins. Okay. Now the transaction is something that's going to be part of a new block which is going to be validated by miners known as Lisa and Robert. So if you guys remember, we had earlier discussed about miners. So these are special nodes whose roles involve validating transactions as well as creating new blocks for the blockchain system. Okay. Now what we'll do is let's try to look at the ledger in itself. So this is what a sample ledger looks like. Okay, every transaction holds the details of the transfer currency from one account to the other. That is, in the transaction details, what you'll be specifying is who is sending to whom, as well as how many Bitcoins are going to get transferred as part of this transaction. Okay, here you're not going to store the balance explicitly. What do I mean by not storing the balance explicitly? So let's take an example of your current bank account. Here what happens is there's a complete history of your credit and debit that gets processed, and then a current balance that is shown with respect to that same. However, in the Bitcoin blockchain system, you do not hold a balance sheet. But there are certain cryptocurrency systems like Ethereum which hold an account-based balance system, but Bitcoin blockchain system does not hold the balance explicitly. So you might be wondering, how do I know if a person has sufficient balance? So what you do is that you check the blockchain to see at any point does this person have sufficient balance to initiate this transaction. Let's say one of the transactions part of the blockchain is where someone else is sending James 500 Bitcoins. So that means I can be sure that he has enough balance to send it. So what you do is you check the complete transaction history that is associated with James to see if he has sufficient balance. Okay, are you guys clear? Okay, that's good to see. Now here what we'll do is that we'll consider the third entry that is part of the ledger to be James. So let me just add a J here. So this is James and this is Kevin. Okay, so as you remember, James has to send 500 Bitcoins to Kevin. So what happens? 500 Bitcoin should get deducted from James's account and has to get updated into Kevin's account. So once this transaction is validated, then the ledger also gets updated with respect to the same. So earlier where it was 1,342 and Kevin had $12, it gets updated to 1,842 and Kevin's balance gets updated to 512. Okay, so here explicitly balance is not stored. This is something that gets calculated every time the Bitcoin transaction gets recorded. Okay, this is just to give you a simple idea of how things work out as part of the blockchain system and how the ledger works. Okay, now to give you an overview of how the transaction as a whole works out is that first James initiates a transaction request. Okay, simultaneously miners who are called as special nodes try to validate this transaction. Okay, so whichever block has this transaction detail, they try to validate it. That is, does James have sufficient balance? And they both are basically trying to solve the same problem, so they are a race in between them as well. Okay, once they have identified that he has sufficient balance, that is the block gets validated, then the money gets deducted from James's account and gets added to Kevin's account. Now here what happens is, since each transaction has to get validated, this ensures that the problem of double spending does not occur. Okay, so even if he tries to falsify by sending two transactions, since each of the transaction gets validated one by one by the miners, the issue of double spending gets solved. Are you guys clear? Okay, so Tyson is asking me what happens if each of the miners get one of the transactions. That's a very good question, Tyson. So we'll take that up as part of the next session, where we'll be talking about how double spending gets solved as well as how a blockchain system validation takes place. So there we'll be talking about how the transaction gets validated in detail as well as how the problem of double spending completely gets annihilated. Okay, but since you have asked this question, Tyson, let me put it very simply for you. So what happens is that both of them actually validate one of the transactions, which is maybe 1 in a million case where both the transactions are verified and validated at the same time, and this gets created to a new block. Then what happens is they start to propagate it as part of the network. So that way everyone gets one copy of transaction that is being validated by Robert, the other by Lisa. Now whoever creates the next block, whichever block they have used previously, that is, if they have used Lisa's block, then the transaction approved by Lisa becomes valid and the transaction approved by Robert does not become valid. So this in turn eliminates the problem of double spending. I know it's not very clear. We'll be talking about it in the next session as I have mentioned. But I hope you've got a simple overview. Okay, that's good, Tyson. Now again, I expected this question from you as to why would miners actually validate these transactions. Now, we had talked earlier about a transaction fees, but in the blockchain system, the transaction fees is quite minimal. So validating a transaction in itself is not quite helpful. But for miners who create the new block, they get an incentive of 12.5 bitcoins. So if you create the next block of the blockchain system, you get an incentive of 12.5 bitcoins as part of a reward. So this in turn is a huge amount. So going by the present rate, this is somewhere close to $35,000 for just mining a new block. Easy way to make money, right? Now, it may seem a huge reward to just mine a new block, but it's not quite easy as you think. Given today's resources, no individual can completely mine a new block. Okay, so that's exactly why you come together to form something known as a resource pool, where different miners come together, form a group, and then try to solve the next mining block. Based on how much resource they have all put in to mine the new block, the reward gets distributed as such. So even if, let's say, 5 miners have come together and mined the new block, each get 2.5 bitcoins. Now when you say 2.5 bitcoins, this is close to almost $5,000 to $6,000. So that's quite useful, definitely. So as I had mentioned, given the individual resources, no single person can mine the new block as well. But the Bitcoin system definitely rewards you for helping out the transaction as well as mining the new block as such. Once the new block gets created, it becomes the permanent part of the blockchain, and as we have seen, the blockchain system keeps growing and new blocks keep getting added to it. So any doubts still here? Okay, so James is asking me, where does this Bitcoin get stored? So James, you have a special wallet called a Bitcoin wallet which can be used to store these Bitcoins. Now basically there are 4 different kinds of wallets. Now I'm not going in detail right now. We'll be talking more about this as part of the demo. So basically you're going to use a special wallet called Bitcoin wallet to store these Bitcoins. So all you need to do is that you need to give the private key where the Bitcoins have to be transacted. Once you do that, you can get the Bitcoin reward once the mining is complete. So Deep is asking me, can I mine Bitcoins using my computer? Definitely Deep, but again, as I had mentioned, it's not quite feasible for a single user to mine a Bitcoin. Now there are a lot of things that you need to take into consideration. Okay, you need to take into consideration amount of electricity that you're going to be spending. You need to take into consideration amount of resource that you're putting. Okay, even the processor as well as RAM that you're investing in computing is another major factor here. So again, there are a lot of things that come into picture. So what I would suggest is you check out the Bitcoin feasibility calculator, which is available online, where you have to just enter certain details and then you can see how feasible it is for you to mine Bitcoins. But again, as I had mentioned, mining using your system is not quite feasible. Okay, you have special devices known as Bitcoin miners which are used for mining Bitcoins. Okay, Deep is asking me, how is a Bitcoin miner different from our system? So to put it quite simply, basically is the difference between the processor. Your Bitcoin miner uses a specific kind of processor which makes it easy for you to solve the mathematical equation and mine the Bitcoin resource. Now I'm not going to go too much in detail with respect to this. We'll be talking about this in our next session, where we'll try to mine Bitcoins using our system first and we'll try to mine it with using a Bitcoin miner second. Is that okay? Definitely. Great. Moving on, let's try to understand how a Bitcoin transaction takes place on a higher level. Okay, so what happens is someone actually requests for the transaction. So you can either send a transaction to someone else or you can also request a transaction. When you do this, it gets transmitted across the peer-to-peer network. That is, everyone who's part of the system gets the detail with respect to sender's public key, receiver's public key, as well as how many bitcoins has to be transmitted. Once this gets validated, then this validation signal gets propagated throughout the network and it gets added as part of the new block. Once the new block gets added to the blockchain system, then it also gets verified and a transaction complete signal gets sent to the user. Okay, so I hope you guys are clear with respect to the flow of the blockchain system. Any doubts with respect to what we have discussed till here? Okay, it's great to see that you guys have followed till here. So now let's talk about the various blockchain features. Now in any blockchain system, all the transactions which are validated get included as part of it. Now the information here basically is the time at which the transaction is taking place, the date on which the transaction is taking place, the people involved, as I had mentioned here, the public keys, as well as the amount that is being sent with respect to that same. All these information with respect to every transaction is stored. Again, you might be wondering, how can you store so much data? So again, all of this gets combined and hashed to get a specific value, which in turn gets stored as part of the block. Now each node has a complete copy of the blockchain. So as I had mentioned earlier, once you sign up for the blockchain network, then you can completely download the blockchain system, thereby ensuring you have a complete copy of the blockchain distributed ledger. Apart from this, as I had mentioned, miners are special nodes who verify all the transactions associated with the block by solving various mathematical puzzles. Now again, you might be wondering what this mathematical puzzle is and how is it solved. So for that, we'll talk about it in the next session, which completely deals with blockchain mining and blockchain verification. Also, the mathematical principle associated with blockchain completely ensures that all the nodes are automatically and continuously in a state of agreement with each other. That is, all the values which are present as part of the blockchain are same with respect to everyone who is part of the blockchain. So again, as I said, this is mainly because of the mathematical as well as cryptographic techniques involved in creation of a new block as well as verification and validate. So even if you try to modify one specific transaction or even a block as a whole, it is not quite possible because everyone who's part of the blockchain has the complete copy. So even if you try to change, it is not completely reflected, as we had seen our previous example when we are talking about the peer-to-peer network. Now, there are mainly three types of blockchain that can be implemented. The first is a public blockchain. Now here, everyone who's part of the system can completely view the ledger as well as add a new block of transaction. That is, you can verify any transaction and add the new block. Okay, an example of this is the Bitcoin blockchain system as well as the Ethereum, Dash and Fatcom blockchain system. Now these are different cryptocurrencies that are being used throughout. Then you have private blockchain. Now here the difference is that all the permissions, that is to either validate or add a new block, is kept to a central organization. Only people who are part of this organization can view and add transactions, but generally what happens is people in the internet are allowed to view this. But this is not the case always. There are certain organizational blockchain wherein you can't see it unless you have the required permission. So it's not completely accessible to the public as well. One example of this is multi-chain, and you also have Blockstack, which is another popular private blockchain. Then you have something known as a consortium blockchain. Consortium blockchain is somewhat between the public and the private blockchain. Here what happens is that the control is not completely restricted to one central authority, but with selected groups of nodes who have the access to either write or add a new block. But again, the ledger as itself is something that can be viewed by the public or can be restricted to people who need access to this. Okay, and examples for these are Ripple and R3. So depending on the needs, an organization can set up one of the three types. So who can give me an example of these three systems apart from what is mentioned here? You can take your time, think about it and give me an example with respect to the three. Where do you think these different kinds of blockchains can be used? Okay, banks can be private and consortium. That's a good answer, Tyson. What do you think about a public blockchain? See, you don't need to restrict your thoughts just to the banking domain. Now, as I had mentioned to you, blockchain is something that is growing beyond the banking domain system as such. Financial monetary system is just a tip of the iceberg. There are different domains. Now, if I have to give you examples with respect to that same. So let's take an example of a supply chain blockchain. Here what happens is that you can establish a consortium or a private blockchain wherein only people who are on the governing board can decide to modify others. But anyone who's associated to the blockchain can see the complete details. So even your suppliers as well as your demanders can actually get an idea of what is happening with the goods, where exactly it is, and which stage of the whole process is it. Now, one example of the same system is IBM's blockchain system, which has made a drastic change with respect to the supply chain market as well. And to know more, you can check out IBM's video on IBM blockchain, where you'll get a complete idea of how blockchain is being used by them. Now, another idea with respect to the consortium blockchain that I can give you is with respect to the healthcare system. So what few organizations are trying to implement is that they're trying to establish a consortium blockchain where people with selected access, mainly doctors, can view the complete records of patients which is present in the blockchain. So this ensures that if a customer is admitted in a different hospital, you don't need to completely send his record details across. He can directly access it from the blockchain given enough privileges, and it ensures that this is not completely tampered as well. So try to think about different domains where blockchain can be used apart from banking and the domains I have mentioned. So tomorrow when you come back for your next session, I hope you guys have a few answers at least. Okay? Definitely, that's good to see that you guys are interested. Okay, now moving forward, let's try to look at blockchain use case. Now, as I had mentioned, monetary system is basically just tip of the iceberg. Blockchain is something that is being used across different domains. Okay, now one major domain where blockchain presently is being used is supply chain management. Apart from that, blockchain is also being used for the election system. Okay, so here what is happening is that using the digital signature, anyone can sign into the blockchain and cast their vote, thereby ensuring more number of people come in and vote for their candidates, as well as vote frauds do not happen. Apart from that, these are some of the different domains where blockchain can be used. Let's say in terms of industry flows, you can change the way you interact with your suppliers. You can also identify your real-time capacity. You can even have a peer-to-peer trading system. So your network service management can improve, your demand side management can improve. Again, your self-service maintenance, your asset inventory tracking, all these are different domains where blockchain can be implemented to improve the efficiency as a whole. Now, as I had mentioned, your assignment for tomorrow is to identify at least 5 domains where you feel blockchain can be implemented and improve the existing system. Okay, so please do not pick up any of the domains that we have discussed as part of this session. Okay, that's great. Now let's move forward to the last topic of today's session, that is the blockchain demo. Now what we need to do is that we need to implement a digital transaction between different Bitcoin wallets. What we need to first do is that we need to set up one desktop wallet, that is 𝐤𝐥, as well as we need to set up one online Bitcoin wallet, that is blockchain. Once you've established these two wallets, we are going to perform a transaction between both of them, and then finally we'll verify. Okay. First, what you need to do is that you need to set up your desktop wallet 𝐤𝐥. So for that, all you need to do is go to 𝐤𝐥.io and download the digital wallet. So this is your 𝐤𝐥 homepage. All you have to do is just click on get 𝐤𝐥 free and you get redirected to the download page. Okay. Now here what you need to do is that you need to just select your device. Since I'm using a Windows system, I'm going to specify Windows and it's going to download. Now it's quite easy for you to install 𝐤𝐥. I'll be showing you how to install 𝐤𝐥 as well. So first go ahead and download this wallet. Great. So now that you have set up your 𝐤𝐥 wallet, let me just show you how to install blockchain wallet as well. So for that, just go to blockchain website and here just click on the option get free Bitcoin wallet. Okay, so this is going to redirect you to a new page for signing up. So first start by giving your email ID, then specify a new password. So once you've specified your password, just click on I have agreed the terms and click on continue. So this in turn will give you a wallet identifier. Always store this number. So this is quite easy for you. What you need, all you're going to see is welcome. So your wallet is getting created automatically. So it's quite easy process. Okay, so now what we'll be doing is that we'll be initiating a transaction between my Bitcoin wallet to my 𝐤𝐥 desktop wallet. Okay, so let me just show you how it's done. So as you can see here, there's a specific amount that's already loaded into my Bitcoin system. As to how you can purchase Bitcoins, there are different sites for you to purchase Bitcoins. Now, if you are in India, there are different sites. I would recommend that you use either Zepay or localbitcoinbuyer.in. But again, as I had mentioned, you just need to Google up and you can find different websites that will help you purchase Bitcoins. Okay, now what we're going to do is that we're going to send this complete amount from my blockchain to my 𝐒𝐥𝐿 wallet. Okay, so here you can either specify a request to receive amount or you can send it directly. So what I'll do is I'll send it, and what is going to ask me is that it's going to ask me the private key. So for that, come back here, you can copy this from here and just paste it. So now let's say I need to specify the amount. Okay, so what I'll do is I'll specify the complete amount that I have, that is 0.12, and then immediately it tells me what is the maximum fees I can send. So just click on it, and this is the maximum fees that I can send. Now if you see, the standard transaction fees that is added to this is just 4 rupees. Okay, I'm sending almost close to 2600 and it's asking me a 4 rupees transaction fees. So this helps you identify it better. Okay, apart from this, let's say if you have to perform this transaction on a priority, then you have the option of setting it on priority. But that means I have to again reset it, and then here you can see that the estimated time also changes. This gets confirmed between 0 to 60 minutes and is taking again a transaction fees of 41 rupees. So it's not much when I consider the standard transaction fees that banks take. Okay, so what I'll do is I'll set it on priority and I'll initiate this transaction. Okay, just click on send bitcoins and the transaction is being processed. Come back to 𝐒𝐥𝐿 and let's wait. Now if you see here, the transaction has been added and my Bitcoin wallet has been updated with respect to that same. But there's one thing here, it tells me that this transaction is not confirmed. That is, there's a specific time that it takes for it to get confirmed. So this has to be verified and validated and has to get added to the blockchain, and only then will this transaction get confirmed. So again, as we see, this had been set as a priority and it may take somewhere close to 1 hour at max to get confirmed. Now this is just the maximum situation. There are times where it gets confirmed instantaneously as well. Okay, so let's just keep waiting. Now one thing you can do to check the status is to go to this arrow mark here, and you can see 3-block confirmation is still pending. So to get more info, just click on this and you'll get redirected to the page which gives you the update with respect to the status. So here you can see it requires 3 confirmations with respect to that same, and it's still not yet confirmed. So if you click on view tree chart, it will show you how the transaction is being converted and how it has to get verified. So let's wait for the final confirmation. Okay, so if you see here, the transaction has been confirmed, and if you check in 𝐒𝐥𝐿, you can find the Bitcoin wallet has been updated with respect to that same.
Let's take a look at the working of a blockchain. The working of a blockchain revolves around 3 basic components, which are blocks, miners, and nodes. We just discussed what blocks are. Now, let us understand what miners and nodes mean. A blockchain node's main purpose is to verify each batch of network transactions, which are nothing but the blocks. A full node is basically a device that contains a full copy of the transaction history of the blockchain. Miners can be defined as accountants who record every transaction to the blockchain. Proof of work is important if you want your transaction to be valid. Miners are the ones who keep the record of your transaction. Hence, they are the record keepers who keep the system updated on new transactions and existing ones. Let us see the working of a blockchain. First, the transaction is requested by any one of the users. Each user has their own private key and a public key. Using these both, a secure digital identity is created to authenticate the user through digital signatures. Once the transaction is agreed between the users, it needs to be approved. For a public blockchain, the decision to add a transaction to the chain is made by consensus. This means that the majority of the nodes or the computers present in the network must agree that the transaction is valid. The people who own the computers in the network are made to verify the transactions through rewards. This process is known as proof of work. Next, a block identifying the transaction is created. This block is then sent to every other participant or miners in the network. The miners then validate this transaction and receive a reward in terms of cryptocurrency. Only after all these processes are successfully done, the block is added to the existing blockchain. This update is distributed across the network and the blockchain gets updated. Now that we understand the working of a blockchain, let's take a look at some of its advantages. Accuracy of the chain. Transactions on the blockchain network are approved by a network of thousands of computers. This removes almost all human involvement in the verification process, resulting in less human error and an accurate record of information. Cost reduction. As blockchain eliminates the need for third parties and middlemen, it saves enormous cost for businesses. The cost and effort spent on documentation and its revision are also saved as everyone gets to view a single immutable version of the blockchain. Decentralized network. One of the biggest advantages is the decentralization of the network. Blockchain does not store any of its information in a central location. Instead, the blockchain is copied and spread across a network of computers. Whenever a new block is added to the blockchain, every computer on the network updates its blockchain to reflect the change. By spreading that information across a network, rather than storing it in one central database, blockchain becomes more difficult to tamper with. Efficient, private, and secure transactions. Transactions placed through a central authority can take up to a few days to settle. But with blockchain technology, transactions can be completed in as little as 10 minutes and can be considered secure after just a few hours. Many blockchain networks operate as public databases, meaning that anyone with an internet connection can view a list of the network's transaction history. Although users can access details about transactions, they cannot access identifying information about the users making those transactions. Transparency. Most blockchains are entirely open source software. This means that anyone and everyone can view its code. This gives auditors the ability to review cryptocurrencies like Bitcoin for security. This also means that there is no real authority on who controls Bitcoin's code and how it is edited, making it transparent to all of its users. Now that we understand the advantages, let's take a look at some of the use cases of blockchain. Banking and finance. With blockchain, banks also have the opportunity to exchange funds between the institutions more quickly and securely. Currency. By spreading its operation across a network of computers, blockchains allow Bitcoin and other cryptocurrencies to operate without the need of a central authority. This not only reduces risk but also eliminates many of the processing and transaction fees. Healthcare. Healthcare providers can use blockchain to securely store their patients' medical records. When a medical record is generated and signed, it can be written into the blockchain, which provides patients with the proof and confidence that the record cannot be changed. Real estate. Blockchain has the potential to eliminate the need for scanning documents and tracking down physical files in a local recording office. If property ownership is stored and verified on the blockchain, owners can trust that their deed is accurate and permanently recorded. Voting. Blockchain can be used to facilitate a modern voting system. Voting with blockchain carries the potential to eliminate election fraud and boost voter turnout.
I'll give you an analogy to help you understand how does this blockchain is going to work. So let's take an example and let's take up the bank. Okay, suppose we've got someone and her name is Alice. Okay, we've got an Alice and Alice wants to send the money to a Bob. And what she's going to do, she's going to do a wire transfer, or you can say she's going to send the payment through NEFT and she's going to send the payment to the Bob, and she is sending through the bank and assuming that she's using the NEFT payment method. That is what she's doing. Now what is happening in this scenario is
all of her money, that is all of this Alice's money, is stored inside the bank, which has actually two primary purpose. One, it keeps track of how much money she actually has. And another thing is, this bank, it also provides an online portal which allows her to perform the wire transfer to Bob. So whenever this Alice authorizes the wire transfer or authorizes the NEFT transaction from her Indian cents, her bank is going to process the transaction and it is going to transfer the money from her account and credits the Bob's account. For example, if she is sending 1000 rupees, so 1000 rupees will be deducted from the Alice account and 1000 rupees will be credited to the Bob account. Now here, behind the scenes, the bank has actually two primary technical features which makes it possible. One, if I talk about this bank, okay, I'll do one thing. I'll open up my OneNote so that I can explain you in a better way. So we've been talking about Alice. So we've got a lady called Alice and we've got Bob, and she's planning to send 1000 rupees to Bob, and in order to do this, she is currently making use of bank. And when she does the transaction, so 1000 rupees will be deducted from the Alice account, 1000 rupees will be credited to the Bob's account. Now we are talking from the bank's perspective right now. From the bank's perspective, in order to make this happen, the bank behind the scenes, it basically has two technical features. One, it has got database. So this database is a place where the bank maintains a database ledger of all the Alice's transaction to determine her current account balance and the transaction history. Let's say the Alice has got her salary and she decided that she spent everything on her shopping. Now all that shopping, everything that is being done to ensure that money is debited, money is credited when she's getting the salary, every transaction is being maintained in my database ledger. So in any instant, it is going to have an updated information over there. And also this bank has a network. So this bank has a network as well. So the bank, it actually uses the network to process the wire transfer or the NEFT transfer so that the funds can be transferred from her account to the Bob's account. Because there can be a scenario where the account which Bob has, it might not be present in the same account. Let's suppose this Alice, she has an account in SBI, and if I have got this Bob is having an account in ICICI Bank, so it has to use some kind of a network to send this amount from SBI to the ICICI Bank. So this is what a network is all about. Now here, with this network, it gives, with the help, like when I say network, it's like the overall benefit that we have. You can think of them as a front end as well. So with this front end, it will give the online portal to Alice so that she can connect to that online portal and she can also send that money to the Bob. Now, when we talk about the blockchain, this blockchain presents an alternative to this model by eliminating the bank altogether. So in order to transfer from my account to the Bob's account or from Alice's account to the Bob's account, with the help of this blockchain, I don't require a bank itself. Now, what I'll be doing in this scenario? So instead of sending the money to Bob via wire transfer, what she can do is she can send him the cryptocurrency directly with a blockchain. So she can send cryptocurrency. Okay, she can send cryptocurrency where she can send directly to the Bob. Much like the bank, this blockchain gives her a place to safely store her funds and also send money to the Bob. So what exactly it is doing is, primarily it is replacing the two primary technical features of the bank, that is the database and the network. So the database which keeps track of how much money Alice has, and the network where the Alice can connect to a blockchain in order to send the money. When she does, the blockchain processes her transaction and moves the funds from her account to the Bob's account. And these two things, which she was doing with the bank, now she can do it with blockchain as well. Because this blockchain, it serves both these roles. It will take care of database as well as the network. So you can think of this blockchain as a network and a database at the same time. So this is the basics of this blockchain technology. So I wanted to give you this example so that you understand what exactly is this blockchain is, because as we progress in today's session, we will be defining it in an like in a theoretical manner, and I'll try to simplify it as much as possible. But I hope you now have a basic idea behind what exactly is happening in the scenario of this blockchain. I can say that this blockchain is a peer-to-peer network, meaning it is a system of nodes or computer where all of these nodes can talk to one another. Okay, so that is what this blockchain is all about. Here I'll have my Alice. So Alice, and we have got Bob. Alice connects to a node. Okay, I'll call this as P2P network or peer-to-peer network. And she connects to node, and then the Bob is going to receive the money. So the same thing will be happening over here. So it's like we've got the computer worldwide and it is replacing the bank. And this peer-to-peer network is responsible for processing the transaction so that the Alice can send the money to Bob. So she simply needs to connect to a node which is present on the network to initiate her transaction, and the blockchain, it handles the rest behind the scenes. Okay, it handles the rest behind the scenes. So at the end, Bob is going to receive the money. Okay, so this is what a high level introduction to this blockchain. So let's get started and let's see what do we have as part of our today's agenda. As part of our today's agenda, we will be learning what is this blockchain, the applications of blockchain, the technology stacks of blockchain, and I'll try to give you an overall idea about how you can set up your system, which is at a very basic level. So that's what we'll be doing in today's session. All right, so let's start by understanding what exactly is this blockchain. So we've been talking about the story where Alice, she wanted to send the money to the Bob. Now I have mentioned that instead of using the bank to complete the transaction, she can send the money with the help of Bitcoin, and she can make use of peer-to-peer network. She just has to connect to the node. Instead of logging into her net banking portal, she just have to connect to the node. Instead of initiating as an EFT transaction in her internet banking, she just has to initiate a transaction in this P2P network. Okay, and here when we talk about this blockchain, so you can think of them as a database, and you can think of it as something like a server or a network. So it does the both things. So this is what we have learned right now. Now here when we talk about this blockchain, okay, as I mentioned, so Alice, so she's interested in sending the money to the bank. Now let's understand and let's examine some of the functions and its function like a database. How does this blockchain functions like a database? So here in this scenario, especially on this blockchain, each node on my network, it actually maintains the copy of the data on the blockchain. For example, they all know as how much money Alice has in her account. So what it means is, instead of bank storing all the data inside a central database, the blockchain stores it redundantly on each node in the network, which makes it virtually impossible to tamper with the data. Which means, just think about it, guys. In the scenario of bank, okay, in the scenario of bank, everything is stored in a central database. I'm not saying that it can happen, but I'm just think about hypothetically. If that central database is lost, or if someone changes the value over there in the central database, I mean, there's a chance of tampering the data over there. But when it comes to blockchain, here this blockchain stores the data redundantly on each node in the network, which actually means it's virtually impossible to tamper with the data. Which means this Alice, she cannot modify or she cannot manipulate her account balance, because all the other nodes know how much money she really has. Let's suppose if she changes her account balance in her system or in her node, she cannot prove it that that is her account balance, because it will be stored in other nodes as well. So this is what one of the main feature where blockchain functioning like a database. Okay, so this is what this blockchain, guys. Now let's go ahead and let's understand what exactly is this blockchain. So when we say blockchain, people think that blockchain and the cryptocurrency are the same thing. I mean, like whenever we talk about Bitcoin or when we say blockchain, people will think that Bitcoin and blockchain both are same, or in general cryptocurrency and the blockchain both are same. Well guys, I want you to remember this: blockchain and the cryptocurrency, they're not the same thing. Now this Bitcoin that you have seen or that you have heard, which you might have heard and come across, it's actually a cryptocurrency. But blockchain that we have, it is the underlying technology behind this Bitcoin. So blockchain is the technology behind the Bitcoin. So these blockchains, they can be used for other purposes beside these cryptocurrencies as well. So usage in the cryptocurrency, it's one of the application of blockchain. Okay, it's one of the applications of blockchain, but that's not the only thing. So it's just saying that if you have a motorbike, going to the office is not the only thing that you can do. So you can use that motorbike to travel to your hometown, to go to a grocery shop, or just to roam around the city. You can do multiple things, isn't it? So you cannot just simply label that you can use the motorbike only to go to the office. So that's how silly it sounds when we say cryptocurrency and blockchain both are same. So blockchain is like a technology, and this is actually behind the cryptocurrency. Okay, now that you are clear about what exactly and the difference between the blockchain and the cryptocurrency. Okay, so if I want to describe this blockchain, okay, if I want to describe this blockchain, here what I can say is the blockchain is actually, it can be called as a spine of this entire cryptocurrency system. Here, one of the benefit of this, like a blockchain, is this blockchain technology not only helps with the users perform the transactions using cryptocurrencies, but it also ensures the security and the anonymity of the users who are involved. Now here, in the scenario of this blockchain, it is a continuously growing list of records, and we call it as blocks. And these blocks are linked and secured using this cryptographic techniques. So a single blockchain, it can serve as an open and a distributed ledger, which can record transactions between two parties in a verifiable and permanent way. And this ledger is shared among everyone in the network, and it is public for all to view, which means this brings in the transparency and the trust in the system. So this blockchain is a new way of implementing any solution or a use case, guys. Here, it's actually a concept which can be implemented by any language, and solidity is the most preferred default whenever we are writing the programs in blockchain. Okay, now here in this term of blockchain, whenever we say it as a block is actually the current part of a blockchain which records some or all of the recent transactions, and once completed, it actually goes into the blockchain as a permanent database, and each time a block gets completed, a new block will be created. And as I mentioned already, this blockchain is typically managed by a peer-to-peer network. So collectively adhering to a specific protocol for validating a new block, and once it's recorded, the data in any block cannot be altered retroactively without the alteration of all the subsequent blocks and the collusion of the network majority. Which actually means that suppose if any transaction is actually once stored in blockchain, it means they are actually permanent. They cannot be hacked or manipulated. And these are some of the main features of this blockchain. So if I want to define it right now with all the learnings and small bit of information that I just gave you, I can now say that blockchain is an immutable distributed ledger, which is used for recording the transaction, tracking the assets within the network of businesses. It's a form of storing the information which prevents anyone from changing, hacking, or cheating it. The intangible assets would include the intellectual property, patents, copyrights, and other brand assets. So this is what a blockchain is all about. It's actually a structure, I can say, which stores this transactional records, and we call this transactional records known as blocks. And it is it will be of public in several databases, and which is actually known as chain in a connected network through peer-to-peer nodes. And typically this storage of this records which is public, we call it as a digital ledger. Okay, so this is what a blockchain is all about. And coming to this transactions in blockchain, so here in every transaction in this digital ledger which I'll be doing will be authorized by a digital signature of the owner, which automatically authenticates the transaction and also safeguards it from tampering. Hence, the information the digital ledger contains is highly secure. So you can think of this digital ledger is like a Google spreadsheet, which is shared among numerous computers in a network in which the transactional records are stored based on the actual purchases. And the fascinating angle is that anybody can see the data, but no one can corrupt it. Now, that's the best part about this blockchain transactions, which is a digital ledger. So all transactions, including the information on the time, date, participants, amount of every single transaction are logged, and each node in the network owns the full copy of a blockchain. So this is what the blockchain transaction is all about. So as I mentioned, so these blockchains are verified by the miners who maintain the ledger after solving the complex math puzzles. And the mathematical principle ensures that the nodes automatically and continuously agree to the current state of the ledger and every transaction inside it. And if anyone attempts to corrupt a transaction, the nodes will not arrive at a consensus, and hence it is going to refuse to incorporate such transactions in the blockchain. So these are some of the key features when it comes to blockchain transactions, which prevents in tampering or corrupting the data. Okay, now let's have a look at the applications of this blockchain. Here, when I talk about and when I quote back the example, that is the Alice sending the money to the Bob. So suppose you're sending your money to the family or friends from your bank account, or this Alice sending to the money to the Bob. You'll have to log into the internet banking and transfer the amount to the other person using their number. Now, when the transaction is done, the bank is going to update the transaction records, and it's very simple. But here, there's a potential issue. As I mentioned, these transactions can be tampered with in a quick manner. People who are actually familiar with this, they can actually make use of some third-party rules. And along with that, here So they'll be able to like there's actually a vulnerability is present, and because of this blockchain digital ledger, so here because of this, the record keeping of the data and the transaction are actually the since this record keeping and like handling the transactions are actually a crucial part of any business. So this information till now it was actually handled in-house, and sometimes it was actually passed through like brokers, bankers, or lawyers, which will actually increase the time and the cost for the business. Now, with this blockchain technology, it actually helps the businesses in avoiding the long process, and it actually facilitates the fast movement of transaction. And as a result of this is actually gaining the popularity because it is helping the business in saving both time as well as money. Okay, so let's have a look at the applications of blockchain. Now, when we talk about this traditional application, as I mentioned, guys, you'll have a front end, and using that front end, you are going to do something and it is going to update your server. Might be, or like you may not be directly doing it, or you may call the API, or API is like is from the backend, it's going to update the server. And this is what happens in the traditional application scenario. And if a person, or if someone who is into this hacking, or like who is aware of it, how it everything happens, so there is a high chance that it can be tampered in a quick manner. So that is one of the serious issue that we have into the current application. Now, with the help of this blockchain, with the help of this digital ledger, since the ledger is stored in a redundant manner in various nodes, it is not easily like possible to perform the corruption. So this is one of the main advantage of having this application as a decentralized. So because of this benefit of this decentralized system, so what it does is here, if I talk about a traditional system, not from the decentralized system, traditionally you would actually need the approval of regulatory authorities like government or bank for performing any transactions. Now, with this blockchain, you can actually do the transactions with the mutual consensus of users, resulting in smoother, safer, and a faster transaction. And that's one of the main benefit of this decentralized system. And here, another main advantage over here is it's highly secure, because this blockchain uses a digital signature, and this feature is used to conduct the fraud-free transaction, which actually makes it impossible to corrupt or change the data of an individual by the other users without a specific digital signature. And another benefit I would say when it comes to working with blockchains, guys, automation capability. So this blockchain technology is programmable, and it can generate the systematic actions, events, and payments automatically when a specific trigger has been met. Okay, so these are some of the key features I would say when it comes to blockchain. Now that you have understood about what exactly is this blockchain, some of the key features of it, let's have a look at the technology stack when it comes to blockchain. See, the blockchain operates on a technology stack, which would include the user experience. It will be an UX. Okay, it will be a UX where it will take care of user experience, and will have an application layer. And in the bottom, we'll have the blockchain protocol. In the blockchain protocol, we'll have some cryptography, which is nothing but the consensus rules. We'll have the P2P computer network, which includes nodes, mining, and tokens. And we also have a distributed ledger, which takes care of transaction record. And along with that, to connect everything is actually connected with the help of internet, which is my TCP/IP infrastructure. So this is how a technology stack of a blockchain would look like. So first thing is internet. See, The internet is actually a foundational technological layer. It's a network of networks where we'll have a global interconnected devices. It will be computers, smartphones, IoT devices, which relies on this internet protocol suite, that is TCP/IP, and defines how data should be packetized, addressed, transmitted, routed, and received. Okay, and on top of this, we'll have the blockchain protocol, and this blockchain protocol operates on the internet through the peer-to-peer network of computed devices that we call it as a node, which executes the protocol, completing the transactions on the basis of the cryptographic consensus algorithm. And along with that, this transactions will be completed on the identical copies of my distributed ledger of these transactions, and everything is actually hosted on a P2P network of devices. Okay, so what this blockchain protocol, what it actually builds is, it actually builds an open, shared, and trusted public ledger of transaction, which is not controlled by any single entity. So these recorded transactions cannot be changed, and it can be inspected by anyone. Now, then we have an application layer. So the first and the best known blockchain application, I can say it as a Bitcoin. So Bitcoin has actually developed on native blockchain protocol, and for most of its existence, except for recent changes which were introduced in the form of forks, guys. Okay, so this Bitcoin network, it actually led to the development of decentralized autonomous organization with the disintermediation in the transfer of value as currently seen in centralized financial structures with national or regional bankers or settlement agencies and financial intermediaries. So what we do is, like in this application layer, we'll have the application, guys. Okay, and that's what you can remember for a simple understanding. And coming to the user experience, so here we have the continued development of dApps. dApps is one of the new term, especially is used in the blockchain technology. dApps is also known as decentralized application, which are accessed by a specialized dApp browser on a device of our choice. So you can search more on this dApps and dApp browsers, guys. So that's how the overall technology stack of my blockchain would look like. So one of the main advantage when it comes to using this decentralized application or dApp is, so here one, it is an open source, and the another advantage is decentralized consensus, and there is no central point of failure. So these are some of the main features of this dApp, that is decentralized application. Okay, and here it is autonomy, so you're the one making the agreement. There's no need for a broker and a lawyer. The documents are encrypted on a shared ledger. The backup on the blockchain, your documents are duplicated many times over. And accuracy, so on smart contracts are not only faster but cheaper, and they also avoid the errors that arise from tedious manual work. So these are some of the important advantages of decentralized applications. Now, on the basis of blockchain, we see variety of companies have started producing the services and everything, guys. We've got BlockVerify. So BlockVerify is actually a solution which is based on blockchain. And here, this is an anti-counterfeit solution, which is going to help in identifying the counterfeits, non-duplicable, company verify, and it's a global solution. So this is one of the application, I would say, or a product from the blockchain technology. And here, some of the things that this BlockVerify can verify are, it can actually verify the counterfeit goods, diverted products, stolen merchandise, and fraudulent transactions. And we've got Ripple. So this Ripple is, I would say, like it's also a service. So here talking about this Ripple. So RippleNet is actually a network Yes, it's actually a network of institutional payment, guys. And this is a decentralized global network of banks and payment providers. And here in this scenario, so like various banks and money services business use this solution developed by Ripple to provide frictionless experience to send the money in a global manner. So this helps us in reducing the issues that we had faced earlier, that is costly. And now as a result of this, it's more reliable, very fast, ease of access, and main important security. And another feature is its low cost. Okay, next we've got StoreJ. Okay, we've got this StoreJ. Now this StoreJ is actually a fast, secure cloud storage at a fraction of cost. So that's what the official documentation of this StoreJ would say. It's an open source decentralized file storage solution. It actually makes use of encryption, file sharding, and blockchain based hash table to store the files on a peer-to-peer network. So as a result of this, the data will be private. No one can access it because you are getting the shard ability, and it's relatively fast because it is present on the P2P, and it is relatively cheap. And here, yes, you can shred the data. It is going to it has an amazing encryption. The data is distributed, and you can also perform the audit as well. So these are some of the key benefits of this StoreJ. Next, we've got Augur. So Augur is actually a decentralized prediction market program or a platform, and this has been built on the Ethereum blockchain. So as per I've read last time, I think this has been built by the Forecast Foundation. It was founded in the year of 2014, guys. So here it's a prediction market control owned and operated by the people that use it. So weather prediction, political forecasting, company forecasting, and event hedging. So these are some of the predictions that it can do. Okay. Now that you have seen some of the important solutions that we already have right now from the blockchain, and you have seen the importance of blockchain whenever you are starting your learning journey, especially one of the trending topics right now, which is in the industry, it's always recommended that you follow an approach which we call it as a structured learning approach. Here at Edureka, every course follows a structured learning approach, and this is a learning approach which is recommended by industry experts. Now, using this in a structured learning approach, you'll be able to progress from level 0 to level expert. Yes, you'll be able to progress from level 0 to level expert, because this is a learning journey where you'll be having with the industry expert who'll be with you in every step of the way. As part of your blockchain certification training program, in the first module, you learn about origin and the working of this blockchain. This is followed by an hands-on session, and in the second module, it's around the cryptocurrency and the blockchain. Okay, and in the third module, you'll be learning about Bitcoin platform. The fourth module, it's around Bitcoin mining. Fifth module, it's around introduction to Ethereum. Sixth module, you'll be learning about basics of solidity, and you learn about advanced solidity in the seventh module. In module 8, you learn to get an idea about developing a decentralized application using Truffle. And in module 9 and 10, you will learn about Hyperledger and how to create and deploy your private blockchain on a multi-chain. So this is how your learning journey would look like when it comes to structured learning approach at Edureka. As you can clearly see, this is a program which will help you to become job ready, that is industry ready in the technology of this blockchain. Okay, now moving on. So if I want to talk about some of the places where blockchain technology is used. So we've got 𝐓𝐿ANS. So 𝐓𝐿ANS is one of the job market job market platform, so which is actually working completely on Ethereum blockchain with 0% service fees. So it's a future of higher work for Ether cryptocurrency. So it has got 0% service charge. It's free and it's decentralized. So it's actually a first kind of a job market platform for connecting the freelancers and the developers with its employers. And the best part is the entire database runs completely on Ethereum. So this is about the 𝐓𝐿ANS. So as a result of this, they say only cuts, no cuts, only savings. So 𝐓𝐿ANS doesn't take a percentage that you earned. So the amount of Ether the employer pays is the amount the freelancer gets. Okay, and the best part is there's no artificial cost or restriction. Everybody can apply for or create an unlimited number of jobs. So all that is needed is to pay the Ethereum gas fees associated with these operation. So that is how you'll be paying, guys. So as part of our learning journey in today's session, you have seen what exactly is this blockchain, how is it different from the traditional operation. And when we talk about blockchain, I gave an example as how it works as a database as well as a network. Then we have seen some of the applications of blockchain, and we took a few examples to distinguish between blockchain. And one more thing that we have understood is blockchain is not equal to Bitcoin. So blockchain is a technology behind these cryptocurrencies.
Let's get started with why you should become a blockchain developer. First and foremost, you may consider the demand and job opportunities available for blockchain developers. According to an article by LinkedIn, after the cryptocurrency bull market of 2017, there has been a meteoric rise in demand for blockchain developers and blockchain engineers. Hence, if we look at the job opportunities in India for blockchain developers, we have more than 4,500 vacant jobs, and in the US, even higher than 11,000 jobs. If we consider the tech hubs in these countries, Bangalore alone has 2,300 jobs and California has more than 2,600 vacant jobs. This data is based on an analysis conducted using Indeed and Glassdoor. So the competition is not too high to get in a job as a blockchain developer. One factor that may interest you to become a blockchain developer is the pay. In India, a fresher is paid about 6,33,000 rupees per year, and in the US, the pay is as high as $120,000 annually. This again is based on an analysis using LinkedIn and Glassdoor. So this is the average for freshers. With increase in experience, the salaries shall increase too. With the right skills, you may get the opportunity to work in top-notch companies such as Deloitte, Accenture, TCS, Capgemini, IBM, Tech Mahindra, and Amazon, among others that are hiring blockchain developers. So wait no longer to get started in this lucrative career. Next, let's see who exactly is a blockchain developer. Blockchain developers are developers who work on developing and optimizing blockchain protocols, designing the architecture of blockchain systems, and creating smart contracts and web applications that use blockchain. The reason why they are in demand is because they strongly help organizations. Automatic execution. Using programmable transactions, blockchain technology streamlines business processes, which enables real-time clearing and settlement. Digital asset management. Blockchain rapidly creates and manages digital assets and instruments. Production grade. Blockchain enables to manage a compliant blockchain platform at scale with zero downtime. Trusted business networks. Blockchain deploys permissioned networks with shared business logic and customizable governance with ease. Advanced security. It also provides tamper-proof data coordination and granular security controls to mitigate risk. So no wonder why blockchain developers are in demand. Hence, as a blockchain developer, your roles and responsibilities would include collaborating with managers to determine blockchain technology needs and functionalities, creating application features and interfaces by using programming language and writing multi-threaded codes, applying the latest cryptology techniques to protect digital transaction data against cyber attacks and information hacks, maintaining client and server-side application while also optimizing and securing blockchain applications by integrating new tools and technologies, educating sales personnel on blockchain features that allow secure digital payments, and documenting blockchain development processes and complying with best practices in data protection. Make sure to keep up with the current blockchain technologies and cryptography methods. Now let's look into the skills required by a blockchain developer. For that, let's look into a job description to get the real skills that are looked out for. In this JD posted by Capgemini, they are looking for experience in developing blockchain application, experience in platforms such as Ethereum, programming in languages such as C, Java, JavaScript, knowledge of cloud platforms and virtualization using Docker, cryptography most importantly, as well as building POCs and creating prototypes. But why stick to one job? Let's look at few more. This job description was posted by Encore. There again we can see the requirements of POCs, Ethereum Solidity, application development, blockchain development, smart contracts, Ethereum framework, some knowledge of cloud infrastructure as well as programming in Golang, Solidity, Java, Python, etc. Similarly, in the job description for blockchain developers as posted by Slice, we can see smart contracts, deploying, managing, and developing applications, especially blockchain applications, and some programming skills in Solidity or Go. To sum it up through all the mini job descriptions, we see that the skills required by a blockchain developer includes cryptography, especially in cryptocurrency, knowledge of blockchain architectures such as consortium, private or public, smart contracts, programming in languages such as Golang, Java, C++, Python or JavaScript, knowledge of data structures, experience with web development, blockchain frameworks such as Ethereum, and of course some organizational skills. With the skills in mind, now let's understand the learning path to become a blockchain developer. Just like any other career path, to become a blockchain developer, you need to follow a certain roadmap. Start off by getting a degree. Though it's not necessary, but it is preferred to have graduated in BE or BTech. Next, earn the desired skills. As we just talked about the skills required, go and learn them now. If you are looking for free resources, check out Edureka's YouTube channel that provides in-depth video lectures for you to understand. If you are more of a reader, you can also check out the blogs by Edureka, where so many are devoted to blockchains alone. Next, go ahead and get some hands-on experience in blockchain development. You may code and create your own smart contracts, create your own distributed application on Ethereum platform using Solidity, as well as invest in Bitcoin or other cryptocurrencies that employ the concept of blockchain to understand how the system works. Also, to combine all these steps and get a well-defined learning path, you may get certified in blockchain. Check out the blockchain certification training course by Edureka, which covers all the required skills. It is specifically designed for working professionals to take up the classes on weekends. There is 24/7 support from Edureka. The instructors have 10+ years of experience in working as blockchain developers themselves. Luckily for you, there are no prerequisites to take up this course. Everything is taught from scratch. And also, you have lifetime access to the lectures to come back and revisit the course even after you finish. So go ahead, start your journey to become a blockchain developer today.
So first of all, we're going to be taking a look at the traditional way normal applications or web services work. So firstly, a web service has two parts. Firstly is the client, and then the client connects to the web server. Now this web server is very centralized and it's owned by a certain company that is actually hosting all the web services. So anytime you want to use any of the services hosted by this particular company, you have to send a request to their server, in which the response they will give you the requested service. Now, what does this centralized server actually contain? Well, it contains two major things. Firstly is the API, and secondly is the data. Now, the API is mostly all the services and all the endpoints that are actually being served by the hosting service. That may be any company like Facebook, Google, Twitter. And the second part is the data part. Now, this is the most important part for you as a user, because any of the data that you are also creating, that is user-generated content, is also being stored on their centralized architecture. So what does this actually mean? Well, when these two things are actually being owned by big major companies, they have the right to do anything with your data. So however, they may be advertising your privacy protocols, like Facebook says that they will never use any of the user-generated content for their own business. But that's kind of not true. Facebook earns a lot from ads that is actually being directed towards you because of the interest that you show on Facebook. So if you show some interest on clothing, you'll definitely get some ads related to clothing. So how is that not using user-generated content for their own purpose? Well, some of you might not agree with this whole agenda of privacy and how it works. Well, you don't actually need to, because the main problem out here is that it's a central point of functionality. So if a hacker actually wants to penetrate through to their system, he only has to actually concentrate on one point, and that is the main server. So if that is actually hacked or somehow compromised, all your data, all the APIs and all the endpoints, everything is compromised in a process. So this is how traditional applications works, and these are the shortcomings that come with the traditional applications. So the invention of decentralized applications mostly promised to deal with all the problems that come with the centralized architecture. So let's see how a decentralized application actually works. So firstly, you have the user who invokes a smart contract. Now, if you don't know what a smart contract is, you can check out my smart contract tutorial, where I've told you all everything that you need to know about smart contracts and most of its development part. Now, the smart contract will contain all the rules abiding for the service that is being provided, and it also contains state information which contains data for the smart contract. Now, you must be also thinking that in a centralized architecture, the hosting and other peripherals is taken care of by the hosting company like Facebook. So when you are going on Facebook server, you do not actually have to pay for any computation because Facebook is doing that already. Now, Facebook also takes a part of your money and now Facebook also takes a part of your data and converts it into more profit, but that exactly doesn't really happen in a decentralized network. So how is computation being paid for in a decentralized network? Now, the computational resources that is required, it is paid in gas, which is the unit that is used in the Ethereum network. I'm going to be using the Ethereum network for per se as an example. So gas is the way you pay for resources when you are using a decentralized network. Other than that, you're also paying a small amount of fee called a transaction fee. Now, this transaction fee is actually collected by the miners who are validating these blocks. This transaction fee can actually vary from around 1 or 2 Ether or even its smaller denominations. Now, every miner who validates a block also gets paid by the network in terms of Ether. So every miner probably gets around 1 to 2 Ethers nowadays. And every block only takes 14 seconds. So that's how currency is also being generated in the network. Now, what happens next is all this money that you need for your transaction is being fetched from your wallet, which is your Ethereum wallet. Now, your Ethereum wallet is used to manage your funds and invoke different contracts. So that's all you need to keep in mind when a wallet is told to you all. Now, after all this invocation has been done, and all the state changes have been made and the miner validates the block, all this information is then sent to the network, and the network then updates your wallet with the new and updated funds that you have. So this is basically how a decentralized application works. You are going to invoke a smart contract. Now the smart contract changes some stuff on your account, and all these resources that you use are paid for you and by the network itself. So you're basically not depending on anybody else. Now let's see the technology stack that is normally used in the development of decentralized apps or dApps. So the front end is made mostly using the normal way, that is HTML, CSS, and JavaScript. But you can also use any of the majorly available frameworks like Angular, React, Vue.js to actually create your front end, because your front end will be interacting with the smart contracts through the Web3 API. Now, the Web3 API is what lets you connect to the smart contract that is residing on the decentralized network, and the decentralized network can also talk back to your application through the means of events. We'll be talking about events when we get into the app development part in future videos, But for now, all you need to know that smart contracts are written in Solidity, and the front end is written however you want to wish, actually. Now, Web3 is available in JavaScript, Java, Go, and Python. And we'll mostly be referencing the JavaScript part, that is the web3.js. So we'll be using web3.js when we're actually developing some kind of app in the future. So don't forget to check back in. Now, let us just go over the advantages of decentralized applications or blockchain applications that come along with it. So firstly is autonomy. So it's autonomous because you're the one making the agreement. There's no need for a broker or a lawyer of any sort or any sort of third party for that matter. Secondly, there's a lot of trust because all your documents are encrypted using modern technology and modern encryption methods, and it's all sharded and distributed on a decentralized network, which is being run by a shared ledger. So there's literally no way anybody can break into it, now at least, unless quantum computing becomes a very big thing in the next 6 months or something. Thirdly is backups. On the blockchain, your documents are duplicated many and many times over. Your documents are owned and seen by everybody on the internet, but in an encrypted fashion. So you do not need to worry that, oh, somebody has my copy, so they might be able to see it. It's not like that. It's all encrypted and only you can see it. But a copy does exist. So in case you actually lose some of it, you can always go back and check your transaction IDs and get back what you just wanted. Last but not the least is accuracy. Now, whatever these smart contracts are trying to replicate, so things like bidding, form completion, and such things, mostly done by clerical workers. So most clerks actually tend to make a lot of mistakes because this work is generally very tedious manual work. But since we're talking about computers, there is no chance for any sort of mistake unless there's bad code, in which case it's normally a bug which is fixed by the developer in no time. So accuracy, backup, trust, and autonomy. These are the major advantages of decentralized applications that is severely lacking in most centralized architectures. So now that we've seen how decentralized apps work in comparison to traditional apps and the advantages of using a decentralized architecture for most service providing apps, so let's go ahead and see some of the most interesting decentralized applications or applications running on the blockchain that have been developed till date. So firstly, we have BlockVerify. Now, one of the most significant problems that the business community faces globally is counterfeit products. These counterfeit goods and products lead to billions of dollars in losses every year. However, the blockchain could offer a solution to these issues. BlockVerify is a project that seeks to harness the blockchain to fight the counterfeit industry. With the blockchain, BlockVerify is confident that they can monitor the entire supply chain with complete ease. According to those behind BlockVerify, the only way to improve anti-counterfeit efforts is to utilize the blockchain. To achieve this, they are using a private blockchain which is highly scalable, transparent, and tamper-proof. Every product will be given a unique identification number that is then stored on the tamper-proof blockchain. So basically, BlockVerify can help you identify counterfeits, non-duplicatables, company verifiables, and it also offers a global solution in the method. Now, anyone can be able to access this number on the blockchain to verify whether a product is genuine or not. So with the solution, things such as medication or anything else can be verified with ease using this solution. Anyone can be able to conduct the verification utilizing this technology. So what all can BlockVerify do? Well, it can help you identify counterfeit goods or diverted products or stolen merchandise and even fraudulent transactions. Okay, so that was all about BlockVerify. Moving on, we have Ripple. So RippleNet is a network of institutional payment providers such as banks and money service businesses that use solutions developed by Ripple to provide a frictionless experience to send money globally. So let's give an example first. So firstly, imagine there's a Mr. Jones who lives in New York and has a box of chocolates that he doesn't really need. Now he's very interested to watch a baseball game but doesn't have money for the tickets. Secondly, there's a Mrs. Smith who lives in Los Angeles and has a rare stamp and she would like to give away for a box of chocolates. Lastly, we have a Mr. Brown who lives in Alaska, suppose, and he's looking for a rare stamp and he has a ticket for a baseball game in New York that our Mr. Jones is very much looking for. Now, in our current system, these people would probably never find each other and remain with their not valuable valuables. But in the Ripple world, they could say, hey, I have a box of chocolates and I want baseball. And the system will look for a shortest and cheapest combination to make it happen. Moreover, the platform allows you to make payments in any currency, including Bitcoin, and has a minimal internal transaction commission of around $0.00001. Yes, that's the right amount of zeros I just said. And the only reason it's not free is to only prevent DDoS attacks. So the current system for transactions is pretty much unreliable, expensive, and slow. Unreliable in the sense that a transaction can take days to actually get committed to the bank. It's expensive in the process as to how many people you need to pay to get your transactions done. And it's very slow as a whole overall. Now, what Ripple does is it promises to actually remove all this by making transactions very much accessible. Like I just said, that you can exchange cookies for a baseball game, something like that. And it's very, very fast. Oh my God, Ripple is amazingly fast. You have no idea how fast Ripple can be. Secondly, because it runs on the blockchain, of course, it's reliable. And as I just said, Ripple has some insanely low costs. And it's only not free and low cost because we need to prevent those DDoS attacks. Up next on our list of blockchain applications is 𝐶𝐸. So 𝐶𝐸 is an open source decentralized file storage solution. It uses encryption, file sharding, and a blockchain-based hash table to store files on a peer-to-peer network. The goal is to make cloud storage faster, cheaper, and private. Now, the traditional cloud storage solutions like Dropbox or Google Drive has limitations. While files are backed up redundantly, bandwidth from a data center or unexpected outages can restrict access to your files. There's also this issue with privacy, and these companies have control over all your files, including the ability to access them. Now, the 𝐶𝐸 project uses blockchain and peer-to-peer networks to solve these problems. It distributes the files so redundancy is well established. It also guarantees you're the only one who can access the files because of the encryption. Now, the best place to understand 𝐶𝐸 is probably torrents. Now, in the near early 2000s, torrents became a notorious way to download movies, music, TV shows, and use them for free and illegally, of course. Now, torrents use a peer-to-peer network, and it works something like this. Mainly, users maintain copies of the same file all over the network. When someone wants a copy of that file, they send a request to the peer-to-peer network, and users who have the file known as seeds send fragments of the file to the requester. The requester receives many fragments from many different seeds, and the torrent software recompiles these fragments to form the original file. Now, the benefits of using a torrent is you can download fragments of a file from multiple sources in parallel. So this means the file transfer could potentially be faster than the downloading and the whole thing all at once from a single source. Additionally, for the purpose of pirated music and videos, torrents are decentralized. No company controls the torrent, so it's difficult to shut down a torrent. And the same could be said for 𝐶𝐸, but you can't say the same for Google Drive. So 𝐶𝐸 works in a similar way, except it's not for pirated music and videos. So let's take a moment to understand that. Firstly, there's some end-to-end encryption going on. This is where the data privacy goes to the next level. Sharding already adds one layer of privacy as no one knows which data to host and can read the whole file from, but even being able to read a shard of a file is problematic. It could still contain some sensitive information. So what exactly is file sharding? Well, the first way 𝐶𝐸 is similar to torrents is sharding. So this means your file is broken up into millions of pieces and distributed on a network. So that is where the distribution part comes in. And the fourth part is audit or file verification. So to answer this concern, 𝐶𝐸 completes a file verification audit every hour. In order to get paid, farmers or the people who are validating on the network have to prove that they have the shards they've been sent. 𝐶𝐸 sends a request to the farmers, and if the farmer has changed or deleted the encrypted shard, they won't be able to answer the request. So that's a pretty neat way to actually approach cloud computing and cloud storage using blockchain applications. So next up on our list of blockchain applications is 𝐸𝐵𝐿. So 𝐸𝐵𝐿 is a decentralized prediction market which can forecast the outcome of an event based on the wisdom of the crowd principle. So basically, it's a prediction market protocol owned and operated by the people that use it. So with this method, information collected from the crowd is averaged into the most realistic possibility and therefore the most probable outcome. Correct predictions are rewarded by the network, while incorrect, reported and penalized. And this incentivizes the truthful reporting of events. So 𝐸𝐵𝐿 aims to revolutionize the prediction market, and in doing so, changing the way people receive and verify the truth. Now, the main idea is to make more accurate predictions by large groups of people rather than a small team of experts. So 𝐸𝐵𝐿 is also the first major decentralized application developed using Ethereum and represents a major proof of concept for this underlying technology. Decentralization ensures that 𝐸𝐵𝐿 cannot be censored by governments that deem prediction markets as gambling, whilst ensuring the sustainability of the application. This decentralized nature ensures honesty in reporting an outcome of events using crowd wisdom to cancel out individual frauds. Now, Augur has been used for weather prediction, political forecasting, event hedging, and even company or business forecasting. And it's going pretty well in my opinion. So how exactly does Augur work? Well, Augur works on events. So an event occurs that is being wagered upon in a market created on the Augur network. Now the outcome results are reported by the reputation holders to Augur in 2 steps. Part 1 of this step is the reputation holders privately and securely submit outcome results to the network. And the part 2 is that about 1 month later, a second report is publicly submitted in plain text for all to see. Next, upon completion of reporting periods, consensus is achieved, leading to 2 financial events. Those who wagered correctly are paid out for their predictions, and honest and active reporters receive trading fees and proportionate with reputational holdings. And on the other hand, dishonest and negligent reporters lose a lot of their reputation points, which is redistributed to honest and active reporters. So this means that rep is only necessary for those wishing to report and not for those just wishing to wager. So all reputation tokens are available in the reputation software sale, and you can check them out at Augur's site. Now the last application that we're going to talk about is going to be something for you guys who are looking for jobs. So firstly, this is called 𝐓𝐿ance. Now 𝐓𝐿ance allows you to create an employee or employee profile and list and apply for open positions, ranks, and provide feedback for employers and employees, and send and receive invoices. Now 𝐓𝐿ance works on the Ethereum, and so it basically has 0% service charge, is decentralized, and there's no restriction, and has free membership. So something like freshersworld.com, where you are applying for jobs as a fresher, you mostly have to pay a certain amount of fee so that you get those invitations and interview call letters. But on 𝐓𝐿ance, you basically don't pay anything, and you are getting the best contacts as a freelancer. So basically, 𝐓𝐿ance is a first of its kind in the job market platform for connecting freelancers and developers with employers. Its database runs completely on the Ethereum public blockchain, and front-end source files are distributed on IPFS, or the Interplanetary File Storage System, meaning 𝐓𝐿ance is fully decentralized. So basically, there's no cuts and only savings. 𝐓𝐿ance doesn't take a percentage of what you earned from the connections that you made on 𝐓𝐿ance, and the amount of ether that the employer pays is the amount the freelancer gets. So that's a very, very big thing for freelancers. Next is there are no artificial costs or restrictions. For example, let me just quote Freshers World. So Freshers World says that you can join for free and you'll get all those interview letters, but that's actually a sham, because you will be needing to pay that really pro version payment option that they have. So you will have to buy that if you want to get those premium companies calling you for your CV, even though you might be actually a very good coder. So basically everybody can apply for a job on 𝐓𝐿ance or create an unlimited number of jobs. All that is needed is to pay for the gas fees that is associated with these operations. Okay guys, so in the end we saw how decentralized applications are developed, the technology stack that is used, basically HTML, CSS, Web3 API, and Solidity, and how decentralized applications compare to traditional applications. And then we saw a few very good examples. In the upcoming videos, I'll be teaching you guys how to create your very own simple decentralized application by interacting with the Web3 API. So please hold on your thoughts for those.
Why do we need a blockchain wallet? Now, first thing that comes to your mind is, why do we need a specific Bitcoin wallet? Now, again, what you need to understand is that Bitcoin is a digital cryptocurrency. So to handle these cryptocurrencies, to store them and as well as manage the transactions, initiate the transactions as such, you need a specific type of wallet. And that's exactly what your blockchain wallet is. Now, apart from that, most people usually have multiple blockchain accounts, okay? So each account correspondingly could have a different amount of Bitcoins present in it. Now, this is a general policy most people actually follow. Now, in that case, using the same blockchain wallet, you can store all these accounts and ensure that you have complete access to your accounts as well as balance. Apart from that, these blockchain wallets in itself help you instantaneously perform transactions. Now, once you have the address of the person whom you want to send the Bitcoins to, then it's just a matter of copy pasting it, specifying the amount of Bitcoins you want to send, and then just clicking on send. And the transaction in itself is quite instantaneous as such. Finally comes the concept of transaction. Now, always it's important that you keep a track of all the transactions that you do. Now, once we have linked all your blockchain accounts to a single blockchain wallet in itself, it becomes quite easy for you to keep track of all the transactions that you have performed. Now, take an example of online wallet like Blockchain Info. Here, all the transactions from when you have created your wallet are available. Now, this basically gives you a complete idea of how much you earned, whom you've sent to what, as well as all the references and the transaction details as well. Okay. Now, moving on, let's try to understand what exactly is a blockchain wallet. It's basically similar to a bank account. Okay, like how you have a PayPal account, how you have a bank account associated with Bank of America, ICICI, HDFC, and so forth. Your blockchain wallet also is equivalent to a bank account itself. Here what happens is you use this specific blockchain account or blockchain wallet to send, receive, and store your bitcoins as such. Okay, so again, similar functions to your bank account itself. Now again, how it is different is that instead of actually sending currency, here you're sending bitcoins. But the value of bitcoins is something that is not constant. It keeps changing with respect to the current value of bitcoins as such. Now, more people invest into bitcoins, more will the value of bitcoins increase. More people pull out from it, more will the value reduce as such. Now, this is one of the major contributing factors that decides the value of bitcoins as such. Because the Bitcoin and blockchain system is something that's completely built on no trust model. You don't need to put your trust on someone else to understand. Now, we need to understand that here more and more people invest into the system, more and more will the value keep growing. And this is one of the greatest contributing factors for the growth of Bitcoin. So it's grown over 650% at least in the past year itself. Great. Now, moving forward, let's try to understand the various features of a blockchain wallet. How does it separate it from the other wallets that are present in the market for storing digital currency? Now, the first and the foremost feature is the security feature. In comparison to most other digital wallets, blockchain wallets have multiple layers of security. Apart from that, even initiating a transaction involves certain levels of step. You're going to have to enter your PIN that is associated for the wallet. You may have to enter a passphrase if required. If it's a hardware wallet, you need to actually specify. You need to actually confirm the transaction on the hardware wallet and so forth. Again, in comparison to most other wallets out there, the number of security layers associated with a blockchain wallet is quite high as well. And apart from that, the blockchain system in itself is something that is completely built on various security techniques. So this ensures that even the transactions themselves are completely secure. But one thing you need to remember is that the transactions in a blockchain ledger are not reversible. That is, if you've initiated a transaction to a wrong person, then you cannot recover the bitcoins that you have sent. Always ensure that you're sending the bitcoins to the correct address. Apart from that, the next feature would be the instantaneous transaction feature. Now again, as I had mentioned to you, the transactions here are quite instantaneous. You don't need to wait for a long time for the transaction to complete or for a confirmation to come. Now if you work with bank transactions, there are times when you initiate a transaction but have to wait till the banking hours for the transaction to get completed and verified as such. But here the transaction can be initiated 24 hours and 7 days a week, and you don't need to even worry about the delay with respect to the transactions. Now, one major factor with respect to the blockchain wallet is that it lets you convert your bitcoins into different cryptocurrencies, as well as you can sell out your bitcoins into any currency that you want. Now, as for today's session, I'll be showing you how we can buy bitcoins using Indian rupees. Then I'll also show you how we can convert bitcoins to Ethereum on the blockchain info wallet. Finally comes the use of accessibility. Now, again, as I had mentioned, Bitcoin wallets are present in multiple platforms. Okay. You can have your wallet present on a piece of paper, it could be present on a hardware device, it could also be on your phone. So at any given instant, you have the complete access to your wallet, and it becomes easy for you also to check up your balance. You can also validate your transactions and immediately also initiate any transactions as per your requirements as such. Finally, let's move forward and talk about the various types of wallet that are present with respect to blockchain wallet. Now, it's essentially important that you understand the different types of wallet that are present, so that you can go on to decide which wallet suits your requirement as such. Now, the first category of wallets are based on the location of the private key. That is, where exactly is the private key associated to your wallet being stored. Now, when we talk about a hot wallet, this is basically a blockchain program wherein the private key is completely stored on a cloud-based server. So you don't need to worry about where it's being stored, because what happens is it's present on the cloud, and anytime you want to access it, you can go on to the website of the blockchain wallet and immediately access it as per your requirements as such. The second type is called a cold wallet. Now here how it's slightly different is that you have an application that runs on either your device or it could be a hardware wallet as such. What you need to do is that all the transaction related details, that is the private key, the sender's key, apart from that the amount, everything is going to get first hashed and only the transaction hash is going to get propagated throughout the network. So this ensures that the details with respect to the user is secure as such. Now in comparison to security feature, cold wallets are considered to be more secure than hot wallets because again you have the complete control with respect to your private key. But at the same time, in terms of accessibility, hot wallets are more easily accessible, as well as the speed of transaction with respect to a hot wallet is quite faster when compared to a cold wallet as such. Then you have based on the devices and clients. Let's first talk about the devices. You can either go for an online web wallet. Here what happens is the wallet is actually present online. That is, it's a web-based wallet wherein all your keys would be stored on a cloud-based server. Apart from that, you have mobile wallets. Now here what happens is usually the private keys are stored on your phone as well as it's linked to a web-based server. Now on the web-based server, based on the application, there would be a copy of the private key or it could just be stored on your phone, whereas the transaction details would be propagated on the cloud service. Then you have desktop wallets. Now desktop wallets are basically an extension to your cloud-based wallet. But what happens here is that it is actually a cold wallet rather than a hot wallet, because all the details with respect to your private key, your transactions, everything is stored on the wallet and is not directly accessible to a third-party professional. Now again, you need to understand that all the details are present on an application. It's only the final hash value that is going to get propagated through the cloud-based server or on the blockchain server itself. Finally, you have physical wallets. Now physical wallets is something like your security mission. You can have your physical wallet either present in form of a Bitcoin card. It could also be a paper wallet as such, where you're storing your Bitcoins in a piece of paper. Okay, now this is a simple example of how a paper wallet would look like, as well as a Bitcoin card. Now apart from that, physical wallets are also usually used to store Bitcoins for future purposes as well. So let's say you want to save up some Bitcoins in case of some emergency. Physical wallets are one of the best choices as such. Now moving on, let's talk about blockchain wallets based on clients as such. You can either have a software client wherein it could be a desktop application, it could be a cloud-based application, mobile application or so forth, or you can go with a hardware wallet as such. Now again, as I had mentioned, it's based on the user's requirement that you can choose one or the other. Now let's compare some of the most popular wallets that are present in today's market. Okay, so we are going to compare 5 of these popular wallets and each of them come from a different category as such. Now the first wallet that we'll be talking about is BitcoinCo. Now this was the core wallet introduced by bitcoin.org and is one of the most secure as well as stable wallet in the market today. What you need to understand is that while you're using this wallet, it completely downloads the entire blockchain. That is, you get the complete blockchain downloaded on your system. So thereby it becomes a very huge wallet. Given today's size, it's close to about 130 GB that gets downloaded when you're working with Bitcoin Core wallet. But with respect to the space and the memory constraint, also comes the feature of security, privacy and stability with respect to it. So this is one of the most popular wallets that had been initially introduced. Coming on to the next wallet, that is Tensor. Tensor is again one of the most popular wallets as a hardware wallet. Okay, now again with respect to hardware wallet security, this is again one of the major players in the market today, and it also comes with respect to a display as well as 2 keys which will help you verify, as well as adds another layer of protection for your blockchain wallet. Now again, when you talk about the security feature with respect to Tensor or any hardware wallet, it's very high in comparison to all other wallets. But again, with respect to ease of use, it's not that comfortable when you're on the go or when you want to immediately initiate a transaction. These are not very comfortable for that. Okay, coming down to the next wallet is Blockchain Info Wallet. Now, Blockchain Info Wallet is one of the most popular online wallets present today. It has close to about 8 million different users as such. Now, it also supports both Bitcoins and Ethereum and helps you convert your Bitcoins to Ethereum and vice versa, which we'll be seeing as part of today's demo as such. Now, apart from that, it also offers one of the cheapest transaction fees for initiating any transaction as such. Like, let me just give you an example. Let's say if you want to send about 2,500 rupees. On a non-peak hour time, it costs you somewhere about 4 rupees as such as the transaction fees. And at the same time, if you want to make the transaction a priority transaction, the transaction fee slightly increases to about 41 rupees. Again, this is very small fees that gets included when you see the overall transaction fees, with respect to the different forms of transactions that are available today. Okay. Next we have Electrum. Electrum is again a very popular desktop based wallet and is known for its security feature as well. Now, in terms of speed as well as simplicity, is one of the most popular ones as such with respect to desktop wallets. There are various features with respect to Electrum, so I would definitely recommend, if you're looking for a desktop wallet, this is one that you should definitely put your eyes on. But again, one thing you need to remember is that Electrum has slightly higher transaction fees when you compare with respect to the other desktop wallets as such. Moving on, Mycelium. Mycelium is one of the most popular mobile wallets which is present for both Android and iOS. Okay, here you have the complete access to your private keys and it does not leave your device unless and until you wish it to. So as I had mentioned to you, this is an example of a cold wallet. Here the private key details are stored on your device as such, and unless and until you want it to be migrated, it does not get migrated. Now there are people who want to constantly keep checking their Bitcoin wallets for an update with respect to the value of Bitcoin. So Mycelium also offers you an option of watch only address, wherein you can keep checking the value of Bitcoins associated in your wallet without having actually to log into your wallet as such. Okay, so I hope you've got a simple understanding with respect to the different types of wallets as well as the comparison between the most popular wallets in today's market. Now you can go on to choose whichever wallet meets your requirement, and for today's demo session what we'll be doing is we'll be buying Bitcoins using the 𝐓𝐵 mobile application, okay, wherein I'll be buying Bitcoins and then I'll be initiating a transaction from my 𝐓𝐵 mobile application to my blockchain info wallet, which is an online based wallet. There I'll also show you how you can convert your Bitcoins to Ethereum as such. Okay, so I hope you guys are definitely looking forward to this. Moving on, first what you need to do is that you need to go on to Google Play Store and download your 𝐓𝐵 application from Google Play Store. In case if you're looking to buy Bitcoins in India, then this is one of the best choices that I can suggest you with. Okay, so once you've done with that, let me just go on and show you how you can buy Bitcoins, and I'll give you a simple overview of how 𝐓𝐵 works. Now this is the 𝐓𝐵 Google App Store download page. Okay, so you can go on to download the application, and this is the Apple Store download link for 𝐓𝐵. Okay, now let me just show you how 𝐓𝐵 looks like. Now this is the 𝐓𝐵 interface on an Android application. Now since I am using an Android application, you can see this is how it looks like. Okay, so let me just go to the buy option here. Okay, now as you can see, I've already loaded some money into it. Let me just give you a simple overview with respect to the application before we go on. Okay, so if you go to the menu option here, you can see there are different things here. First thing that you need to do after you've installed the application is go to the verification option, and here what you need to do is that you need to provide your personal details as well as your PAN card details. Apart from that, you need to give your bank details. Now every time that you wish the balance amount, that is what the amount that you've gained after selling your Bitcoins to be transferred to your bank, then you need to provide the corresponding bank details. Apart from that, you need to provide your address details in case of verification as such. Now once you've completed the verification process, which usually takes a day to 3 days, then you have the access to buy and sell Bitcoins as per your need. Now first thing what you need to do once your verification is complete is that click on the deposit option to deposit a specific amount into your 𝐓𝐵 wallet as such. Okay, so you have two ways to transfer the money. Either you can use net banking or you can go with RTGS, NEFT or IMPS. Now I would recommend going through net banking because it's faster and you can definitely get started immediately. Okay, once you've done that, you can see the corresponding balance being reflected here. Now let me go on to buy Bitcoins as per my need. So if I click on buy option present here, then it's going to redirect me to the option to buy the Bitcoins. Okay, now one thing you need to keep in mind is that 𝐓𝐵 buys as well as sells Bitcoins on a higher rate when compared to the market present trends. Okay, this is mainly because they keep a buffer with respect to the current rates as such in case of a fluctuation with respect to that same. Now again, the minimum amount that you can buy Bitcoins for is 1,000 and it can go up to 10 lakhs as such. Okay, now what I'll do is I'll use the complete amount here. So let's say I'm going to use 3258. Okay, and then it's telling me I can buy 0.1 Bitcoin given the present rate as such. So let me just click on buy option and it is going to ask me for a security pin. Now this is another thing that you would be setting up while you're installing the application. Always ensure you remember your PIN associated with respect to your wallet. If I click, I specify my PIN as such, the transaction gets initiated and immediately the Bitcoins get added to my wallet. Okay, now if you can see, I had earlier 0 Bitcoins present. Now I have 0.1 Bitcoin present here. Now given at any instance I want to sell my Bitcoins, I can just click on the sell option and it's going to give me the present rate, and it tells me how much I can sell my bitcoins for. So if I click on sell all, it's going to tell me the corresponding value as well. Okay, now it's time that we initiate a transaction with respect to our 𝐓𝐵 application. Now for this, what I'm going to do is that I'm going to use my 𝐓𝐵 wallet, which has 0.1 Bitcoin, and I'm going to send it to my blockchain wallet. Now here, you have the option to either receive Bitcoins or you can send Bitcoins by selecting one of these two options. Now first thing I want to do is that I want to send Bitcoins. So let me just click on send. Now here it's going to ask me whether it's to a specific contact in my wallet or I'm going to specify the corresponding address. Now in this case, I'm going to specify the address. So I'm going to click the B icon present here. Once I do that, it's going to ask me for the name as well as the address. So here you can see the address has been specified. So let me just call this my wallet 1. Okay. Apart from that, most wallets these days also have a QR code associated for their wallets. So you can even scan the QR code rather than entering it manually. Okay. Now, once I click on the tick mark present here, you can see below here, it's going to ask me how many Bitcoins do I want to send. Now I'm going to click on send all. Okay, so here you can see it's taking a corresponding transaction fees associated for my Bitcoins as well. Earlier where I had almost 0.1 Bitcoins, now it's come down. This is because of Bitcoin network transaction fees. Now if you see here, these are the standard transaction fees associated with respect to the Bitcoins. They may change slightly depending on the traffic as such. Now once I click on send all option and I click on the icon present here, it's going to again ask me for the PIN. So I specify my PIN and it has initiated a transaction with respect to my Bitcoins. Now let me go back and show you. Okay, you can see I've got a message that tells me that my Bitcoins have been sent from my wallet as well. So this is one of the major factors which I would recommend you to go with 𝐓𝐵 as such. Okay. Now this is my blockchain info wallet and this is a completely cloud-based wallet here. Okay, so here are all my recent Bitcoin transactions, my present transactional value. That is, there's no Bitcoins present at the moment, so it's showing me the balance to be 0. Okay. Now they've recently started an option to buy and sell Bitcoins through these blockchain wallet itself. Apart from that, as I had mentioned, they support both Bitcoins as well as Ethers as such. Okay, so I've got a notification that says I've received Bitcoins. So let me just go to my Bitcoin dashboard. Okay, let me just go to my home dashboard, that is. So here you can see I have 0.955576 Bitcoins, but the value is low. This is mainly because the Bitcoin info wallet actually is going with the current value of 2,96,000 for the present value of a Bitcoin. Whereas on 𝐓𝐵 it was close to 3,22,000. Now that is mainly because the difference, as I had mentioned. So they keep a buffer difference with respect to that same. Okay. Now this is my corresponding value in Bitcoin. So let me just show you how you can convert these Bitcoins to Ethereum as well. So here you have the option of converting all your existing Bitcoins to Ethereum on the blockchain info wallet itself. So let's say if I put 0.00, okay, and it tells me that the minimum limit is 0.000143 Bitcoins, okay, which is correspondingly equivalent to 40 rupees in Indian rupees as such. Okay. So let me just change it to 0.1. Now it tells me I have only so many Bitcoins and I can only convert this. So once I click on this option, then it converts this to Ethereum. Okay. So 0.009 Bitcoins is equivalent to 0.127 Ethereum as such. Again, this is majorly because the price difference with respect to that same. Now, wherein a Bitcoin is close to 3 lakhs and Ethereum is just worth 21,000 rupees. Okay, I've standardly kept the currency to be rupees because rupees is where I would be working around with. Now once I click on next, the conversion actually starts. Okay, now one interesting fact about the same is that there is a time frame associated with respect to the code because the value of Bitcoins and Ethereum are constantly changing. You can see here it's fixed a specific value for my Bitcoins, it's fixed a specific value for my Ethereum. It's also kept a constant exchange rate with respect to that. There's an associated transaction fees as well as a withdrawal fees as well. Now I've agreed to the condition. Shapeshift is one of the most popular platforms which helps you convert your cryptocurrencies between each other. Okay, so once I click on confirm, correspondingly the transaction is going to get initiated and the exchange has successfully taken place. Now again, this may take some time with respect to that and the corresponding conversion would get reflected here. Now if you see here, there to be a transaction. Okay, now at any point if I want to see the status of this, just click on the arrow mark here, which will redirect me to blockchain.info website, wherein it will show me the status of the transaction as well. So you can see the status of any transaction. And if you've attended my previous session, you might be aware that any transactions using Bitcoins is visible to everyone across the globe. So all you need is the transaction ID associated and you can completely view transactions involving Bitcoin. But here again, it's using my public key, thereby ensuring that no one can actually know who is dealing with respect to these Bitcoins. So your identity is completely anonymous.
Now, I guess the topic deserves a small introduction to this whole cryptocurrency jazz and what it's all about. Well, digital payments have replaced the whole idea of carrying cash with you. Whether you want food, groceries, a cab, or even general services, you can pay for everything digitally, but it's not really like cash payments. Cash is untraceable, cash can be spent anonymously, and more so, cash is trusted. Escaping these problems was the promise made by Bitcoin, the first ever cryptocurrency. It had the beautiful anonymity of cash, and it was cash that was not printed by the government. Instead, it was made by a bit of code that was powered by the citizens of the internet, and you could trust it. Today, anyone can buy crypto. A few signups, smash in your credit card details, and trade in your money for digital cash. Bitcoin got so popular that by the end of 2017, it was as valuable as the big banks that it stood against. Today, there are thousands of cryptocurrencies out there other than Bitcoin, and we are going to list down the top 5 that are in my opinion. Now, at first, of course, we have Bitcoin. Bitcoin was the first cryptocurrency that started the whole decentralization movement. Without Bitcoin, we would not be where we are in terms of crypto today. What made Bitcoin stand out was how it brought about a new perspective of trust. According to Bitcoin, no user is a trusted user, and everything must be verified by public consensus, which is achieved by a mathematical process called proof of work. We won't get into the working of proof of work, but let's just say it's a very resource heavy and equally trustworthy and hard to break system. It was truly the first piece of tech that promised security over the internet. As of this day, the market's capitalization of the world's top digital currency, Bitcoin, is more than $125 billion, with a price per coin of more than $6,700. Next on our list is Ethereum. Ethereum is an open source and public blockchain-based distributing computing platform for building decentralized applications. Now, before the creation of Ethereum, blockchain applications were designed to do a very limited set of operations. Bitcoin and other cryptocurrencies, for example, were developed exclusively to operate as peer-to-peer digital currencies. Now, Vitalik Buterin, the mastermind behind Ethereum, envisioned his project as a platform for developers to write programs on the blockchain. Now, this was brought about with the implementation of smart contracts, which is basically a program that runs on the blockchain and can be invoked by other users of the network. So basically, this allows app developers to freely work on the blockchain without knowing its intricacies by using frameworks like Truffle.js. Above that, Ethereum is also moving to a more resource-friendly consensus algorithm called proof of stake, and the crypto coin of Ethereum, which is called Ether, has about 100 million of them right now in the market, which just shows how much popular it is. Up next, we have Ripple. Ripple is a real-time gross settlement system, currency exchange, and remittance network created by Ripple Labs, Incorporated, a US-based technology company. Now, Ripple is built upon a distributed open-source internet protocol and supports tokens representing fiat currency, cryptocurrency, commodities, or other units of value such as frequent flyer miles or mobile minutes. It eases out the process of cross-border payments with its negligible transaction fees and super-fast transaction times. Above that, what makes it special is the consensus algorithm used, which is called the Byzantine fault tolerance, which is based on the Byzantine general problem. It's a method of eliminating faulty participators of the network by bringing about a consensus through majority poll. It's a pretty interesting concept and you should definitely check it out. Also, Ripple has some insane flexibility in terms of currency. You can pay in all sorts of cash currency and cryptocurrency, including Ether and Bitcoin, and there's only a negligible internal commission for this. Okay, so that was all about Ripple. Next up is Bitcoin Cash. Now, Bitcoin's popularity skyrocketing caused its own set of problems in terms of scalability. The number of transactions increased by leaps and bounds, and the rate at which the blocks filled up were increasing as well. More often than not, people actually had to wait till new blocks were created so that their transactions would go through. This created a backlog of transactions, and in fact, the only way to get your transactions prioritized is to pay a high enough transaction fee to attract and incentivize the miners to prioritize your transactions. To solve this problem, Bitcoin went through a hard fork and Bitcoin Cash was born. This was done with the implementation of SegWit, which stands for segregated witness. Now, the implementation of SegWit brought about a few changes. It increases the number of transactions that a block can take. It decreases the transaction fees. It reduces the size of each individual transaction. Transactions can now be confirmed faster because the waiting time will decrease. And this, in overall, helps in the scalability of Bitcoin as a whole and as a protocol. Now, since the number of transactions in each block will increase, it may increase the total overall fees that a miner may also collect, which also helps with miner incentives. Lastly, now for our top 5 cryptocurrencies, we have EOS. So EOS is a blockchain platform for development of decentralized applications or dApps that are similar to Ethereum in function. It makes dApp development a breeze by providing an operating system like set of functions and libraries for developers. EOS brings together the best features and promises of the various smart contract technologies out there. For example, the security of Bitcoin, the computing support of Ethereum, into one simple to use, massively scalable dApp platform for everyday users. It provides a complete operating system for decentralized applications focused on the web, with services like user authentication, cloud storage, and server hosting. Now, the EOS platform is equipped with full-featured authentication system that includes user account permission levels, locally secured user data, recovery for stolen accounts, and much more. Above that, EOS provides server hosting, cloud storage, and download bandwidth to developers as they build and deploy applications and web interfaces. Now, when an application is built on an app platform, micropayments are not required to send messages and perform tasks on the EOS blockchain by end users. App developers determine how the typically low transaction fees will be paid. Now, the community can also fix bugs and upgrade and downgrade in the system democratically and securely with its governance rules. This works by having block procedures to vote to confirm certain transactions, whether applications are running properly, and on modifications to the source code and the system as well. Above that, it's an insanely scalable platform from what we've been promised. So there's a lot to look out for in EOS, and that's why it makes it into my top 5 cryptocurrencies.
So this is how the blockchain industry is revolutioning. In fact, this all started before 2014. So they represented from 2017. So a lot of VCs are investing, a lot of industries. You can see that you can just type in blockchain and look for the news. It is like rage actually. A lot of people are getting into this field, especially since this cryptocurrency is closely involved with blockchain. Okay, so it has a like more of it. Like if you look at other technology, it doesn't have any financial incentives. But when it comes to blockchain, it is completely revolutionary. There is something called ICO, you might have knowing, initial coin offering. Previously, we heard the term only called IPO, initial public offer. So new coins are getting generated, new platforms are being developed. A lot of things are happening. What they're claiming is in 2023, it will be all consortiums. That is, a group of people would be work together to form a blockchain platform for a specific industry. Okay, so these all things would happen. And 2024 is when most of the systems you can see there is a blockchain adoption. Many industries, and 25, it's all through, and they're claiming that it could be used, 85% people would be using blockchain technology. So this is an idea like how the government would be using. For example, if you see, we are all using these wearables, right? So the wearable devices, Fitbits, and other IoT devices. Okay, so these devices would start interacting with blockchain. So this is one of the biggest use case in the market right now. Especially if someone from telecom background or core C++, C++, I think this would interest you. And many government related projects where they would create more transparency, okay, using this blockchain technology. Some of the examples, smart city, they're saying even there would be a 10% increase in the world GDP. So we'll look at how our current system works. Suppose, let's see, like today, if you want to transfer some amount of dollars from United States to India. So there is a Bank of America in United States and there is a State Bank of India bank in India. So you are trying to send $10,000. Let's say Pranav is transferring $10,000. What happens is from Bank of America, you are initiating a transaction. Then what happens is, so this is nothing but Federal Reserve. So similarly, India, there it is called Reserve Bank of India. Okay, and the local Indian bank is called State Bank. So now what happens? Pranav is trying to send $10,000. Internally, what will happen is this Federal Reserve will maintain how much Bank of America has. Bank of America in turn will maintain how much Pranav owns. Pranav has $10,000. Suppose, let's say Pranav has $20,000. And what will happen is now Pranav is trying to initiate a transaction of $10,000 to State Bank of India. What would happen is, first, this amount would be deducted from Bank of America. Okay, it notifies Federal Reserve that, okay, a $10,000 is going to be deficit from my Bank of America. So Federal Reserve reduces the amount Bank of America, suppose Bank of America has $100,000, it reduces by $10,000 and it initiates a transaction of $10,000 to State Bank of India via Reserve Bank. Okay, it will be sending to Reserve Bank of India, and Reserve Bank of India finally transfers to State Bank of India, and State Bank of India finally deposits to Pranav's account or someone's account in India. This is how things flows when you transfer, when you do an overseas transfer. When you carefully observe, there is a lot of third parties or centralized authority. So there is Bank of America, there is Federal Reserve, again it's a centralized authority, there is Reserve Bank of India, there is a centralized authority, okay, and State Bank of India. So what happens is, today, suppose we can say this Indian national rupee rate is 65. 65 is the price for today. What Bank of America will tell you is, we will give you only 64 rupees because we are doing all this headache of transferring between banks. Okay, and finally it has to reach State Bank of India. And only way is, I would give you only 64 rupees. Then Pranav has no choice. He'll have to live with 64. So by this, what he is losing is, he is losing 10,000 bucks. So 10,000 into 65 becomes 65,000. Now he is losing 10,000 when he transfers. Like this is 64. And also it takes time. Okay, now maybe you are using Zoom or some service which is fast, but they have their own business model. Okay, but ideally it takes time for you to deposit some currency from overseas to India, and also you are paying a significant amount of fees. We have lost some amount, right? So likewise, if you look at the entire remittance market or overseas transaction, it is close to $20 billion, I believe. On a yearly, this transaction fees and other thing is almost close to $20 billion. And people are thinking, if we use blockchain technology, this $20 billion could be given for some poor welfare or something better which could help the world. Okay, why we should charge so much amount of fees? So we'll look into that. Okay, so that is how the current system works. Okay, here what they have mentioned is trade is recorded. So Pranav is making it, they're maintaining it and they're sending it. So what are the problems with the current system? So first thing is fees. You are paying a substantial amount of fees, and central authority has a control. So if they decide 65 rupees to give you, they can give 65. Tomorrow they decide of 60 rupees, then you'll have to pay 60 rupees. There is no other choice. Unless you fly from US to India and give some amount, otherwise there is no choice. And also you are not allowed to transfer a small amount. Say if you want to transfer just $1 to India, that is not possible. Even for charity, just imagine that for a charity purpose, you want to contribute $1. So everyone would like to contribute, right? Suppose when it is $1,000, we might think for $1, everybody will be ready, $1 or even $10. But such kind of transactions is not possible with the current centralized system. And possible solution, what we are going to look at is, if there is no middleman, if there is no centralized authority, today Pratik wants to send something to Hussain. Okay, how can he do that? Okay, is there a way, is there a channel, is there a mechanism where we can transfer some amount of funds directly without using central banks? There is solution. Okay, so that is nothing but why this Bitcoin was created in the first place. So without any central authority, one can transfer funds from one place to another place or one person to another person without a middleman. Okay, it doesn't matter if it is from States to India, or it doesn't matter if it is from you're transferring to your neighbor. It is all going to work the same. If you're going to transfer some money to the next house person, that is also same. It is equivalent to doing an overseas transfer. Both are one and the same. Now we will see how the system, okay, when we say decentralized, you might have questions like, okay, in the centralized, people know that how much Pratik is initiating a transaction. Pratik knows, or the bank knows Pratik, how much Pratik owns, who he is transferring to, and all those transfer process, central authority take care. Okay, when you say decentralized and when you say Bitcoin, okay, who is taking this responsibility? Who is sending funds from one location to another location? We will see that in depth now. So there are three types of system. One is a centralized system. Just think of this as Bank of America. All of the users have account with this Bank of America, and if they want to do anything, if they want to send that funds to the neighbor or someone, they always need to go via Bank of America, and Bank of America only will talk to the outside world. Okay, so this is a typical centralized system. So next is a decentralized system. Decentralized is nothing but partially there is one central authority, and then this one person is talking to another person. Okay, like here, this central authority talks to another central authority. Likewise here. So this is a decentralized system. So the last one is distributed system. So distributed is everyone talks to everyone. So all of them are connected somehow. For this, to understand this, Bitcoin. So now what is Bitcoin uses? Bitcoin uses distributed network. And there are some special peers who are validating the transactions. We will see that. But Bitcoin is a distributed network. For this, I'll give you an analogy. Let's rewind some time back. Okay, let's go to 2000s and let us understand the centralized system and decentralized system too. Previously, if you want to download an audio file, what you do? Probably early 2000s, or not even early 2000s, in 2000s or 1998, something like that. Okay. So at that time, what you would do is one would go type in abc.com and he will look for the songs, what all songs he has got, the website got, and then you click a download button and you wait until it gets downloaded and then you play the song. Similarly, if you want to download the movie, it's the same. Okay, you go to some centralized website, you click that, it gets downloaded. You see the problem here, it is a centralized system. If abc.com goes down, there is no way that you could download a song. There is no possibility at all. Because it is centralized system, you are just believing abc.com. Then came in early 2000s, or I think 2004, something like that, then came this torrent revolution. So how this torrent works, I know that most of you might be knowing torrent. Let's say that there are three parties, XYZ. So XYZ wants to download a song. Let's say that it's a rhymes. X person has this nursery rhyme. He has first downloaded. Okay, next what happens is, let's take 4%. So now Y also is downloading. Y, what happens is Y will download from X. Now, so both of them have nursery rhymes in their respective machines. So it is not in any centralized location. Okay, it is not put in abc.com. Instead, it is residing in their own machine. Now Z wants to download a song. The same rhymes he wants to download. While doing so, what he will do is initially, he will try to do is, he will contact the maximum number of peers. Okay, the software will take care for you. But in turn, behind the scenes, what happens is, it will try connecting multiple peers and then it will download. So let us take this rhymes is 10 MB. Just as a random example, okay, 10 MB. So now the Z system, what it will try is, first 5 MB it will try to download from X, and the remaining 5 MB it will try to download from Y. And put together it will get the rhymes. Now suddenly what happens? Y system goes down, or Y has turned off his system. Still Z is able to download from X machine. So here if you see the SPOF, or single point failure, right? So very good property of blockchain. Okay. So this single point of failure is addressed here. So even if Y goes down, still Z would be able to download from X. And if there are multiple peers, it's well and good, the download would be faster, there will be multiple connections. Whereas in the centralized authority, what happened? It was all abc.com, you just wait for the song to get downloaded from that one particular system. Now we are going to look at pictographically. So you see here there are multiple nodes, there are multiple computers. So let us take the same example. Okay, you have this rhymes. Okay, moment you have, what you do is, you transfer that to this machine and this machine and this machine. It goes on like that, and finally what will happen is, eventually after some time, everyone in the network would have this rhymes. If it is a compulsion, okay, rhymes is nothing, audio file, if you want you would download. But in terms of blockchain, what happens is, the entire set of transactions, let us take Sandeep makes 10 transactions. Okay, in blockchain world, what would happen is, this 10 transaction, it will go here, it will go here, it will go. Eventually what will happen is, after some time, everybody in the network will have all the transaction that was ever made. So if this system wants to look in for the transactions, like what happened in block number 5, it need not go and fetch the information from this system. Instead, it will have its own copy. Distributed ledger technologies. There are two things which are going on in the market. One is blockchain, and other thing is called distributed ledger. So people say that, why should I have a block? I can have only transactions. I don't need a block. All I need is just a proof that I have transacted. So there are some groups going on. So these are some of the industry consortiums. That is, these are a group of people who work on a common goal. So this Hyperledger is one such consortium. They are trying to build a blockchain platform for enterprise use case scenario, enterprise. And in Hyperledger, it is actually open foundation, and there are multiple projects which are going under Hyperledger. So one is called Hyperledger Fabric, which is incubated by IBM initially. Then the next one is Hyperledger Sawtooth Lake, which is incubated by Intel. There is Hyperledger Iroha. There are a lot of projects. So each one is taking a piece of this and working. Okay, so this is that type of a consortium. The next consortium is R3 Corda. So this consortium is nothing but they work on financial use cases. So they are trying to build a blockchain platform specifically for financial and capital markets industry. And the last one is PTDL. They are working for trade related use cases. They are trying to build a blockchain system, or they are coming with, they need not even build a new blockchain system. They will bring in the auditors. They will see like what can be done. Okay, how this is going to work in my line of business. So these are some of the groups they're working. And some of the platforms you can see, some popular platforms is Ripple. Okay, whatever I said, Intel, Sawtooth Lake, and Tendermint. You can see Ethereum here. So these consortium takes these all platforms and they're trying to find out what can be used. Ethereum, Bitcoin, like that. And underlying infrastructure, you can have it in a cloud. Okay, you can have your own data center, or you can set up your own blockchain network within your company. You're allowed to do that. Or if you want to go to a cloud approach, that is also possible. So these are some of the options available. So initiating a transaction in a network. So what they're saying is, just imagine there is no central authority, there is no banks. Just imagine today's world, in US or India, you don't have banks, and you want to transfer or you want to send some funds. Okay, Hussein want to send some funds to India. The only way is you physically have some dollars, go convert in exchange, bring the rupee, give it to the concerned person. Or you give it to some person who is going to India, some third party agent. That is physically you'll have to go and give the funds. That is the only way. Otherwise, it's all through central authority. We'll see like how this is happening in Bitcoin world. What is this transaction? Who will verify this transaction? What happens? So all these questions you might have thought about. Now we'll see like one by one, we'll address all those questions. So first step is initiating a transaction. Okay. So the important piece of it is, so I'll go here and then I'll come back to the previous slide. So this entire Bitcoin or blockchain, this all works based out of public key, private key algorithm. Okay, you might heard of this RSA key and all, right? RSA encryption standards. It all works using public key and private key cryptography. Let's see like what is public and private key. So public key, private key itself is a very big module. Okay, now what we are going to see is a high level understanding of what it is. So what happens is, there are different encryption standards by which you can create this pair of keys. Okay, normally what happens when you request for this encryption mechanism, right? You get pair of keys. One is a public key, that is like your house address, you can give it to anyone. Another one is a private key which you will have to safeguard, or otherwise you can correlate with your house key. So you normally what you do is you give your home address to everybody so that they can post, they can send letters or greetings, something like that. And only you can open the door and take what is present there. So that is nothing but private key. So this private key also will be some kind of numbers. So this is how it looks, some jumbled numbers kind of. So the idea is, if you want to send a message, hello. Okay, X person, let's take Bob and Alice. Bob wants to send message hello to Alice. Now, what happens in the physical network, if you send some intruder, what they can do is they can go find out what you have sent. So say hello is okay, but say it is a bank account, some kind of information, then it is a problem. So one solution was, first level was encryption. So encryption, when we think simple, shift by one, basic college level, what we do, we shift every bit by one, something like that. You know, you create a hello. Now what you're doing is you will shift everything by one. Shift by one alphabet. So likewise, this gets shifted. Similarly, what happens? The recipient should know that what is the key, and then he should pre-shift, post-shift and pre-shift. He'll have to do to get the message. But this has a problem. First problem is you are sharing the key, like what is that you want to, and the key is very weak. You are shifting by some characters which will be easily identified. So the concept here is public key and private key. What if Bob wants to send a hello message? What he would do is, he would get Alice public key. Everyone will be having a pair of keys, public key and private. Alice would be sharing her public key. This is Alice public key. Now Bob will, what he will do is, he would take Alice public key and then he will encrypt this hello message, then send it to Alice. Okay, now only Alice can open this message with her private key. No one will be able to open it. It is not possible at all that only who has this private key can open the message. Okay, now in this case, Alice is using the private key, whatever she has, and she is opening the message. I would recommend, I have a post here. There is something called cryptography basics. Here I have mentioned like how do you create a digital signature, how do you get a pair of keys, and how to encrypt, decrypt. I've given this hello Alice example. I've given step by step if you want to deep dive into cryptography, like basics if you want to go through. So now here what happens is, here James is trying to initiating a transaction. James uses two pieces of information, that is his public key and private key. So now what happens here is, James is trying to send some funds to Kevin. He's like our hello message. He is taking Kevin's public key and then he's encrypting. And only who can open? Decrypt, only Kevin can open using his private key. Any other private key will not be allowed. Just remember this house analogy, like you have your home address which you can give to anyone, but only whatever post or envelopes which are sent, only you can open because you have the private key with you. So there is another version of it. Okay, so here what we have seen is, we have taken the public key and encrypting, right? So in the Alice Bob case, so there is one more case. Okay, suppose what you are doing is, Bob is sending a marriage invitation or something like that. Okay, so what he is doing is, he is encrypting with his private key and he is broadcasting the message. Whoever has Bob's public key can decrypt. It's vice versa. Bob has encrypted using his private key. So Alice needs to know Bob's public key to open it. Just go through that link. It has examples, and also like if you want to try out, there are commands also to try out. So the concept is encryption. Encryption is used for sending any transactions. Especially, right, I would spend a lot of time here, public key cryptography, not now, but maybe after 2-3 weeks. If you want to get into this blockchain, especially when you look at this Hyperledger fabric, it is all SSL certification, HTTPS. It's all works like that. Okay, so I would recommend all of you to go through it completely and understand cryptography concepts. So where are the keys stored? Keys in the Bitcoin world, it's stored in the wallet. Okay, we'll see what it is. So normally what happens is, so we have this Bitcoin address and wallet. So it is nothing but, now let us focus our shift to Bitcoin. Okay, so you want to make some transactions. High level, you have understood what is blockchain. So Bitcoin uses blockchain as a technology to do all the transactions. So for normally in a Bank of America, if you want to have an account, what you have an account number, you log into Bank of America, and then probably you have a password, and then you get in and you do some transaction. Similarly, here you have something called wallet. So this wallet could be of different types. This wallet always comes with two elements. One is a public key and private key. So private key you would be signing if you want to send a transaction. Suppose the previous example, James want to send something to Kevin. He takes Kevin's public key and then sends the transaction. So you always get a pair of keys. Public key, you see, you can look at here. This Bitcoin address is nothing but a public key. Okay, people call this an address. What is your Bitcoin address? It is nothing but a public key. And this is a QR code. So the representation of this one as in form of a QR code. And if you want to send some transaction, you need to enter your private key. And that is like your password. You cannot simply go and send a transaction. You need to prove that you are, for this public key, you have a private key. So you get always like a username and password. You get this couple of things. Now let me quickly go and show you like some of. This is nothing but a blockchain info for Bitcoin. It will have entire all the blocks which were ever created. You can see here. So let me open a block. Inside the block, there are a lot of transactions which have happened. So you can see that some numbers to some numbers here. And you can see some Bitcoins have been transferred also. So this is nothing but the public key. See here you can see Bitcoin address. So this has an address, this has a QR code and things like that, right? So this is nothing but the public key. And with that, you have a private key that will not be shown here because that is going to be your secret. So that is your private key. So we will look into this blockchain. We will see like blockchain.info, what are the information we have here. We will see in the subsequent slides. For now, understand that this is how an address will be look like. So that's what they have mentioned here. Bitcoin wallet types. So there are different types of wallet. As I mentioned in the third module, we have a lot of information about wallets. So these are different types of Bitcoin wallets. First one is hardware wallet. Hardware wallet is all these wallets, whether it be software, whether it be web, cold or hardware, everywhere you get the pair of keys. Hardware wallet, what happens? You get a pair of keys and you can store the Bitcoin here. You can have the password or the private key separately noted down in a paper or something. So your Bitcoin physically will be present here. So now if you want to transfer, you can transfer from the hardware wallet. Cold wallet is you can have it in a, that is you're not cold when they say like how we say, right, database is in cold. Likewise, so it is not connected to the internet. So you store it in your Bitcoin, whatever Bitcoin you have, right? You can store that in a piece of USB drive, or you can note down your public key, private key in a piece of paper. So that is nothing but cold wallets. Web wallets is nothing but if you are trading via exchange, okay, you are buying Bitcoins and selling Bitcoins over exchange. What they do is on behalf of you, they maintain your public key and private key. Even though it is risky, they maintain it, but still for trading purpose, we leave it there. These are web wallets. Software wallets are nothing but you can download a piece of software which would generate to you a public key and private key, which will sync with blockchain. It will do all those functionalities. Okay. So these are software wallets. So now we'll see like the transaction, how things are happening. So here, what happens is whenever you send a transaction, okay, in the Bitcoin world, you have a public key, private key. In Bitcoin world, what happens is maximum you sending some funds to some person. So whether it be in India or anywhere, all you need to know is the person's, okay, whom you're trying to send, you need his Bitcoin address or public key. Both are one and the same. Okay, you need to have that. Once you do that, have his key, you are saying, say, if you want Kevin, in this case, Kevin is sending James 5 Bitcoin, okay, and he would enter his private key. Then what happens? A transaction is initiated. So whenever it's initiated, it goes as a, like this, it will be gone as a digest message. It will be a digital signature. That is nothing but previous example we have seen, right? Bob is sending a hello message to Alice. When it is signed, what will happen is it will all have a jumbled numbers. That's how things looks like. But inside the jumbled numbers, there is hello message. So that only who has private key would be able to decrypt it. So that's how every transaction goes. All you need to understand is someone's public key would be taken and across that funds would be transferred. Now, next, let's see how the transaction propagates. How is the transaction faster than the present system? So in a distributed architecture, okay, how things works is you send a transaction, any message, anything you try to broadcast, right? What happens? It goes here, it goes here. Every node will propagate its information to the next node. Sometimes in Ethereum world, it's called gossip protocol. Moment something happens, the information is gossip to the next node. So that's how it is fast, and that's why it will be very fast. So normally in the traditional system, what happens? See, there also internally, if you look, it is happening the same. Okay, suppose this is a abc.com, and if you want to download the file, what will happen is it will go through multiple routers. Like it will not go via peers, but it will go via router switches, and then it will take the information and then it will give you. That's how it works. Here it is more of a peer-to-peer fashion. So if this peer has information, immediately you get it. That's about it. So next is who validates, since there is no central authority. So there are the special nodes called miners. So this miner's responsibility is to validate these transactions, whatever transaction, right? So in the previous case, what we have seen is person A has sent some 10 Bitcoins to Pranav. So that validation, who is validating that, we will see in the subsequent slides. Mining is a process. It is nothing but in a traditional banking world, what happens when you transfer funds from Bank of America to India, there are central authorities who are verifying that such a transaction has taken place. Likewise, in the decentralized network, someone has to verify that such a transaction has taken place. So that is what the miner's job is. So how to verify this transaction, who is verifying it, I'll let you know all those things. So I'll use my notepad for explaining. So this is a very important concept. So let's first, what is happening is there are many nodes in the network like A, B, C, or Tom, Harry, lot of people are in the network. Everyone has this public key, private key. All of them have this addresses with them. First step, everyone has a public key and private key. And first, let us take a simple transaction. The transaction is A is sending 10 bitcoins to Harry. So what happens here is A has to know Harry's public address. Only then he would be able to send a transaction. And also A will be having his private key. He has to sign his transaction using his private key. So this is the first step. Step 1, A has to know Harry's public key, and also he has to have his private key to send a transaction. So this is how a transaction is initiated. Now, moment a transaction is initiated, what happens? We looked at that diagram, right? So there were a lot of nodes which were interconnected. So the transaction goes to A to B system, then it goes to adjacent nodes. It gets propagated like that. So B, what will happen is, see, suppose A has sent a faulty transaction. Let us say A does not have 10 bitcoins at all. A is having only 1 bitcoin, but A is trying to send 10 bitcoins to Harry. Then if node B is going to propagate this information to everyone, then it is a problem, right? The transaction which is sent, does not have any meaning at all, because it is a faulty transaction, and that gets propagated to everyone, which is waste of time. So there are some certain steps. Each step we will look deeply in the third class. For now, what you understand is, if a transaction is sent from A to B, some validation will be done by B before propagating it to Tom. Tom will do some validation and propagate to Harry. Okay, in case if B finds out that transaction is invalid, he would reject that transaction. Before it traverses from one node to another, okay, each of the transactions are minimally verified. There are some verification steps and it will be verified. So that is the step. Here I have mentioned Tom to Charlie. So here what I'm saying is Tom to Charlie it goes, and peer node validates up these transactions. They're doing some basic checks. So now this is how all these transactions are initiated by every node. Now what will happen is, there are some special nodes called miners. So they will validate all these transactions. So mining is a process of validating that transaction and forming a block. Let us see. So there are some transactions coming, okay, like transaction 1, A to B, A is sending to B, B is sending to C, Ram is sending to Sita, like that. The lot of transaction keeps on happening, transaction. This special nodes, mining process, okay, these are mining nodes. There will be many mining nodes in the network. Let us take mining node 1, 2, there are many mining nodes. Their job is, they will pick up the transaction. They will pick up all these unconfirmed transactions. I'll come to what is unconfirmed transactions. So that is unconfirmed transaction, nothing but this transaction should not be there in any of the previous blockchain before, not blockchain, block. So now job of the miner is nothing but one computer system. Just imagine like that. Miner is one computer system. He will be waiting for the transactions to come. Moment he gets some amount of transactions, like suppose say like our block size is 1 MB, okay, or 2 MB, and 1 MB can fit, example, 100 transactions. Real world it is more than that, but I'm just throwing an example. So 1 MB is trying to find out all the 100 transactions. Now I have got 100 transactions, so I made sure these are unconfirmed transactions and basic validation is done. And another thing is, I would also make sure that person A has this much amount of money. So all this has also been validated. Now I'm going to validate this block of transactions and then create a block. Okay, so miner's job is take this 100 transactions and add it to the blocks. Previously in the first few slides we have seen, right? So there was a genesis block, and block after block there were a lot of blocks. So miner is trying to validate these transactions. Once he is successful, he will add that to the block and add it to the chain. This is theoretically. I will explain how the puzzle works. Before this mining piece, this solving the puzzle, I will show you like how the block looks like. So you will get an idea, then we'll go deep dive into it. So I'm going to blockchain.info, and this is the real Bitcoin network. Here I'm going to search the first block ever created. So this is block 0, or it is called Genesis block, and it has one transaction out of, it has output of 50 Bitcoins, and there is only one transaction. Now let us look at 10,000th block. Okay, in the 10,000th block also there was only less transaction. Maybe we should look at the latest one. So let us look at block which was created before 25 minutes. So I'm clicking this. So here totally, if you see, these are the important things which I want you to observe. Okay, in this block, how many transaction has happened? 2,358 transactions has happened. So these many, and how much Bitcoin worth was transferred? It is close to 31,000 Bitcoins. And you can see these are those 2,300 transactions which has happened. Okay, all these transactions which happened before 25 minutes. So what I want you to notice, so there are, see here, there is 3,300 transactions. Some transaction has happened. These are the transactions. And if you see, each block is tied with the previous block. You see here, this is the previous block. And each block has a hash. So that also we'll see what it is. So it is nothing but with all these transactions and everything, it generates a hash. And what I want you to look at is, there is something called difficulty. How difficult was to solve this puzzle, and what is the reward I'm going to get if I solve the puzzle. Okay, it is 12.5 Bitcoin. Okay, and there is a nonce. This is a very important number, nonce. So now let me get into the details. Now let's go to the puzzle, like how it is getting solved. This is the puzzle we are going to solve. Okay, the miner, every miner in the network has to solve this puzzle. It is nothing but what it has to solve is, so this is nonce or a number, okay, random generated. So with all these transactions, right, with the 3,000 transactions, our example have 3,000 transaction. Out of this transaction, you generate a hash out of it. The software itself will generate for you. So it will generate a hash number. This is nothing but the challenge string. Okay, next comes the difficulty. So network will tell you, you add a number with this and you do a hash of it. If you do a hash of these both, I need a result of 42 zeros prefixed. 42 zeros. Okay, let me go here. See here, I have written it. So we have this challenge string, and all we are going to find is, we are going to guess the number, and what the puzzle says is, whatever number, you take this challenge string and you add any number to it, and when you do a hash, all I need is, I need prefix of these many zeros. If you find these many zeros, then I agree that you have solved the puzzle. That is proof of work algorithm. What it says is, challenge string is nothing but the hash, whatever number you want you choose, but the riddle says, get me 42 prefix number of zeros. Now miner, what he has to do is, he will start from 1. There is no other way to do it. What he does is, he adds number 1. Challenge is nothing but the hash. Okay, number 1, and with number 1 he tries to add the hash and then get the hash, and then he will check whether I have received 42 zeros. Then he will repeat. Now I take the number 2, add it with the challenge string, I hash it whether I get 42 zeros. Likewise, miner has to try indefinitely until he comes up with this 42 zeros prefixed. The 42 zeros is nothing but the difficulty factor. So tomorrow, if the difficulty level has to be increased, just a number, one more difficulty level, if it is 43 zeros, it will be like 1 trillion calculations per second. So this has to be done continuously, and then the riddle has to be found. Once this, suppose let's say this miner has found this riddle. Yes, our nonce number is 89, just a random example. You have a challenge number with 89, you found a number which has a prefix of 42 zeros. It means you have won the puzzle. Means like for the block you are trying to mine, you have found the puzzle. Now what you would do is, you would propagate your block to other miners to validate. Now other miners would validate whether the block you have solved is right. If you have solved it right, you get a reward of 12.5 Bitcoins. Miner would get a reward of 12.5 Bitcoins. Make sense? And also this block will add it to the blockchain, meaning this block or this entire amount of transactions in the block is being validated by the entire network, and it is foolproof. It can be added to the chain. So what happens is, once the transaction is verified, right? This is an example. Here what they've said is, once the transaction is, the block is validated, what will happen is, this block will be propagated to all the peer nodes. That is nothing but the ledger. Here what they have mentioned is, so James has $10, okay, and in fact this is a typo actually. So all the transaction, James is transferring $5. Okay, it has to be 5. Okay, and Kevin to Paul 3. All the transaction which has ever happened, right? It does not go to centralized. Instead, what is happening is it is stored in all the nodes. So James knows what all the transaction has ever happened. Robert knows what all has happened. So this is what they are trying to depict. Next one is ordering of transactions. We'll see this. So the question comes like, suppose A has only 10 bitcoins and A is transferring Charlie 5 bitcoins, or we'll say 10 bitcoins only. Okay, 10 to Charlie. At the same time, A is also transferring to Tom 10 bitcoins. He's trying to fake. So at that time, what happens is only one transaction has to go through. So other transaction should not get passed. Okay, suppose let's say this transaction he has initiated from India, and okay, he is opening the same wallet somewhere else in US, and then he's trying to transact. Then what happens? Say USA and India. So wallet address is same. Someone is opening A's wallet from USA and sending 10 bitcoins to Charlie, and someone is using the same A's wallet opening in India, and they are trying to send 10 bitcoins to Alice. So now, just I have taken a USA and India just to geographically, I just want to assume that it is a very far, but eventually it's not going to happen like that. Okay. So 2 transactions got initiated. This is one transaction, this is one transaction. Then what will happen is it will all get propagated, and then it's going to be formed as a block. So at that time, one transaction would go through, one will not go through. So that's when this order and everything matters. Okay. One transaction will go through, one will fail. So by that way, we are eliminating that A is not sending a double spending. So this is how you see block number 145 followed by 146, 147, 48. This is how these all blocks has a block hash, block ID. We have seen, right? Each will have a hash number. So this is a hash number. This previous block is tied 145th block, right? You see 146 will have this block ID, previous block. So this one will have this block's ID. Similarly, that's how everything is getting chained, chain of blocks. Now there is a scenario that there is an Indian miner. This is also I am considering geographically. USA there is a miner. Similarly, in India there is another miner. So they are also waiting for transactions to be mined. Okay, so he has taken 3000 transactions. Similarly, he has taken some transactions, and they are both trying to mine the block. Let's say that both of them have mined the block. He was able to do it in say 6 minutes. He was able to do it in 6 minutes 1 second, like that. Okay, like that they were able to mine. So now we have 2 blocks which are under race. Instead of race, I would say like there are 2 blocks which mined. Who will get the reward? What will happen? What happens is, moment your block is mined, you will not immediately get the reward. You will get the reward only after miner propagates the block into the network. All other miners have to validate whether this block was mined successfully. Then only the 12.5 bitcoins will be awarded as a reward. Now in this case, what will happen is there are 2 blocks. For instance, let us take both are been mined in the exact 6 minutes. Then what will happen is 2 chains will be propagating for some time. That is, let us say we have block 1, 2, 3, 4, 5th. We are supposed to add the 5th block. Then what will happen is in USA side, people will be adding block 5 and they will be going. This block came from US. Another, what will happen is in India, they think like, this person has mined. Okay, and they will try to add Indian block. Okay. Likewise, 2 blocks goes, but the 12.5 rewards are not allocated yet. What they will do is, since now there is a problem, right? So both are them in the same height. They will see there are other miners nodes will validate, okay, who has done most difficulty rate, who has solved most difficulty rate, or who has solved more number of transactions. In this case, so let's say both are 3000 transactions. Both have same difficulty rate, 42 zeros. Both have same minutes. In that case, what will happen is they'll see who is adding the next block here, right? So suppose there is one block which gets added here in the Indian chain, right? Here it's not getting added. It's taking some time. Then what will happen is this becomes the longest chain and people will start following this chain rather than the Indian chain. And the reward would go to this miner who has mined this block. You see here there are list of transactions. So these transactions are all initially validated by basic validation is done by the peers. Okay, now once it is in the block and confirmed, it means that it is a tamper-proof record that yes, such a transaction has happened. And you can see this unconfirmed transactions are there in a pool. And for forming a new block, these transactions are pulled in and then the puzzle would be solved. So here you see this is the existing blockchain. Now there are two new blocks. Okay, one miner from India. So here they have said Lisa, okay, and Paul. If you consider miner from India and miner from US, so they are trying to mine a block. In that case, who would be the winner? So that is the question. We'll see that. Whose block to consider? If there is exactly same in that case, whose block to consider? And here, so proof of work, block puzzle. Okay, so it takes, whatever we have seen, right? So they have given it in text. Probably, I think I've explained to you, like, what are those zeros, how it works. The important thing to notice here is mining this proof of work algorithm, right? It takes a lot of electricity. What they compare it with is the entire Bitcoin network takes or requires electricity of Iceland. So the entire Iceland's electricity power is required for running a Bitcoin network. So that much of electricity is required. Why that much of electricity is required? Because the puzzles which you are trying to run is trillions of calculations per second you are trying to do. So that much of processing power it requires, and here comes the electricity. So that's why electricity is more, and part of Bitcoin solution that each contain answer to a special math problem. Math problem is nothing but the zeros. So there are three components. Okay, so we have seen this already. So nonce is nothing but your answer, the random number which you are trying to find out. So that is nonce. So hash is nothing but every block. Once you frame a block, you can hash certain elements and create your block hash or block identity. And transactions, whatever transactions which have happened for that particular block, whatever you are choosing. So finding the puzzle, why it is hard? Because it is brute force. So there is no direct solution to find out the puzzle. You'll have to try with all the random numbers. So roughly it takes around 10 minutes for one to find this solution. So what if one builds a lot of processing power and is able to solve in 6 minutes or 5 minutes? What happens is blockchain or a Bitcoin network, it is defined in the Bitcoin protocol. Bitcoin protocol will monitor how fast miner is able to solve the puzzle. If it finds that people are solving the puzzle so quickly, then the difficulty rate will be automatically adjusted. From 42 zeros, it will be 43 zeros. For 1 zeros, it is like 2 power 42. It is a drastic. So it is like multiplying into 2. So that much amount of work one has to do to find again. So suppose next time onwards, once the difficulty level is increased and now the mining takes place or the 11 minutes or 15 minutes, then accordingly the protocol itself will adjust the difficulty rate. So this difficulty rate adjustment is happening every 2 weeks once. So that is also defined as part of Bitcoin protocol. It roughly the difficulty factor will be adjusted every 2 weeks once. So there is some calculations like number of blocks exactly. Based on that, the difficulty factor would be adjusted. So now we'll touch base on some security properties of a hash function. So hash function, I've shared an article, and also there are some very important properties of hash. So hash is nothing but a mathematical function. So for example, if you guys have from programming background, you would know that we talk about classes and objects, right? So each object is a hash. If you go into internals, so each one is a hash. This hash algorithm should have certain properties. Okay, we'll see what are the properties. First one is collision free, meaning, so if you give an input as Alice, okay, and if you want a hash, you get an output. And no two inputs will have the same hash. So Alice gets a hash, Bob will have a different hash, Charlie will have a different hash. No two inputs will have a same hash, even if there is a smallest change. In Alice, you keep a just full stop, then you run a hash function, the output would be completely different. So that's what, if you look at the article which I've shared, there are some steps I've done. So in that I've showed, like, if you have a period, the entire hash output would be different. So just try that. So this is the first property, collision free. So the next property is hiding. That is, say for a given input, you get an output which is completely not relevant to the input. So if you give Alice as an input, you get an output completely some gibberish numbers. From the gibberish numbers, you would not be able to make out what the input was. Okay, so that is the second property. And the third one is puzzle friendly. So it is nothing but your hash You should not append with something and you get an input back. So likewise, it should not be there. So these are the properties of hash. You should just keep in mind. So why do miners invest in their resources in validation? So why do they spend so much electricity? The reason being they are getting a reward. So they are getting a reward of 12.5 bitcoins today. So these are miners' reward. What do they get? They are solving the puzzle. So they are trying to find the answer. One who wins publishes to the block to the network. Okay. Once publishing or broadcasting, what happens? It will be validated, and other miners would take this. They will come to a consensus whether this block is a valid block, and then they will add it to the blockchain. So the reward, they spend so much of electricity and they are trying to validate all the transaction in the network. So they are rewarded with 12.5 bitcoins for now. So that is the monetary reward they get. So next is, how is the currency generated? So currency, what happens is, see the limit of 21 million bitcoins, which we have spoken some time back. So this 21 million bitcoins is already hardware, meaning that it's already mentioned as part of the protocol. And every 10 minutes once, a reward will be generated and sent to the network. Okay, so this they have represented pictographically. So this is the blockchain. And what happens is there are a lot of transactions inside a block. So there is a challenge string. So challenge string is nothing but the hash which is generated. And then you're trying to prove it. Proof is nothing but the nonce. Okay, so the random number. And you are doing a hash of it. And once done, what happens is it gives you an output with so many zeros in front. So this zeros defines the difficulty factor. Once done, the winning block is added to the blockchain. So next one is if what happens. So these are all things we have seen. If more than one block gets solved in the same time, what is happening? So that is solved using consensus mechanism. Let us see what happens. Now consensus algorithm. So what is consensus algorithm? We'll just look at that and then we'll see what happens when both the blocks gets mined in the same time. So for any blockchain or any consensus is just a common word, just coming into an agreement. So there is a special rules which are set up saying that if X happens, do we all agree? So something like that. Let us take a simple example. Okay, so we all, suppose a group of people are living in an apartment, and what they decide is if something goes wrong with the swimming pool, all of us has to contribute to the pool. So whatever may be the amount, or maybe they have some nominal amount, say maximum we could contribute $5,000. This is nothing but they are framing a rule, upfront before something happens. They are framing, and everyone agrees to that. Tomorrow, if something happens to the pool, it's already agreed. So that becomes consensus algorithm. So here, what is the consensus here we are talking about is, so what if two blocks are solved in the same time? Then who would win? Okay, so all those are defined before. Suppose I'll give you another example. Okay, let's say that running race is happening. This is maybe a weird example. So let's say that a running race is happening for a group of 10 people. So the idea is if two persons are coming at the same time, in that case, what would happen is we will look at their previous track records, like, till final, whatever was their points, how fast they have run. Based on that, winner would be awarded. This is assumed before, or the committee members have come to a consensus that if two persons are winning the race at the same time, the previous race would be considered. So that is agreed. Now running race happens, two persons are coming at the same time. Then based on the previous rules which are defined, person would be chosen as a winner. So this is consensus. So here they have similarly in Bitcoin network. So in what all scenarios, those we'll look at, like what happens when the next block is solved. So here what happens, the previous Paul's blockchain. So what happens here is Paul's blockchain, nothing got added. Here there is one more thing. But if you see here in the Lisa's blockchain, there are how many blocks? 1, 2, 3, 4, 5. But here the Paul's blockchain or Robert's blockchain, what happens is maximum they have only 4 nodes. 1, 2, 3, 4. So here what happens, even though they all solved in the same time, after a while, after a period of time, this branch or this Lisa's blockchain seems like she has more number of blocks. Now what happens, everyone would, all the other participants, right, other blockchain, this is a consensus. So yes, okay, you all solve the block in the same time, you continue to solve. Consistently wins the race. Then what happens is, over a period of time, Lisa's blockchain, okay, has more number of blocks, and everyone, like other networks also would follow the chain because Lisa has more number of blocks. So they're trying to adapt to the longest chain. So once they adapt to the longest chain, what happens is This block, right, all the blocks which got solved before, this goes to the unconfirmed transactions. So in this case, the orange and the green block, it won't get rewarded, and as well it will be put into the pool of unconfirmed transactions. So what if a miner is trying to cheat the system? So this one we'll see like what all the negative scenarios. Let us go to notepad. Okay, cheating scenarios let us take. So in India, USA, okay, suppose these are transactions happening. So AB is one transaction and a transaction. So now if suppose A in India, a miner is trying to add a transaction A to D, AD, which has not happened at all. Then what happens? This one, right, this block goes to the mining other miner nodes for consensus. At that time, they will be able to find out whether such a transaction ever did it exist or is it a fault transaction. Okay, so by that way, they will be able to eliminate such a block. Okay, so this is one thing. So the next one is, this is one type of attack. So other, that is theoretically speaking, it is just for the sake of theory. Theoretically, Bitcoin can be hacked. When we say hack, we can attack the Bitcoin network. How is? So let us take here, what is the mining ground rule? Mining ground rule is one has to solve the puzzle and then the transaction has to be validated. The mining block has to be validated by other miners. Suppose, let us take in India, there are 10 miners. First block contains AB transaction. In second block, they are adding AC transaction, which did not happen at all. And similarly, AD, like that they are trying to manipulate. If one has to manipulate like that, what should happen? They should add a block and that has to be confirmed by other miners. That's 6 confirmation. Theoretically, what they are saying is, in India, there are other 6 superpower miners. As soon as the transaction is done, the other miners are going to confirm. It will go on like that. So theoretically, it is possible. But practically, what is happening is, one needs lot of power, lot of electricity, lot of hashing power to build such a system to hack the network. And what they are saying is, in the world, there are like couple of supercomputers. Okay. Even if you build 10 times such supercomputers, you will not be able to hack. You will not have that much of enormous power because it is distributed. The power is distributed now. So you will not have such a power, and henceforth, practically it is not possible. But theoretically on papers, yes, this hypothetical scenario exists. And another thing to notice is there are some pundits or gurus, what they are claiming is the next age of computing, right? What is it called? Cognitive computing or quantum computing. Once this quantum computing comes into picture, it would be easy. That's what the one set of people are arguing. Pictographically, they have represented bundle transactions, verify if transactions are valid, solve the proof of work. When the solution is found, the block propagated to the network. What if someone tries to hack the system? What happens is, suppose one miner is trying to add a block with all faulty transactions. Moment he is trying to add, what will happen? First of all, other miners would reject. Okay, and if he's trying to add the hash, okay, he should know the previous hash. So by that way, basically others would reject and it will not be able to, not possible. If there is a faulty miner, in consensus, it would fail. So there is no way to alter the system because it's all blockchain. Everyone has the copy. Okay, suddenly if you say that such a transaction has happened, that is not possible. So the protect by raise 51% attack, what I have mentioned. To sum up, distributed or what is happening in the blockchain till now, what we have done is it is all through public-private key, and every information is propagated from peer to peer. And the Bitcoin world, it's all public ledger. Okay, everyone has a copy of it. And the next one is miners are getting validated, and finally the consensus. So benefits of blockchain technology in terms of cryptocurrency, in terms of Bitcoin, what is that you have achieved? Settlement in real time. So in the bank world, what happens is bank will initiate a transfer to you, but behind the scenes, they will work with other banks to get that transfer done. But here settlement is real time. All the ledger would be updated for everyone at the same time. Cost saving, the remittance thing we have seen. Security, it is, even though it is public, it is all governed by very strong cryptographic algorithms which cannot be broken. Immutability, once written, this is a very important property. These are some properties, security, all fine. When you go to any blockchain interview, or if you want to something, if you are discussing with your colleague or peer, okay, so one great feature is immutability. So it cannot be, once written in the chain is written and everyone will have this copy. And user pseudonymity, meaning that there is no account name as such. Okay, all it is gone by as a public key. So no one knows like who you are. So in a nutshell, they have tried to put a use of mathematics to create a secure ledger. This is just some without needing third parties. Anonymity and pseudonymity in cryptocurrency. If you look at Bitcoin, all your addresses are all public keys. You have some numbers. Now what happened sometime back in United States, there was some regulation. You all may be knowing about this website called, I think, Silk Road. So where this was in 2012 or 2011, people started using Bitcoins for crime, drug dealing, because it is all anonymous, right? No one knows the address. People just, send Bitcoins to this address and they deliver drugs to you. Some in some fashion. Even they kill people, I heard. So this website, it's called Dark Web. In fact, you can look at watch the TED video of Dark Web. It's very good. So these websites wouldn't be indexed in Google. So they used something like that and they were using Bitcoin. And then came this Bitcoin regulation that people or the government started tracking this address belongs to which IP. Previously, such tracking was not there. Now there is something that is getting tracked, like from which machine it got originated. What was the location this transaction? Externally or somewhere, they are trying to track this information in Bitcoin after 2013. So even though we say anonymous, you have public key and other things, still you are able to see, you are able to find out. If you go search in the blockchain.info, you will find out from where to where it is sent. Okay, the information from your address to whom you have sent the coins. Now there is a group of team called Zcash. They wanted to eliminate this. What they did is, Bitcoin is pseudonymous. It has some public key. Anonymous is nothing is known. So Zcash used this anonymous concept. Like you send some Bitcoins to X person will not know from where it has come. He will eventually get his Zcash, he will get his cryptocurrency, but he will not know that from where it has come. So those all would be encrypted and sent in the network. So that is Zcash, the one type of cryptocurrency. So this is more of a theory actually. So what all types of cryptocurrency are there? Even there are a lot of other currencies also, which is not mentioned here. See, these are some of the anonymous cryptocurrencies. Recently, you might have seen this Monero and Dash. I think Dash was all-time high. So let's see. There is an important, it's a double-edged sword. When you have a complete anonymous cryptocurrency, what they say is a double-edged sword, meaning that, see, people could use for drug trade and things like that. Okay, all corrupt things. At the same time, suppose if you want to deliver some political speech, that's example given here, or some critical message the military general wants to pass it on to someone else, very critical message. In that case, it is very good if it is anonymous, completely anonymous. It is based on case-to-case scenario. So these are some of the cryptocurrencies which uses anonymous concept. And here, so the idea, they are using a protocol like how we are using proof of work algorithm. We will not go deep dive into this ZK-SNARKs algorithm. Okay, but I will give an idea like how it is working. This ZK-SNARKs. It is called as zero knowledge proof SNARKs algorithm. So the idea is, I'll tell you one simple story. That is, it is easy to remember also. The story is like they would be looting the town, okay, in the night time, and they get all the jewels and other things, and they dump it in the cave, and then again they go back. That's how it works, right? That is a story. What happens is, moment they come to the cave, okay, they say some secret word, and the cave opens, and people go and dump their jewels. Okay, so that's how things were, per story. So the ZK-SNARKs algorithm, what it says is, you don't give me the key, but you prove me that you can get into that cave. So for that, what you will have to do? Suppose, let's say that I know the secret key, and I want Prashant to know that I know the secret key, but I should not give my key to Prashant. Okay, so what I can do is, I can invite Prashant or make him stand sometime back and open it and show him. I won't show the key, but I will open it and show him the proof that yes, I have opened. Okay, and then similarly I will close it and show him that I can close. Okay, but I will not reveal the key. Such an algorithm is this zero knowledge proof algorithm. So in the enterprise world, if you look at Ethereum, right? In the Ethereum world also, they have tried to incorporate this ZK-SNARKs algorithm for sending the transactions. Okay, recently it was launched like a month or month and a half back, when I did not go through completely. Okay, so they were trying to implement this algorithm, ZK-SNARKs algorithm, and this is getting very popular, especially in the enterprise network where they want to hide the transaction between two parties or hide the transaction between competitors. They wanted to go with this algorithm called zk-SNARKs. Okay, so problem with the anonymous cryptocurrency, we don't know who is backing it. It is not recognized. What if suddenly government says that it is totally anonymous and we want to reject it? So all those things, there is a problem. And pseudonymity, it is a pseudonym. Okay, you have been given another name. Likewise, if you look at Bitcoin, even though you have all public key, there is some, I see for now an IP address is also something, there is an association, and you can track this. If you're sending some money to X person, this can be tracked from where it started to where it ended. So here A's address is a pseudonym. What we have seen actually, from where it started, where it resolved, everything can be found out. For example, sometime back, I think this WannaCry virus, right? So once the WannaCry virus attacked, people were demanding in Bitcoins. If they demand in Bitcoins, they would have asked the Bitcoin address. So if they have given the address, they can track like where all it is passing. If it is a total, for example, if they have asked in a Zcash and they have given some address, and then they would not know that where it has gone. So now we will look at this programmable money, pay some close attention. Now we will see, we are going to see how the smart contracts, how the blockchain is help the enterprise world or even the public world, how it is working. Especially we'll focusing towards Ethereum now. So the example what they have given is, so there is Alice, there is Bob. Today Alice wants to purchase a car from Bob. And let's say that her criteria is emission test. So if the emission test is passed, Alice is ready to buy the car from Bob. So this is the criteria. Now what happens is, for example, let us say that she is purchasing a car from Amazon or some online mechanism. She is trying to purchase a car, or eBay or Craigslist, something like that. Okay, let's take Amazon for a simple example. Okay, so Amazon, she is finding the car and car is good. At least the pictures looks good. And what she is asking is, can you do an emission test? Bob takes the car and he does the emission test, okay, and then sends an email copy. And emission test is also passed. Now Alice is sending a fund to Bob, and now what happens? Bob is refusing to send the car. For some reason he says that no, my car is there, breakdown. Okay, I'll send it to you tomorrow. Now there is a problem here. And also, let's take suppose he's sending the car. Okay, let's say that scenario. Bob is sending the car, but emission test he has faked. He did not do the emission test properly, and he has faked and he has sent to Alice. And Alice now only knows that emission test has failed and Bob has cheated him. So let's see that how blockchain is solving this problem. So in blockchain, what we are doing is, here we are creating something called smart contract. Okay, smart contract is nothing but a piece of code, like how your transaction, like that, a piece of code which will be present in all the machines. Like how your blockchain, all transactions you have, right? Similarly, this piece of smart contract will be present in all the nodes in the network. In the smart contract, what is written? Let's see. Alice, some buy car, only buy car. For buying car, you need to send funds. Suppose let's say that $10,000. Now Bob has to send the car, and also emission test has to pass. So all these functionalities has to be done for a successful transfer of ownership, like the car from Alice to Bob has to do. What all things has to do? First, Alice has to look at the car elsewhere and she has to purchase. She should send some amount. And the condition, what is the condition she is mentioning? Emission test has to be passed. Then if that is the case, he would send and things would be fine. Okay, now what is happening with smart contract scenario is, Alice would be sending, I'll take, instead of dollars, let me take Ether, cryptocurrency for example. Alice would be sending 10,000 Ethers to this smart contract. This is a contract X. Let's say that this is a purchase contract. Now X has funds, and in the contract, what will be the next step? Emission test has to be conducted. So the emission party will come. So Alice, Bob, let us take one more property. Let us take CarZone or some company. Let's take Firestone. So now Firestone, is testing whether the emission test has passed. Once emission test is passed, he updates here that the emission test is passed. Then there is shipment. Okay, someone would be sending the car, right? Then the shipment company makes sure that the emission test is passed, and then he updates that he has shipped. Only then the amount will be sent to Bob. Unless that happens, the amount will be with the contract. Alice has sent to the purchase contract. This 10,000 Ethers, Alice has sent to the contract. Now contracts looks for the emission test. Emission test is clear. Then shipment is cleared. Only then the car would be shipped. Suppose in this case, let us take a negative scenario that emission test has failed. Then what will happen? In the contract itself would be defined that emission test is failed. Send back the 10,000 ethers back to Alice. Okay, so this one will be automatically the contract will send the amount back to Alice. What we have seen is how it can be programmed. The smart contract, how it can be programmed. So this is the Alice Bob car example. So what they're doing. So that is the example I've explained. Is there any other implementation of blockchain? Yes. So that is for smart contracts. That's how it evolved. After Bitcoin, then came Litecoin. Then after that, this one of the Bitcoin core developer named Vitalik, he started this company Ethereum, and that's why the smart contract concepts. So here what they mean is, in monetary aspect is just one piece of it.
What is Ethereum? Ethereum is actually an open source public distributed ledger system which is based on the original core blockchain idea itself. Now it also has few additional features like smart contracts, which is basically an application. Now how it is we'll be looking at ahead. Now when I talk about Ethereum, one of the most fundamental and important question that should come to your mind is that how is it different from Bitcoin blockchain? Now let's look at some of the key differences here. The first and the most important difference between Bitcoin and Ethereum is that the concept or the core idea or fundamental idea which brought these implementations out in the world today. Now, the core idea, if most of you are not aware of, was to bring a decentralized digital money into the world that was not governed by anyone and give the people the complete freedom to decide and work around with it. Now, there were a lot of challenges with respect to the existing monetary system, which we're not going to be discussing as part of this session, but this was the core idea of implementing Bitcoin blockchain. But at the same time, when you come down to Ethereum, although it is a derivative of Bitcoin blockchain, it's often referred to as the second generation of blockchain, because here people have understood what blockchain can be used for and have started using the various capabilities beyond the cryptocurrency market as well. The core idea of Ethereum was to build a world computing system. Now this would be a decentralized computing system where all the resources would be shared across, as well as the computing effort in itself would also be shared. So it's something that would be a world's first decentralized distributed computing system. Now, when you come down, the original idea of blockchain was conceptualized in 2008 and the initial release was in Jan 2009. But Ethereum's conceptualization started in 2013 and the first implementation came out in July 2015. Although the method of release of these coins were initially different, whereas in Bitcoins, you had to mine to get Bitcoins, and in Ethereum, they came up with a monetary system which was basically through an ICO, which is an initial coin investment system. Now, you hear a lot about ICOs and it's something that's gaining a lot of popularity. So if you guys are interested in ICO, do let us know. Maybe we can try and come up with a video on ICOs as well. Now, apart from this, one of the other key factors would be the amount of transactions each of them can process as well. Whereas Bitcoin blockchain can process only about 3 to 4 transactions per second, Ethereum blockchain can process about 15 transactions per second. And again, the time that is taken for creating a block also is slightly different. An average block in blockchain gets created every 10 minutes, whereas in Ethereum, it's about 12 to 15 seconds. Also, the reward system is also quite different, whereas in blockchain, it's about 12.5 Bitcoins. In Ethereum, it's only about 5 Ethers. Now, going forward, let's look at some of the key features which make Ethereum so popular, or the key factors which make Ethereum so effective and popular as well. Now, if you ask me, these are the 4 foundational pillars which make Ethereum so effective that's out there. Firstly, Ethereum is a blockchain-based implementation. Thereby, it does require any form of monetary system. Thereby, you have its own internal cryptocurrency, which is Ether. Apart from that, it came up with the idea of smart contracts, which is basically an application that would run on blockchain and process all the information present on the blockchain as well. It also brought in the idea of a decentralized organization, that is an organization that broke the foundational knowledge of a governing organization, as you can see in the modern society as well. It also helped to introduce the concept of smart property, wherein you could digitally transfer your property without having to face any of the hassles for exchanging the property or validating the documents as well. Let's talk about each one of them one by one. Let's talk about the cryptocurrency, which is Ether. Now, the most common Ethereum's cryptocurrency that you would be seeing out there is Ether, okay, which is actually listed as ETH on most cryptocurrency exchange and is something that's gaining a lot of popularity of recently as well. Now, why a separate cryptocurrency when there was Bitcoins already? Now, the idea here is to provide for the transaction fees as well as the computational service that you would run on Ethereum network itself. Now, there are various applications that will be running on this network. People put a lot of information. People customize the Ethereum network for their needs and necessities as well. So for all the operations that you would be running, there would be some amount of tokens that are going to be consumed to perform these computations. So these tokens are generally referred to as gas. So now gas in itself is something that you pay for. Okay, so basically the transaction fees that you would be charged would be for purchasing that gas as well. So again, any sort of computation that you want to perform, okay, you need to buy gas, and again, that's where Ethereum comes. So if you want to perform any operations on Ethereum, you need to buy gas, which is basically going to be deducted in form of Ether as well. Now, if you're providing a high transaction fees, then basically the chance of your operation getting completed faster would be high. Because again, this is something that miners would take as profit as well. But let's say if you provide too little a gas, then the transaction in itself may fail as well. It's completely left up to you to decide on the gas used for your computational process. Okay. Now going forward, let's talk about what exactly are smart contracts, because we've been talking and hearing about smart contracts for a while now. So let me just address this. To give you a standard definition, a smart contract basically is a computerized transaction protocol which in turn executes a term of a protocol. But in terms of a simple word, it's basically an application wherein you write a standard contract rules and it gets executed without having any change, because anything on the blockchain is completely immutable. This is something that is the core foundation of blockchain. So if I try to even manipulate a contract, it is not possible. Let's take the example of Alice and Bob, who actually have formed a physical contract and they're trying to put the information on a permission blockchain as well. This in turn would actually lead to a smart contract. Okay, now to give you another simple example, let's say I'm buying a house from either of you. Okay, now what happens is that you give me the money and finally I decide not to transfer the property. Then it becomes a loss for you, because firstly there could be a challenge that I would say that I do not receive the money or something like that, or any situation like that. This can be completely avoided firstly by putting it on blockchain, because the transaction that I would be taking from you would be completely visible and I can ensure, and blockchain in itself is immutable, so this cannot be rejected or it cannot be falsified as well. Apart from that, let's say I'm going to write a smart contract that says once I have received the money from you, transfer the property from me to you. That would get automatically executed when I would have a confirmation of payment from you. Okay, so this gets executed. But let's say if I write the condition that only and only if I get 5,000 ethers will I transfer the property, then what would happen is until and unless I get that 5,000 ethers, the transaction would not take place. That is, the contract would not get executed as well. So this in turn also ensures that falsification from both ends are not met. Okay, so this is something that's quite realistically, and since it's out there and open, wherein no human intervention can manipulate it, this becomes a trustless system wherein you don't have to put your trust on someone else, thereby making it quite easy for operations to work and quite transparent as well. Now, for those of you who are looking for an opportunity in blockchain domain, this is what you need to look out for, because today there's a huge demand for people who can write smart contracts as such. Okay, now let me give you a sample idea of what a smart contract would look like. So this is a sample contract that you are seeing. Okay, now this is a IDE which is Remix IDE. Okay, now by default you also get a ballot program here. I also have a hello world program written here. So even when you see here, there are various syntax coming here. Now I don't want to go in detail with respect to this, because this is written in a programming language called Solidity. Okay, Solidity in itself is one of the most popular programming language for writing smart contracts on the Ethereum blockchain. But since there are various implementations of Ethereum that people use, there are different languages that are also preferred as well with respect to that same. So definitely smart contracts and Ethereum is something that you should really look out for if you're looking for a developer job role. Okay, now this is just the simple environment. Now one idea here is when I look at the run option, it asks me what kind of environment do I want to use. A virtual environment, do I want to inject a Web3 or a Web3 provider as well. Now, usually what happens is, let's say if I'm trying to emulate it, I would be using a Web3 provider where I would provide it with account details as well. So if you see in the account, it has the public key of the account as well as it tells me the number of ethers that it has as well. Same time, I can also specify the limit of gas that has to be used for any operation and the value as well. Now, V, Gay, Fini and Ether are the different levels of Ether that you can see. Like how you have a Satoshi, which is the smallest unit in Bitcoin, you have a V that is present in Ether as well. Now, coming back, let's go back to our presentation. Now, here, the next and the most interesting part of Ethereum that I feel and would be the future for most blockchain based industries would be the decentralized autonomous organization. Now, talking about DAOs are basically organizations or group of people which completely exist entirely on the blockchain itself and are governed by the various protocols of blockchain. Now, what you need to understand is that blockchain is an open source technology which can be manipulated as per the user's requirement. So let's say if I'm forming an organization of various peoples, I can ensure that we come to a common understanding and then I can build this organization. First itself, I define these protocols. First itself, I create an understanding and then I create this organization. And then what I can do is basically I can create a unison of multiple long-term smart contracts which are present between these people itself. So any decision that needs to be made, any operation that needs to be done would all be written in smart contracts and these all would come together as well. Now, basically what they are is they are designed to hold on to the assets and use it in form of a voting system and manage their distribution as well. So let's say if there is someone who holds major assets, then he would have a higher priority as well. Now again, two or more entities within the DAO itself can interact with each other in a fully decentralized and automated fashion as well. So any communication thereby also is completely possible, and this is something that definitely happens on a regular basis as well. Now in a DAO, what you need to understand is that each action or a vote is represented by some form of transaction in that blockchain itself. Now, what you need to understand is that in case if any operation needs to be done, it will be in form of transaction as well. Now, again, to give you a quick idea, a group of people come and write smart contracts that govern that organization. People actually add funds to this DAO and are given tokens to represent their ownership as well. So more you invest, more tokens do you hold as well. And when the DAO begins to operate, each member proposes on how to spend this money as well. And based on the votes of the members, the proposal status is decided as such. Now, what you need to understand is that this is how going forward most organizations will definitely work out with, because this makes it quite easier, and also at the same time, you do not need to depend on a third party. You do not have to have the trust factor to go forward as well, thereby making it quite easy and effective as such.
Now, as the saying goes, necessity is the mother of all inventions, and it very well holds true in the case of Ethereum. With the invention of Bitcoin, the world truly understood for the first time the beauty and importance of a decentralized and distributed network, with no central authority ruling the network and trust being established in a transparent manner. Blockchain technology brought a fresh hope onto the table in the realms of data security and information integrity. Developers from all over the world were inspired by simplicity of the ideas that tie up intrinsically to make such a revolutionary technology that is blockchain. Now, with so many developers out there, it was only obvious that a few of them would try and invent their own use of the blockchain. Some developers created a blockchain for identity verification, while some made a blockchain service for taking care of gambling money in a secure and seamless fashion. Others created blockchain services for things like property sale, supply chain transfer, communication between Internet of Things, and whatnot. But if you guys notice something, that all these services serve one purpose. It's like having a big box of tools, with each tool serving only one purpose. The blockchain development community had come to a stagnant point where a developer would make protocols for his own use case, get the distribution, set up the hardware just for his own release. Even if a blockchain platform did have multiple features like a Swiss Army knife, there was no way we could add more features in the future in these platforms in a seamless fashion. This can be attributed to the very specific protocols that govern these different blockchain platforms. What the world needed was a generic platform where new features can be seamlessly integrated into the platform without worrying about things like hardware requirement, computation power, distribution, and this is the exact vision that Ethereum is built on. The creator of Ethereum, Vitalik Buterin, explains that Ethereum's platform has the generality of a smartphone. So what's so great about smartphones? Well, suppose you want to add a new feature to a smartphone. All you have to do as a developer is write the code instead of worrying about other peripheral issues like distribution, connectivity protocols, etc. He writes his code, pushes it to the desired platform's app store, and he's done. Ethereum works in a similar fashion. Developers who aspire to release a feature just simply write their code by defining it as a contract, and all he has to do is release it on Ethereum's network, where his service can be availed by anybody participating in that network. So now that we know the necessity that propelled the need for a platform like Ethereum, let's discuss the features it brings to the table. Now we must have a benchmark of comparison to see what is new in Ethereum, and in Bitcoin being the only notable blockchain before Ethereum makes it a very easy decision. So Bitcoin as a blockchain decentralized the financial system by removing the need of intermediaries like banks and other payment gateways like Visa and PayPal. Ethereum takes this idea way further and tries to decentralize most services imaginable. This is with the help of smart contracts. So before you guys get confused as to what a smart contract is, let me take a moment to explain them. So smart contracts are programs or pieces of code that run on the blockchain. Sure, in 2018, we have a lot of platforms that have smart contracts available, but it's the first platform, that is Ethereum, that brought about this massive change in the way we approach the concept and realms of decentralization. So Ethereum allowed code to be executed on the blockchain. Code being executed could be simulating various business logic like gambling, identity verification, payment verification, market trading, property sale, etc. This opens up blockchain to numerous fields being run by centralized authorities instead of just confining it to the simple bookkeeping of values. Aside from letting us run business logic on the blockchain, Ethereum also keeps a track of its state. So a bunch of you guys must be wondering what exactly is a state. So the state is a log of the current situation of the network, which can be also explained as the current information about the network, the smart contracts, and its users. Aside from all this, it also keeps a track of all the receipts, which are the results of any computation or processing on the network. Aside from these two, it obviously also tracks a ledger of all the account balances and transactions. So as you can see, Ethereum in its process of decentralizing the world brings a lot of new concepts to the table like states, receipts, and smart contracts. Okay, so as we had discussed, the difference that lets Ethereum shine amongst a plethora of blockchain platforms is its sense of generality, which makes adding new features a seamless process for developers. This is mainly possible with Ethereum's simplistic and generalized protocols. Let's take a quick look into them. Firstly, Ethereum has two types of accounts, the first being guest accounts and the second contract accounts. Guest accounts are owned by us everyday human beings, and these accounts are controlled with the help of a private key only known to the owner of the account. Contract accounts, on the other hand, are not owned by anyone. It is the address on the blockchain where smart contracts reside. As you might have already guessed, contract accounts are controlled by code. The key thing to understand here is that both these accounts have equal rights on the network. Equal rights in the sense that both types of accounts can send, receive, and store Ether, which is Ethereum's network-specific cryptocurrency. The second protocol states that anybody can create any application on the network with any rules by defining it as a contract, which means both guest accounts and contract accounts have the freedom to create an application with any set of rules as long as they're defined as a contract on some address on Ethereum's blockchain. The third protocol states a very defining characteristic of Ethereum as a platform. It states that anyone can interact with these smart contracts by sending them transactions. This lets smart contracts to interact with each other. So suppose there was a property sale application running on Ethereum which needed some sort of identity verification for its user base. The application could simply send a transaction to some other ID verification smart contract running on Ethereum. In this way of smart contracts communicating with each other, a lot of services can be tied in, and truly the marketplace can be decentralized. Last but not the least, like every other blockchain, Ethereum is also very much immutable. Even updates to smart contracts that were previously deployed have to be stored at a new address. This makes maintenance of smart contracts a little cumbersome, as previous users have to be redirected to a new address for the service. But I guess it's a shortcoming we all will learn to live with. So Ethereum advertises itself as the world's supercomputer, but in my opinion, it's more like an online vending machine which offers all sorts of services. Like any vending machine, all you need to do to avail a service is send that specified address some transaction. In my opinion, it's a very smart approach at a decentralized marketplace connecting all sorts of businesses, industries, and service providers alike. Now, some of you on the other side of the screen must be wondering as to where does all this computation get processed. Such large number of computation must be taking some ridiculous amounts of parallel processing. Well, to take care of this aspect, the Ethereum ecosystem provides us with 4 tools: the Ethereum Virtual Machine, Swarm or IPFS, which stands for Interplanetary File System, Then we have MIST, which is the Ethereum blockchain browser, and Whisper, which is the communication protocol. So let's go over them one by one. So the Ethereum virtual machine is a sandboxed environment where all the code is run. While it is also the heart of the Ethereum ecosystem, the Ethereum virtual machine is completely isolated from the rest of the main network. It is a perfect testing environment. Any company looking to create a smart contract can do so using the EVM without it affecting the main blockchain operations. Testing this technology is one of the most utmost importance, as flawed code can spell demise for even the most exciting of smart contracts. Second, we have IPFS, which serves as a decentralized storage unit for storing bigger files. Big files are broken into smaller chunks and hashed continuously and stored in a different address on the network by maintaining a hash table. Then we have Whisper, which is the communication protocol that lets all these components and smart contracts communicate with each other. Last but not the least, we have the MIST browser, which serves for browsing the blockchain, viewing its state, and deploying smart contracts and executing transactions. These four are generally called the pillars that hold Ethereum. Now one might say with so much computing power available, one might even try to overload the network by running a program that practically never stops executing. Well, Ethereum has an answer to this too. This problem is tackled by issuing computation credits called gas. The gas price per transaction or contract is set up to deal with the Turing-complete nature of Ethereum and its EVM, the idea being to limit infinite loops. So for example, if you have 10 Ether, which also computes to 1 gas, you can execute a line of code or some command. If there is not enough Ether in the account to perform the transaction or message, then it is considered invalid. The idea is to stop denial of service attacks from infinite loops, encourage efficiency in the code, and to make an attacker pay for the resources they use, from bandwidth through CPU calculations through storage. The more complex the command you wish to execute, the more gas you have to pay. For example, if A wants to send B 1 Ether unit, there would be a total cost of 1.0001 Ether to be paid by A. However, if A wanted to form a contract with B, depending on the future price of Ether, there would be more lines of code executable and more energy consumption placed on the distributed Ether network. And therefore, A would have to pay more than 1 gas done in the transaction. It's a neat system to keep computation overload in check. Okay, so now that we've generally covered the different aspects of Ethereum, enough for one to understand the needs and working of the technology, let's see some of the interesting applications that have been developed on the platform. Okay, so first things first, applications running on Ethereum's network are called decentralized applications. Their core logic is run with the help of smart contracts written in an Ethereum-specific scripting language called Solidity. These applications do not have a single point of service, so a denial of service attack on them is practically impossible. This means decentralized applications, while having no singular ruling authority, also offer zero downtime. So let's discuss a couple of my favorite decentralized applications. The first one on the list has to be 𝐒𝐿. I personally love the idea of this application and how blockchain makes this possible in such a smooth fashion. In today's music industry, distribution services like Play Music, Apple Music, Spotify, and other label records take a significant cut from the revenue made by artists for distributing their content. What 𝐒𝐿 does is, it connects the audience directly with the artist. In this way, when a person buys an album, the money is directly deposited into the artist's Ethereum wallet without any intermediary like Spotify taking a hefty cut from the principal. Not only does this take us a step forward towards a truly decentralized world, but also keeps indie artists who depend heavily on album revenue to continue their career. Second on the list, we have crypto movies. It's a place where you can trade movies with other people using the service. It's a great way for trading movies and watching titles that are generally not available without resorting to piracy. It's a neat service to replace movie rental services completely. Okay, so talking so much about decentralized applications, I guess you guys must be interested to see what one looks like from the inside. This brings us to the demonstration I promised you guys. So I have a simple decentralized application set up and ready. It's a simple jewelry store which runs on a decentralized network. What's the point of running it on a decentralized network? Well, not much at the moment, but this is just to give you guys an idea what the files that a blockchain developer actually working on Ethereum handles on a daily basis. So let's get started. First of all, let me show you guys the files that make up the project. So here we have a folder saying online jewelry shop. And as you guys can see that we have several folders out here. So the build folder out here contains the JSON file, which is the application binary interface of all the contracts that we have created. The application binary interface tells the contract and the HTML interface that what are the functions that are actually in the contract that are to be executed. Next, we have the contracts folder, which has very basic contracts. The first is a buying contract, which basically helps us buy jewelry and handles the logic for it, and it's written in Solidity. I'm not going to show you guys the code as you will not understand any of it. So let's move ahead. Next, we have the migrations folder. Now, these are two JavaScript files that actually help us migrate our code from this network to a test network. So suppose we actually have to test our code or deploy it on the main network. These are the migration files that help us. Next, we have the source code, which is basically the front end. We have our CSS stylings, we have our JavaScripts that handling the dynamic aspect of our site. And then we also have the index.html, which is basically our boilerplate HTML code. Next, we have the test folder, which contains the test buying Solidity contract, which is basically just to test our code on a test network. Next, we have the configuration files and the package files, which contain all the dependencies. Next, we also have the JavaScript file called Truffle. So in the Truffle JavaScript file, you actually have to specify the host and port network that you are going to deploy or test your smart contract on. So let's get started and see what this actually looks like. So first things first, let's actually run our test network. To do that, we are using this node package called 𝐬𝐻-CLI, which provides us with 10 accounts to actually fiddle around with our smart contracts. So go on command prompt and type in the command 𝐬𝐻-CLI if you have it installed, and you'll have these 10 accounts with their own specific public keys and private keys. You will also have this mnemonic, and we'll be copying it down and using it in some time. So next, we actually have to compile our code. For compiling our code, I'm using this neat framework called Truffle, which actually solves a lot of my issues. So first of all, we have to go into the folder. Once we're in the folder, I just tell Truffle that I have to compile my code. So I go Truffle command compile. As my code is already previously compiled, that's not showing anything, but this is how you do it. Then you have to migrate your code. So Truffle cmd migrate. Now, once our code has migrated, all we have to do is run our project. Now, you guys must be sure that we are running our project on a test network, and this is just for deploying and testing our stuff. So as you guys can see, our site has loaded up, and this is our decentralized application. We're selling a bunch of jewelry to people on a decentralized network without actually putting in intermediaries like proper jewelry stores in the middle. So before we go ahead, we have to install this thing called MetaMask, which actually bridges our decentralized applications and the test network that we are running in the background. To do that, we go ahead and download MetaMask. MetaMask is a Chrome extension and can be easily downloaded from the Chrome Web Store. So just go here and say add to Chrome, add extension. Yeah, and that does it for us. Next, we have to set up MetaMask. So you just click accept, go down, click accept again. And now, instead of creating a new password, go and click on import existing den. Now, as you guys remember that there was this mnemonic that was generated by 𝐬𝐻-CLI, we have to go and copy down that thing. Copy this thing down, paste it out here, and give yourself a new password. So as you can see, we've connected our decentralized application to the test network. Well, only one step is left out here. We actually have to tell MetaMask that it's running on localhost 8545. As you guys can see, we have 99 ethers to spend, and we'll be going on spending our stuff now. So suppose anybody comes onto our shop and wants to buy something. So yeah, you just go and click purchase now, and MetaMask will tell you that you have initiated a transaction. You submit your transaction and wait for it to get mined. And once it's mined, it should show a success out there. So as you guys can see, we once purchased our diamond ring and it shows a success. Our transaction can be seen on the 𝐬𝐻-CLI command thing, and as you can see out here that a new block was formed when our transaction was initiated. So this is how people, or rather Ethereum blockchain developers, work on a daily basis by testing and deploying their smart contracts and decentralized applications. So coming back to our session, let me tell you about Ethereum's course at Edureka. At Edureka, we teach Ethereum in a very structured and modular way. You'll be going through beginner level topics like Blockchain 101 and even advanced topics like the Ethereum architecture, the basics of Solidity programming, and decentralized application development. Edureka provides live instructor-led online training, and leaving that aside, Edureka also provides a 24/7 support team that is there to guide you through your technical and non-technical issues that are related to the course. Once you enroll for a batch, you will be provided with a lifetime access to Edureka's carefully crafted learning management system. The learning management system will contain your class recording, presentation, PDFs, and information regarding your projects. At Edureka, once you enroll for a course, you can even reassign your batch at your own convenience. If you're not satisfied with a single go-through of the course, you can even sign up for future batches n number of times. Classes that you miss are recorded and uploaded to your learning management system just to make sure you really never miss out on anything. When blockchain was released back in 2009, people didn't know what to really use it for, other than the general bookkeeping of transactions. Well, it's been almost a decade since blockchain was invented, and we've come across really interesting use cases that implement the blockchain in their own unique ways. One such use case is Ethereum, which was the first blockchain platform that implemented the concept of smart contracts. So what exactly is a smart contract? Well, a proper definition states that a smart contract are executable logic that runs on a blockchain network. This basically means that smart contracts are just simple programs that run on the blockchain. This opens up the blockchain to be used in a variety of sectors. Smart contracts are available that control the logic behind simple things like gambling, asset transfer, vote counting, etc. Blockchain is also the ideal space for smart contract storing due to its decentralized nature. This allows smart contracts to realize transactions without the need of an intermediary. Even though the first application of the concepts of a smart contract was with the launch of Ethereum, the genesis of the idea dates back to early 1994, and the entire credit goes to Nick Schwab. Nick was well known as a cryptographer and a computer scientist. He introduced his idea of electronic contracts that would handle protocols regarding e-commerce when strangers met on the internet. In 1998, Nick even designed a mechanism for a decentralized digital currency called Bitgold. Even though it was never implemented, it acts as a direct precursor to the Bitcoin architecture. Today, we have numerous blockchain platforms other than Ethereum that support smart contract functionality. For example, Hyperledger Fabric, NEM, and Stellar. Regardless of the platform they are deployed in, smart contracts have some general key properties. Firstly, every smart contract is autonomous in nature. This means that once a developer has created his logic and deployed it on the blockchain as a smart contract, he does not need to participate in any of its processes. Smart contracts are also auto-sufficient, which means that they can collect money, realize transactions, distribute resources, issue and spend to allow a larger capacity of storage and computation power. Lastly, smart contracts are decentralized. They are distributed by various network points instead of being focused on one single central source. Smart contracts are mostly developed in their network-specific languages, like Solidity, Serpent, Viper, but there are application programming interfaces these days that allow developers to develop their smart contract in languages they are familiar with, for example, Python and JavaScript. Smart contracts come with their advantages and disadvantages. Let's discuss their advantages first. First of all, smart contracts assure complete safety and security as data in a decentralized registry cannot be lost or hacked. Secondly, they remove third parties and hence assure agent neutrality in signing of deals. Next, as smart contracts are completely automated, this means that it performs the job with utmost precision without a chance for human error. And since everything is automated and run by code, it also saves a lot of precious time. Like every technology, smart contracts too have their own shortcomings. Firstly, they are a hassle to maintain. As things are immutable on a blockchain, this means that every time you update your smart contract, you have to deploy it as a completely new contract at a new address. The concept of a distributed and decentralized backend service is difficult to understand for inexperienced developers. Since it is a new technology, people generally tend to be suspicious and skeptic when implementing smart contracts. Now that we've seen the pros and cons, let's see the tools available for helping us build our smart contracts. Every contract firstly needs a wallet to store its transaction values in. There are many wallets available like Mist, Armory, and Multibit which serve this purpose. Secondly, we need a framework which makes our lives as a developer much easier for deploying these contracts. Good examples of frameworks include Hyperledger Fabric and Truffle. We also need a compiler for our scripting language, but these can be easily replaced by online compilers like Remix and Composer Playground. Lastly, we need a test network to actually test our smart contracts on, as once they are deployed on a regular blockchain network, they become immutable. Smart contracts have seen some really interesting use cases over time. Let's go through a few of them. Gambling, for one, has been made secure and lightning fast with the use of smart contracts. Voting smart contracts exist that make the process completely transparent and corruption-free. Smart contracts are also being used to speed up processes involving deal signing, for example, financial agreements and insurance policies. Other than that, Smart contracts are also being used to automate entire organizations where things like payment distribution, incentive handling are completely automated. These organizations are commonly known as decentralized automated organizations. Now that we've seen everything about smart contracts, it's time we deploy our own smart contract on our test network. For this exercise, we're going to need Node.js and NPM installed and updated to the latest version. For the following exercise, we'll be using the following technologies. We'll be using 𝐓𝐵𝐺𝐽𝑠 framework to interact with our smart contracts through a front-end API. We'll be using TestRPC as our test network, and we'll be using Solidity to develop our contracts, and compiling them will be done through the Remix browser. So without much ado, let's get started. To get started, we must go to the Remix browser first. As you can see, you get a smart contract out here. So we'll be creating our own smart contract. So press the sign button and give it any name you want. So we'll be compiling our smart contract through this Remix browser, and we'll be developing it in Solidity. This contract will not be very complicated, as the motive of this exercise is to show how you can deploy your own smart contracts and test them on a test network. So let's get started. We define our contract with the contract keyword, and we'll call it demo. Now we need one variable, and it's going to be a string, and it's going to be public, and it's going to be called name. We're going to make two functions, one to set the name, so function set name, which takes an argument string and sets that string to the name variable. Next, we need a function that gets the name, so function get name, and this is going to be view only and a public nature, and it'll return a string. So it's going to return the variable name. Now that we've created our smart contract, it's time to compile it. So you just go and press start compile, and as you see, we only have warnings which we don't really care about, and we don't have any errors in the smart contract. So next, we will need to set up our test network. For that, open command prompt and go npm -g ganache CLI. Now you just wait for it to install. Now that it's installed, just type in the command ganache CLI, and this should start up your test network. So as you see, that our test network is up and running, and this gives us 10 accounts. These are the public keys, and these are the private keys. So on the Remix browser, go to the Run tab and change the environment to Web3 provider. Click OK. And as you see, the provider has been changed to the Web3 provider, which is running on the test RPC. So now we need to create our contract, and it's been created at this address. Now it's time that we create our front end for this contract. So to do that, you open command prompt again, go to desktop, okay, and you make a folder. So we're going to call our folder test, and you go into that folder and you go npm init. Just press enter through all these questions and you're done. So we've basically initialized our JSON files. So now we need to also install our framework. So for that, we go npm install --save, so that it gets saved as a dependency in the JSON file, and Ethereum.js, Ethereum/web3.js. Oh, I made a spelling mistake. This won't get installed properly. npm install Ethereum/web3.js. Once the framework is installed, just go and check in the folder. You should have 3 folders, one with node modules, and you should have this web3 folder out here. So now we'll have to create our front end. So for that, we're going to create a new file. So go to the folder where you install web3.js in and initialize your project and create a new text file. We'll call this index. It shouldn't be a text file. So we're going to save this as in the same folder. We've got an index.html. So now we just put in the HTML boilerplate, and we're going to call our web page smart contract tutorial. Second of all, we need to include our script. So the source is, go to the node modules, you go to web3, you go to dist, and you just copy this thing. And don't forget to change these. And in the end, type web3.js. Now we've done that, we will create our HTML for this particular thing. So it's going to be very simple. We have a div, and in this div, we're going to have an input. So input type will be text, and we have given name. We'll give it a placeholder. We enter name, and now we're going to have a button. So button, and we're going to call it set name. Let's give this, and we're going to have an output part, and this is just empty. So let's give these some IDs. So let's give this an ID of input. This will have an ID of button, and now this will have an ID of output. So let's see what this looks like. Yeah, so we have our basic thing. So if I type in my name and set name, something should come out here. So let's get that working. For that, we need our script. And so let's declare a variable called web3. We're going to be using this variable to reference our framework. So if type of web3 is unequals to undefined, I'm going to set the network provider to web3 equals new current provider. So if it's an undefined type, we set to the current provider, and else web3 equals new web3 dot providers dot http provider. It's gonna be, what was our CMD running at? It was running at localhost 8545 if I'm not wrong. So http. So now that we've specified our provider, we need to specify our default account. So web3.ed.default account .ed.accounts. This basically means that we're setting the first account as the default account, and we'll be doing all our transactions based on this. So now we need to define a contract. So our new contract equals to web3.ed. Now we need to paste in our contracts ABI out here. The ABI stands for Application Binary Interface. To get the Application Binary Interface, go to the Compile tab, go on Details, and you basically need to just copy this small thing out here. Wait. Yeah, this thing, ABI. Copy this and just paste it out here. This basically shows what functions are there in the contract. Next, we need to instantiate our contract. So var contract equals to new contract dot add. So dot add, we specify the address of our contract, which was basically this. So that's the address that our contract has been deployed at on a test network. Now we need to do some fiddling. So let's get our outputs and inputs. Var and we need to just Control-C. We'll give them a different name. This was the input, and it had an ID of input. And this was the output, and this had an ID of button, and we're going to call it button. Okay, so now we go contract dot. What was the name of our contracts function? It was set name. So contract dot set name will give us, should be input dot value, and this should only happen when we click on our button. So we're listening for a click, and our callback function will basically do this. So we selected all the elements of our contract, of our HTML rather, and then whenever somebody clicks the button and sets the name, we're going to get an output from the contract get name. So let's save this now. File, save, and let's try running it. Looks like we made an error. HTML 83. Oh yeah, I forgot this. That should have fixed it. Cannot read property providers of undefined. HTML 27. I forgot the new keyword out here. And okay, so document.getElement 79. Okay, this needs to be small. That was a mistake. Yeah, seems like we've run out of errors to solve now. So basically this should go, yep, now you see, we've deployed a contract on the smart contract, and now we're getting the output out here. So basically what happens is our contract is running at this address out here, right here. It knows what's in the contract through this application binary interface, which we see right here. And basically Web3.js just lets us interact with our contracts.
Now, before we start with our first topic, let me just brief you on why Ethereum is needed. Well, most of you here might already be familiar with the Bitcoin blockchain. Bitcoin is the original blockchain entity for providing a decentralized system to facilitate peer-to-peer exchange of values. Ethereum, on the other hand, came up from the idea that blockchain could be used for a number of purposes beyond the bookkeeping of financial transactions. So we can also say that Ethereum maximizes the usage of potential blockchain applications. Now coming back to our original topic, that is, what exactly is Ethereum? So guys, Ethereum is an open source distributed platform that allows decentralized apps to be built on it with the help of smart contract functionality. It was developed by Vitalik Buterin as an extension to the original core blockchain concept. Let me give you an analogy. Think of the Ethereum network as a collection of decentralized and distributed vending machines. Now you go and you put in tokens inside these vending machines and then specify the action that you want to be taken by pressing in the numbers. Now whenever each number is pressed, a certain code gets executed inside the machine. These are the smart contracts. And then a service is provided to the concerned user on the network. Now the tokens that you had put inside the machine were actually ethers. Ethers are the cryptocurrency token of the Ethereum network, and they're used to pay for the transaction fees. There's also another parameter called gas, about which we'll talk later, that is used to pay for the computational services on the Ethereum network. Now since we're still talking about transactions over here, I'm sure some of you might be wondering, why was there a need to develop Ethereum in the first place when Bitcoin blockchain already existed? So I'll give you a clear understanding on how Ethereum differs from the Bitcoin blockchain on various fronts. Now firstly, both these blockchains are conceptually different from each other. While Bitcoin's core idea was to bring a decentralized digital money that is not governed by anyone, Ethereum, although a derivative, extends beyond the realm of cryptocurrencies. That is why it is also referred to as the second generation of blockchain. Now talking about the cryptocurrency tokens, Bitcoin's crypto is named after itself and it's called Bitcoin Cash, whereas Ethereum's crypto token is called Ethers like we just discussed. Now coming to the scripting language, Ethereum is a Turing-complete scripting language, whereas Bitcoin is a simple stack-based language and it is not Turing-complete. What I mean when I say the word Turing-complete is a language that can solve any computational problem by itself, given enough time and energy. Now next we come to the consensus algorithms. Bitcoin uses the SHA-256 hash algorithm, while Ethereum's algorithm is called ETH-hash. Both of these are proof of work currently. However, Ethereum will move to proof of stake in the near future as a part of its scalability plan. Now, proof of stake is still an algorithm with the same purpose as proof of work, but unlike it, where the miners are rewarded for solving the mathematical problem with the goal of validating transactions and then creating a new block, with proof of stake, the creator of the block is chosen depending on its wealth or stake. So, more the number of tokens you own, more would be your mining power. Now, even the coin release method of both the blockchains were different. While Bitcoin came through the mining of the Genesis block, so the first miner earned some Bitcoins as a reward, Ethereum's coins were released through initial coin offerings to raise funds for the new cryptocurrency. The average block creation time of both the blockchains vary, where it takes around 10 minutes for each new block to be created on a Bitcoin blockchain. In the Ethereum blockchain, a new block is formed in every 15 seconds. This is quite faster. Now, since we're talking about Ethereum, we have to discuss about the types of Ethereum accounts. As we can see here, there are two types of Ethereum accounts: the externally owned accounts that are owned by people or organizations, and the contract accounts which are autonomous in nature. Now, these externally owned accounts are controlled by private keys which are owned by individuals. But on the other hand, the contract accounts have associated contract codes, and these are triggered by the transactions or the messages received by other contracts or other externally owned accounts. Now, the contracts that we are talking about here are actually the smart contracts. Contract accounts operate on codes which are written in smart contracts. Now, the users can create a new contract by deploying code to the blockchain. Now, guys, smart contracts are basically immutable pieces of codes that run on the Ethereum network to perform a certain transaction or task. And when these contracts are running on the blockchain, they act like a self-operating computer program that automatically executes when specific conditions are met. Let me give you an example of this. A contract between two parties is written as a code on the blockchain. Now, the individuals involved are anonymous, but the contract is public to everyone on the blockchain. So when a triggering event occurs, which in this case is a bet on an ongoing cricket match, the contract executes itself according to the terms of the code. Therefore, if England wins the match, Bob will receive 10 ethers. But if England loses the match, Andy will receive 10 ethers, and both their wallets will be updated accordingly. Now, the codes in these smart contracts are written in a special contract-specific language called Solidity. A question will naturally arise over here that why was there a need to develop a contract-specific language? Why couldn't we just use the already existing languages like C, C++, Java instead? So, let's see why Solidity is preferred over other languages. Now, Solidity's syntax is very similar to JavaScript. It was developed because using the mainstream languages on a public blockchain won't really add value, because firstly, there are security requirements. You see, anything that gets recorded on the blockchain becomes immutable, so there is absolutely no window for bug fixes. And secondly, it costs money for executing each instruction on the program. So if you were to use C language or Serpent, for example, to write a smart contract, then you may end up with a very expensive contract and not even know why. If you guys want to create your own smart contract, then you can do that by using the Remix IDE. Now, this is a browser-based IDE and it's widely used for developing the smart contracts since it has an integrated debugging and testing environment. Now, here's what a Remix IDE looks like. The contract codes are written over here. This is the compile tab. Now, whenever a new line of code is added to the contract, it gets compiled automatically. This is the Run tab, under which we can specify the environment, the account addresses along with the associated number of ethers, the gas limit, and the value in ways. Now every time you write a code here, you can create a contract by clicking on the create button. Now guys, we'll be writing a demo contract to understand better how all of this works. But before that, let me talk about the EVM where all of these contracts are actually executed. EVM, or the Ethereum Virtual Machine, is a Turing-complete software that runs on the Ethereum network. It enables anyone to run a program regardless of the programming language, and even non-specialized programmers can create a program on the EVM. Let me tell you how all of this works. A user requests 2 ethers, for example, from the sender. Now the sender initiates the transaction message code and must pay for each step of the program that they activated, including the computations and the memory storage. Now this fee is paid in ethers, which is taken from the wallet of the sender. Then this transaction fee is collected by the nodes in the network that run the EVM. Now each and every node of the network runs the EVM to execute the same instruction, and this is how the blockchain database is maintained and updated by the many nodes connected to the network. Now all of these nodes are actually the miner nodes that execute and verify the transactions and then update the state of the accounts on the Ethereum blockchain. In turn, they're rewarded with ethers for each successful block mining. Now once the transaction is verified and recorded, the user gets 2 ethers in his wallet. Now, I'm sure some of you programmers out there might be wondering the same as what our little guy here is thinking about, that if the EVM is running the application code, then what's preventing a piece of code from running forever and overloading the network? Well, here's where the term Ethereum gas comes in. Now, gas is basically the execution fee that the sender pays for running a program on the EVM. It's called gas because the fee acts as a crypto fuel driving the execution in smart contracts. Now, every contract specifies the gas limit, which is the maximum quantity of gas that can be consumed. If you guys want, you can just go to your browser and type in the ETH gas station and click on the first link. Now, here's where you can see the gas used for the current transaction. You can also see the gas price and the top 10 miners that have mined the blocks. You can see the cheapest gas price and the highest gas price, and also the confirmation time by the gas price. Now, gas price is specified at the start by the initiator of the transaction. Now, as the transaction starts, the gas used times gas price number of ethers are subtracted from the sender's account. So when a program crosses the gas limit, the execution reverts and the ethers are not refunded. So guys, it's very important to keep your program well within the set limits of the gas. Okay guys, now we come to the most interesting part of our tutorial, that is how to deploy smart contracts. So we've just learned that smart contracts must pay gas for the computations on the Ethereum network. Hence, if you rent the Ethereum network to run a contract, you'd have to pay for it. So before deploying an actual contract on the Ethereum blockchain, we need to experiment because we cannot afford to make any mistakes as anything deployed on the blockchain becomes immutable and costs gas. So we use testnets for developing demonstrated smart contracts, and these testnets simulate the Ethereum network with providing free and unlimited gas. So this allows the developers to test contracts without having to pay real money for their execution. Now I'll walk you through setting up a development environment so that you can deploy and test your own smart contracts on the Ethereum test blockchain. We're going to create a test environment on the Ubuntu Linux platform, and since I myself have the Windows operating system, I'll be using the Oracle VirtualBox to run Ubuntu. Now let's open the CLI. To run a network, we need a server. So we need to install Node.js and the Node Package Manager, since Node.js will simulate the test server on our local machine. NPM, or the Node Package Manager, is a command line interface program to manage the Node.js libraries. Now we'll run the following command on our terminal to install Node.js. Sudo apt-get install Node.js. We'll type in the password. It's asking for confirmation. Tap Y. And now we'll just wait for our Node.js to get installed. Now we'll also install the npm package. For that we'll use the same installation command. sudo apt-get install npm. Do you want to continue? Yes. And now we'll just wait for npm to get installed as well. Alright, let's just check the version of the Node.js and the npm that we have installed. So we'll type in node.js-v. The version is 4.2.6 and npm-v. The version is 3.5.2. Now guys, this is not the latest version, so we need to upgrade our node packages since we need the upgraded versions for running the further commands. For that, we need to install curl first. So we'll type the installation command sudo apt-get install curl. Now curl is a tool that is used to transfer data from the server. Now we have installed curl, so we'll just pull the entire node package from curl, and for that we'll use the following link. Now note that the 6.x here denotes the version of the Node.js, that is 6, that we want to install. Now we'll install the latest Node.js package using the same installation command sudo apt-get install node.js. Do you want to continue? Of course I do. And now we'll just wait for our latest Node.js package to get installed. Now let's check the Node.js version. Node.js-v. The version is 6.13, so it's cool. Now let's upgrade our npm as well, and for that we'll use the following command. Sudo npm upgrade npm -g. Now -g is used for the global installation so that we can access it throughout our system. Now we'll just wait for our npm to get updated. So guys, our npm has upgraded to version 5.7, which is great. Now let me just clear the screen for your convenience. Okay, now guys, we need to run the test RPC on our terminal to deploy and test our blockchain contract. Now test RPC is a Node.js based Ethereum client for testing and development. For that, we need to create a test RPC file. So we type in the following command. Sudo npm install -g --CLI. Now note that sudo is used so that the user has an authority over the existing files. --CLI only runs when our Node.js version is at least greater than 6.11, and ours is 6.13, which looks good. So now we'll just wait for it to get installed. This might take a little while. Now to install the test RPC file, we'll run the following command. Sudo npm install -g ethereum.js test RPC. With this command, we'll add all the node packages on our local machine. So now we have created our test RPC file. Now let's run it and see what happens. Alright, looks great. The test RPC is running and listening on localhost 8545. Now guys, you can see the available accounts as well as the private keys over here, and we'll be using these for our contract deployment. Okay. Now we just open a new terminal because our test RPC is running on this one. Let me increase the font. Okay. Now next what we need to do is install the Block Explorer to help us keep track of the information on the blockchain. For that, we first need to install Git. Now Git is a distributed version control system that holds the repository of our Block Explorer in this case. So for that, we'll use our installation command, that is sudo apt-get install git. We'll enter the password. And seems like I already have Git on my system. But anyway, you can use the same command to install Git on your systems as well. Okay. Now we need to get a copy of the Explorer on our local machine. And so we'll use the following command. Git clone https github.com/etherparty/explorer. Now we can see that it's cloning into Explorer. Now it's basically pulling a clone of the repository from the cloud to our system. Okay, so it's done. Now we'll just change the directory to the Explorer by using the following command. cd explorer. Now guys, cd here stands for change directory. We'll just press enter. And now we can see that our directory has been changed to Explorer. Okay. Now guys, if you want to launch the Block Explorer, you'll use the following command. Sudo npm start. Now this command will install all the packages on our system. Okay, so we'll just wait for it to get installed. Now we can see the Explorer running on port 8000 over here. Alright. Now guys, if you want to view the Block Explorer, you simply need to go to your web browser. I installed Chrome because it's preferable to me. And then type in localhost 8000 on the browser tab. Now here we can see the Ether Block Explorer page has been opened, and this is where all the transactions are being recorded on the Ethereum test network. So now that we have set up a test environment, let's create a demo smart contract to deploy it on our Ethereum test blockchain. For that, go to your browser and open the Remix IDE. Now go to the Run tab and specify the environment as Web3 provider. They'll ask you if you want to connect to an Ethereum node. Click OK. Our Web3 provider endpoint is localhost 8545. Click OK again. Now guys, if this message pops up that it's not possible to connect to the Web3 provider, then all you need to do is go to your browser tab, click here and load the unsafe scripts. Now we'll go to our Run tab again and specify the environment once more. Click OK, click OK. Now we can see the associated accounts that were in our test RPC file that we created, along with the associated number of ethers as well. Okay. If you want, you can go to your file location and just open the test RPC file. Now these are all the account addresses, and this is the same as you can see over here. Okay, now we'll create a demo contract so that you guys get an idea about how a smart contract is executed. Now we'll write a contract to increase and decrease the value of the variable, let's say named counter. So we'll just open a file and let's name it my contract 001. Now these contracts are basically a collection of code functions that correspond to a specific account address on the blockchain, as you can see here. So now we'll start writing our contract. For that, we'll first specify the source code version. So we'll type in Pragma Solidity version 4.1. Now guys, note that the latest version of Solidity is 4.16, but that won't be supported by our system, so I'm using 4.1. If you want, you can use 4.16. That will not really make any difference in the program that we are writing right now. Okay. Now Pragma is the instruction for the compiler about how to treat the source code. Now since we're creating a contract, we'll use the keyword contract and let's name it as my contract. Now our entire contract would be written within this scope. Now we'll specify our state variable, that is counter, with the value 5. So we'll type in uint256 counter equal to 5. Don't forget the semicolons, guys. Now uint256 is basically the type of the variable, that is unsigned integer of 256 bits. Now this creates a slot in the database that can be accessed whenever a function in the code is called. Now also note that we need to keep the state variable outside of all the functions so that they can be accessed globally. Now we'll write a function, say add, which will increment the value of our counter by 1, counter plus plus, okay? Similarly, we'll create another function. Let's call it subtract. And this function would be used to decrement the value of counter by 1. So we'll write counter minus minus, okay? Now note that the access modifier in both these functions is public. Guys, although public is the default modifier when no visibility is specified, typing out the function visibility is a good habit, so you should always do it. Now there are other access modifiers like external, internal or private, but we do not need to know about them right now. What we need now is a function to output the value of the counter as it changes with the functions called. So we'll just write a function and we'll name it getCounter. GetCounter. The access modifier is public here as well. And since this function is going to return a constant, so we'll use in the constant keyword. Return counter. Now guys, note that we must tell our function the type of the state variable it will return. So we have specified u in 256 over here, since this is the type of our counter state variable. Now whenever a function is called, a small amount of gas is spent, but no gas is required when returning a constant function. Alright? So guys, we've just finished creating our very first contract on the Remix IDE. Now let's test our first contract by clicking on the Create tab. Here you can see all the 3 functions that we have created just now. Now if you tap on getCounter, we get the value of our counter as 5. If you tap on Add once and then again on getCounter, you'll see that our value of counter has incremented by 1 and has become 6 now. Now let's tap on Subtract twice and then again on getCounter. We see that the value of our counter is 4 now. Alright. Now we'll open our Block Explorer to see the details of this transaction. Here, we'll just refresh it. And as you can see here, our contract has been successfully deployed on the Ethereum test blockchain. So now we have seen how the Ethereum is used as a platform to create smart contracts. Now guys, once you start creating your contracts and deploy and execute them on your blockchain, you will be ready to get started with creating full-on decentralized applications. Now we're not going to go into details of the dApp development, but I'll introduce you to what dApps are. Well, a decentralized application or a dApp is a set of smart contracts that operate on the data stored in those contracts. Now an application qualifies as a dApp only when it is open sourced, when it's decentralized, it has tokens fueling for itself, it generates tokens, and has an inbuilt consensus mechanism. Now these dApps enable direct interaction between the users and the providers, and they're comprised of various organizations that work together to create an application. Now these organizations are basically the decentralized autonomous organizations or the DAOs. Now guys, a DAO is very similar to a normal company. Now the only difference is that in a normal company, there is a third party, of course, and the rules are not enforced digitally. But the DAOs have their business decisions made electronically through the codes written in the smart contracts or through the vote of their members. Now the priority of these votes depend on the percentage of the assets that the entities within a DAO hold. Let me tell you in detail how all of this happens. People add funds to the DAO and are given tokens to represent their percentage of assets. So more you invest, more number of tokens you would hold. Now when a DAO begins to operate, the members propose on how to spend the funds, and based on the votes, the proposal status is decided. This way you do not need a third party to depend on, and hence more effective operations can take place. A number of possibly disruptive dApps have already appeared in the market and are continuously being deployed on the Ethereum platform. A few of them being YFund, 4G Capital, Storj.io, and the KYC chain. Now these are a few of the most famous dApps and DAOs that are in the market currently. YFund is a dApp that uses the smart contracts to enhance crowdfunding services like GoFundMe and Kickstarter. 4G Capital is a DAO that provides microloans for small businesses in Africa. Storage.io provides censorship-free, secure cloud storage by sharing data among a decentralized network of computers. And last but not the least, the KYC chain allows the users to maintain a private identity wallet that can be used to authenticate the identification in finance and commerce settings.
What is Bitcoin? Now, Bitcoin was the first cryptocurrency introduced by Satoshi Nakamoto in 2009. Now, the idea originally came from a white paper published by Satoshi Nakamoto with the name Bitcoin, a peer-to-peer electronic cash system. Now, this is the paper as such. This talks about how a cryptocurrency can be used and how it can revolutionize the present system. Now, this came at a time when the current financial system, that was back in 2008, was facing the financial crisis. So this became a key idea as to avoid how this financial crisis can be avoided in future and can change the current existing system as a whole. Now, apart from being the first cryptocurrency, it is also a digital currency. That is, it exists electronically as such. Now, there may be concerns if our money exists on the digital platform. So to avoid any misuse, we use various cryptographic as well as mathematical algorithms which ensure that the creation as well as management of Bitcoins are completely secure as well as non-manipulative. Now, using these techniques, we can ensure that no person can create fake Bitcoins. Now, we've all seen the issue of fake currency notes in our system. So these techniques ensure that no fake Bitcoins are introduced as part of the system. Now, one thing that you need to be aware of is that while introducing the Bitcoin system, it was said that the Bitcoin limit, that is, there can only be 21 million Bitcoins globally. Now, don't worry, because there can be only 20 million Bitcoins, because you can own the smallest Bitcoin, which is 100 millionth of a Bitcoin, known as a Satoshi, and still be part of the Bitcoin system. Now, you may be wondering, it's a digital currency, where is it going to be stored? Similar to how you store your money in your Paytm or your PayPal wallet, this can also be stored in a Bitcoin wallet. Now, this wallet can either be present on your phone, it could be present on your system, it could be present online, or even on a hardware device as such, for your convenience as accordingly. Now, the system or the ledger wherein all the transactions that are added with respect to the Bitcoin is known as the blockchain system. This is an electronically distributed ledger system that is distributed across the globe. Now, before we go into the blockchain system and talk more about it, let's first try to understand how a Bitcoin transaction takes place. To give you a better understanding of how a Bitcoin transaction takes place, let's take an example here. Here we have 7 people: Thomas, Lily, James, Matthew, Mary, Adam, and John. They're all part of a peer-to-peer network where each of them are connected to each other. Now here, Thomas wants to send 500 Bitcoins to Matthew. So what he needs to do is that this transaction, that is, needs to be initiated. So he would send a signal that I want to send Matthew 500 Bitcoins. So what happens is, special nodes or miners as such, these are people who verify all these transactions. They get the signal that Thomas wants to send 500 Bitcoins to Matthew. So they immediately begin validating this transaction. They begin to check if Thomas has sufficient balance and is it Matthew that he wants to send this. They want to check if this is not a false transaction as such. Now, if this transaction is a valid transaction, it needs to be stored somewhere, and that place is known as a block. A block basically is a collection of different transactions that are verified as such. Now, at the same time, you have a competition between John and Adam as to who will create the first block with Thomas's transaction. Once either of them have verified this transaction, they're going to suggest to everyone else as part of the network that this is a valid transaction and the amount can get deducted from Thomas's account and can be sent to Matthew's account. Now, you may be wondering, why would John actually spend time as well as Adam waste their resource in verifying these transactions? That's where the blockchain system or the Bitcoin system surprises you. For a block that is going to be created by either John or Adam or any miner, the system in itself gives them a reward of 12.5 Bitcoins. Now, this is an incentive which the system gives the miner for creating the new block. Quite surprising, right? Definitely. Now, what you need to understand is that for all the effort that these people put, this is basically how the system pays back. But you also need to be aware that this is exactly how a new Bitcoin gets created. So in case if you're wondering how Bitcoins are getting created, this is the only way. Unless and until a miner completes a block, the new Bitcoins would not get created. As of now, of the 21 million Bitcoins, we've created close to 16.5 million Bitcoins as a whole. Now, I hope with this explanation, you've got a simple understanding of how a Bitcoin transaction actually takes place. Now, before we move into blockchain system, I'm quite sure you also already have an understanding of what the blockchain system is. Because in the Bitcoin transaction example that we had taken, we had talked about a peer-to-peer network where this transaction was taking place. That's exactly what blockchain is. It's a technology which revolutionized the Bitcoin system. It became a platform where people could trade as well as buy and sell Bitcoins as per their requirements. Now, as we had mentioned earlier, a block basically contains all the transactions that have been verified and validated in that time span. Now, once you've completed this block, you begin the process on the next block and you keep going on so forth. All these blocks are connected to each other and so forth comes the name blockchain. Now, the blockchain technology is not something that is restricted only to transaction management or the banking domain as such. Now, how you're storing transaction details, you can use it to store any other kind of details as per your requirement, and this is one of the key factors which has led to the growth of blockchain technology being used across different domains. I hope you've understood how effective blockchain technology is. Moving forward, let's talk about the various features of blockchain. Why does it stand out with respect to all the other technologies in the market? Now, if any technology is coming into the picture, the first thing that we are concerned about is the security. Blockchain technology uses an SHA-256 encryption algorithm. Now, here what happens is you're using a hash algorithm. So what you need to understand is that once you've given an input, you generate a hash output. But from the output, you cannot regenerate the input. That is, it's a unidirectional process. So even if you have the output, you cannot determine what the input is. And this encryption algorithm is so complex that even if you make a slight change with respect to the input, the output completely changes. So let's take an example. Let's say I'm going to encrypt I love blockchain through the hash algorithm. It's going to give me a corresponding hash value. Same input, I'm just going to add an exclamation mark and pass it through the encryption algorithm. But the output that gets generated is totally different. If I look at both the outputs, I would not be able to identify that it's the same input just with an addition of an exclamation mark. So I hope this gives you a simple understanding of how the hashing algorithm works. Then comes the distributed public ledger. Now, as I had mentioned earlier, all the transactions that you would be performing using Bitcoins is going to be stored on the blockchain system. So therein you have a ledger. But this ledger is not a centralized ledger like how you have in banks. This ledger is completely distributed, and anyone who becomes part of this blockchain network can get access to the Bitcoin transaction details as well as the blockchain ledger as whole. So everyone who becomes a part of it gets their own unique copy of their blockchain ledger. But you don't need to be concerned because this ledger is available to anyone. The details with respect to the transaction that are present in this ledger are completely secure. They are encrypted as well as they are passed through the hash encryption. Now, one thing you need to notice is that the user details are not specified as part of this. Only the transaction ID is present in the ledger. So this in turn also provides the anonymity to the user, as well as you're not completely aware who holds how much Bitcoins, and this makes the system completely decentralized as well as open. Although it gives you a complete open idea of how much is being used in the system, it is really helpful to come across with respect to the other domains that are present. Now, we've also talked about the third point, wherein the blockchain system, that is, it rewards you for creating the new block, that is, the incentives that you get. Now, 12.5 Bitcoins is the present rate as such. This would keep varying as such. Now, don't think just because you can create a block, you get this reward, because it's not as simple as you think. There are two parts to this. You need to verify all the transactions that are present, as well as you need to identify a mathematical value. Now, I'm not going to talk about the mathematical value here. We'll be talking about that ahead. Okay, so what you need to do is that you need to create a block in a fixed time frame, because the present time frame is 10 minutes for creating a block. So unless and until you cannot create the block in that time, you cannot get the reward. At the same time, you're competing with all the miners who are present across the globe. So it basically is a race against time. The final key point which makes the blockchain feature quite popular is the proof of work. Remember the mathematical solution I was talking to you about? This basically is what a miner needs to compute. Apart from verifying and validating all the transactions that he has, he needs to identify this mathematical solution. You may be thinking, okay, it's a mathematical solution. I can run it on my computer and find out. It's not that easy. There's always a fixed value that is set for every block that is going to be created. Let's say you're going to create the next block, which is 500th block as part of the blockchain system. So there's going to be a specific value that you need to identify with respect to the specific block. But what you need to do is that you need to guess this mathematical value. It's just a hit and run method. Given the present scenario, you need to at least try somewhere between 20 quadrillion to 30 quadrillion values. That's a huge number. At the same time, you need to remember that it's a race against time. So you need to verify all the transactions, you need to compute this mathematical solution, and all this should happen in 10 minutes time frame. And this is exactly why the incentives are also given out to the miners, because they do all this work within this fixed time frame, and once you've computed this mathematical solution, then no one can tell that this reward that is given to you is unjust, because you've put in your resource, you have put in your time to compute the block, you've put in time to verify all the transactions, and the system is rewarding for all your work. So this proof of work in itself is a very valid signal, sending across to everyone that I have done this work, I have validated all the transactions that were given to me, as well as I have created the next block. Moving forward, we'll talk about how a Bitcoin transaction can take place and how you can purchase a Bitcoin. Now, so this is the application that we would be using. So this is the application known as 𝐓𝐵 that we will be using for buying Bitcoins as well as selling Bitcoins and trading as such. Now, I'll just give you a simple overview as to how you can perform transactions using the 𝐓𝐵 application. Now, once you've installed the application from the Google Play Store, you just need to click on the option and verify yourself. There are three things that you need to provide to them. First is the details with respect to your PAN card. You need to provide them a copy of your PAN card as well as fill in this form. Then you need to provide them details with respect to your bank. So in case if you're selling any Bitcoins, the money needs to be transferred to your bank account. So that details needs to be provided here. Apart from that, you need to provide them with your address details. Once you've done with this, they would go ahead with their verification process, and this would take somewhere between a day to 3 days as such. Finally, once you've got the confirmation from the 𝐓𝐵 team, then you can begin to purchase Bitcoins and sell them as well. Now here, as you can see, I have already some money as well as some Bitcoins in my wallet. So first thing what you need to do is that you need to load some money into your 𝐓𝐵 wallet. So for that, just click on deposit option. Okay, here you need to specify the amount, and then you can transfer the amount either using RTGS, NEFT, IMPS, or through net banking. Now, I would recommend that you go through net banking because this is faster in comparison to the other means. Now, as you can see here, I've already loaded some money into my account. Okay, I already have close to 0.026 Bitcoins, and I'll show you how you can purchase Bitcoins as well. Now, if you click on the buy option here, you can see the present rate offered by 𝐓𝐵 for buying Bitcoins, and this is constantly changing rate. So let's say I'm going to use all my amount, that's 2,513 rupees. Okay, so below that you can see how many Bitcoins I'm going to get. Now the minimum amount that you need to spend while buying Bitcoins through 𝐓𝐵 is 1,000 rupees, and the maximum at present is 7.5 lakhs. Beyond that, you can contact the 𝐓𝐵 team and they'll be able to assist you. Now once you specified the amount, click on buy, and the transaction is about to get initiated. Before that, you need to set your security pin. So let me confirm this. And the purchase has begun. Now this transaction is almost immediately because 𝐓𝐵 in itself holds certain amount of Bitcoins and they release it to you immediately. And as you can see, I've also got a message notification telling me that Bitcoins have been added to my account. So here you can see the present amount. I have close to 0.1 Bitcoin present in my account, which is also equivalent to 3,394 rupees as such. At any given point, if you feel that you want to sell your Bitcoins as such, just click on the sell option and you can sell any amount of bitcoins you want. Let's say you want to sell all of it, just click on sell all and all the bitcoins are going to get sold. Now let me show you how you can perform a transaction using Bitcoin. So this is an example of a Bitcoin wallet. Here my Bitcoin is present in my Bitcoin 𝐓𝐵 wallet as such. So from this wallet, I'm going to send it to a different wallet as such. Okay, so click on the send option here, and it's going to ask you whether you have the Bitcoin address or do you want to scan it. Now, if you click on the B icon present in the bottom, then you have option to either manually enter their address or you can scan a QR code. Now, most Bitcoin wallets today come with a QR code, so you can directly scan it. In my case, I already have my address, so I'm going to paste it here. So I'll just set it a name as Bitcoin demo. And I'll save it. So here you can see it is asking me how much do I want to send. So let's say I want to send it all. So I click on send all. It shows me how many bitcoins are going to be sent. But if you see just below that, there's an option known as Bitcoin network fees. So if you click on that, you can see the fees with respect to the amount that you're sending. Now, although the Bitcoin and blockchain technologies were initially introduced with the idea of no transaction fees, but certain wallets do add a specific transaction fees to increase the priority of your transaction. Now here, once I click on send, the transaction is going to get initiated. So I've also got a mail notification that 𝐓𝐵 has sent my bitcoins to my Bitcoin wallet. Now let me show you what my Bitcoin. Now, while I'm waiting for this, let me just also show you another feature of the blockchain wallet. Let's say you've sent a transaction or you've received an amount from someone and you want to verify or you want to check the status of it. Okay, so seems like I've already received my bitcoins. Okay, so let's say for any transactions, if you want to check the status. Okay, so once you click on the transaction, you get the details. So here you can see the transaction has been confirmed. This was a transaction that I had performed earlier today. Okay, so to see more status with respect to your transaction, just click on this option and you're redirected to blockchain.info. Here you can see the details of the transaction that I have mentioned. This is the address, that is my blockchain wallet address, and this is sent to my Bitcoin wallet address. Okay, so this is a different account that I'm setting it to. So you can see the details with respect to this, and this can be viewed for any transactions. This is open to anyone who's part of the blockchain. So any transaction that you want to verify or validate can be seen on the blockchain.info website as such. Okay, so here you can see apart from getting confirmation, it also says pending 3 confirmations. This basically is to ensure that this transaction as such is not a false transaction. So there's a certain delay with respect to this. Although the amount is credited into my account, I cannot use it right now.
When everyone has access to global market, great ideas flourish. That's the ideology of both these platforms, which is why both are open source digital currencies. Now, what makes Ethereum and Bitcoin similar? Just like Bitcoins, Ethereum also has a digital currency which is named as Ether. And both these valuable cryptocurrencies uses the proof of work mining. Alright? Now, even though both are blockchain implementation, they serve different purpose. And that is why there are stark, obvious difference between the two of them. Alright, before we undertake an analysis of these two cryptocurrencies and platform, let me give you a quick introduction of Bitcoin and Ethereum. So let's talk about Bitcoins first. So what is Bitcoin? Bitcoin can be quickly described as a digital money. It is a decentralized global currency issued by a code stored across the globe. The quick introduction for Bitcoin regarding the coding aspect is that everyone can download a computer program which stores all transactions in a chain of blocks called blockchain, obviously, and through which it can validate that you are the owner of the Bitcoin while ensuring that you can spend it only once. Alright, fine. Moving on ahead. So what is Ethereum? Ethereum is a world computer for developing decentralized application. Just like Bitcoins, all the parameters applies for Ethereum too. But on top of that, Ethereum also has a smart contract making the currency aspect as just one application. Because Ethereum can run programs like any ordinary computer at a global scale, right? So just like Bitcoin, it has a software which you can download. The software does all the usual verification regarding Ethereum. But on top of it, it also verifies the code wherever applicable. Fine. So to churn it down, Ethereum can be defined as a decentralized platform for programming a digital money. Okay, so this was a brief introduction of Ethereum and Bitcoin. So let's start with our first comparison. So the first parameter being the cryptocurrency. Now, if you compare the coins based on purpose they were developed, you will see that Bitcoins was created after the 2008 financial crisis with a vision to remove the dependencies on third parties to facilitate the transaction and hence disintermediation. Ethereum, on the other hand, serves two main purposes. Firstly, it is a cryptocurrency that is used to run the state machine of Ethereum. So you see, Ether is a fuel that is used to pay for every single computational step. The invention of Ethereum makes it expensive to use up to too much of blockchain computer's capacity. Ether is the fuel you need to run smart contracts. If considering an analogy, if Bitcoin was a digital gold, then Ether is a digital oil. Fine. Secondly, apart from that, Ether is also traded on exchange just like any other cryptocurrencies out there in the market. Fine. So next we'll compare the two based on the accounts. So let's see in the case of Bitcoin what we do in the case of accounts. Bitcoins does not have a distinct account, but it maintains the ledger of unspent transaction output, or simply said, it maintains the state of where the coins are flowing. On the other hand, Ethereum maintains proper accounts. Accounts play a central role in Ethereum. There are basically two types of accounts in Ethereum. First being the externally owned account, the EOAs, and the second being the contract accounts. Accounts have balance, and contracts have both balance and contract storage. The state of all account is the state of the Ethereum network, which is updated with every block and which the network really needs to reach a consensus about. Accounts are essential for users to interact with Ethereum blockchain via transactions. Accounts represent identities of external agents, example, human personas, mining nodes, and automated agents. Accounts use public key cryptography to sign transactions so that the EVM can securely validate the identity of the transaction sender. Externally owned account maintain the state of the balance and has ether balance, can send transaction and is controlled by private keys. Fine. Next is the contract account. It maintains the state of balance and storage. It also has ether and the associated code. The code execution is triggered by transactions or messages received from other contracts. Now, since we are at the smart contract, let's differentiate the two coins on the basis of smart contract functionality. So a third parameter of comparison is smart contract. While Bitcoin has a built-in scripting language, it's very limited in functionality and with only a few dozen operations. Now, Ethereum has a full general-purpose language integrated in it, known in computer speak as Turing-complete. Programs written in this language are known as smart contracts. Now, you would ask, what is smart contract? Now, these smart contracts are pre-written logic stored and replicated on a blockchain, which is executed by a network of computers and can result in blockchain updates. So guys, you can see that Ethereum takes a distinctive lead when it comes to programming on a platform. It has the potential to help notoriously difficult industries. So imagine the case of investment, where your selling and buying of stock is done for you by the code itself. Also in the case of insurance, where you can automatically trigger the claim whenever the event occurs. Another important application of smart contract could be in the supply chain management and even the fundraising part. Yeah, the fundraising could be made easier with smart contracts. Rather than being limited to a specific set of transaction types, user will be able to use Ethereum as a sort of Lego of crypto finance. That is to say, one will be able to implement any feature that one desires simply by coding it in Ethereum's language. That is why people believe that Ethereum is potentially more lucrative than Bitcoins. Fine. Now let's move ahead and compare Bitcoin and Ethereum on the basis of transaction as a key attribute. So transaction throughput in Bitcoin is close to around 3 transactions per second, which is almost 5 times lesser than in Ethereum. So Ethereum takes a huge lead in case of transaction processing speed. Let's have a closer look at the calculations here. Talking about the Bitcoins first, the maximum block size by average transaction size will give you the average transaction per block, which is close to around 2000 transactions per block. Unlike in Bitcoin, there is no fixed megabyte limit for the size of the block. In Ethereum, a block size is limited by a total gas consumption limit. For instance, in April 2016, the total gas limit amounted to around 4712388 gas, which can be spent on every block. So the average transaction per block can be calculated as average gas limit defined for a block divided by average gas for a transaction, which is 225 transactions per block approximately. Now, don't you think that's way too much of a difference because both of these platforms follows almost the same technology? If you noticed, I said that technology is just similar. Where it differs is the way they have implemented consensus algorithm. Fine. Talking about consensus, you see the Bitcoin's proof of work algorithm has some limitation. The network is vast and growing, and hence a transaction takes considerable amount of time to propagate in a network, which causes the ambiguity in the network of Bitcoin. Also, another limitation of Bitcoin is that since the miners are the stakeholders of the network, the top mining pools control the 75% of all the mining activity, which causes the centralization in the system. Now, to tackle this problem, Ethereum has adopted the Ghost protocol that brings some efficiency gains to the proof of work. Now, Ghost solves the first issue of network security loss by including stale blocks in the calculation of which is the longest chain. That is to say, not just the parent and further ancestor of the block, but also the stale descendants of the block's ancestor. In Ethereum jargon, uncles are added to the calculation of which block has the largest total proof of work backing it. To solve the second issue of centralization, Ethereum implements a simplified version of Ghost, which only goes down one level. Specifically, a stale block can only be included as an uncle by the direct child of one of its direct siblings, or not by any block with a more distant relation. So Ethereum's modified proof of work implementation does adds to the efficiency of Ethereum's network. Positively, Ghost protocol also alters the process of mining in Ethereum. Let's see how mining differs in Bitcoin and Ethereum. The mining in Bitcoin has evolved a lot. In beginning, the CPUs were used for mining of Bitcoin. But as the computational power of the network increased, the GPUs took over the CPUs, and eventually now the ASIC miners are used to mine the Bitcoins. While in case of Ethereum, the Ethereum is ASIC resistant. ASIC should not have any benefit at all because it's just general computation. And to top it off, contracts can be released that are specifically ASIC hard, so there would be an active disincentive to using ASICs. Another interesting thing that doesn't seem pointed out in the white paper is that the memory must be fast, excessively fast. So standard DRAM isn't up to the challenge. That is why the RAM on GPUs take the brunt of the work in most mining today. Ethereum is an advancement based on the principle of blockchain that supports Bitcoin, but with a purpose that does not compete with Bitcoin. So which one do you think is better? Is it Ethereum or Bitcoin? Well, that's for you to decide. And also it depends on how you're using it or what is the purpose of your use. Alright, now if you ask a developer's opinion, now I'd say that Ethereum has its obvious advantage. So both Bitcoin and Ethereum are different versions of using the blockchain technology and are set to establish themselves driven by different intentions. Now, just like Bitcoin, Ethereum, Ripple, there are many new impactful cryptocurrencies and tokens which are arriving in the market every day. So learn the basic of cryptocurrency.
So let's get to comparing blockchains and hash graphs. So the first point that we're going to compare them is the throughput. So Hashgraph improves on the performance statistics of the Bitcoin network. Bitcoin operates at a maximum of 7 transactions per second, while Hashgraph is only limited in relation to bandwidth and allows for over 250,000 transactions per second. Now, the major component of Hashgraph is its virtual voting and gossip mechanism, which makes the system much faster, fairer, and more secure than a blockchain. Now, the next point that we're going to compare hash graphs and blockchain is fairness. So, how is a hash graph fair? Here, fairness refers to the ability of distributed ledger technologies to prevent nodes from manipulating the order of transactions. Hash graph is fair because no single node can manipulate the transactions, and the transactions are serialized with cryptographic timestamping. Unlike in a blockchain, where miners determine the order at which transactions are placed within each block, the transaction order can be extremely important. For instance, consider purchasing the same crypto asset where the first buyer will likely get a cheaper price. So let's say 2 people, Andy and Bob, are transacting separately in a blockchain network. Now, a blockchain miner can choose to include Andy's transactions and delay Bob's transactions, which get added later in the blockchain when processed by other miners. However, in a hash graph, an individual must include both transactions in order they were received. So the next point that we're going to actually compare hash graphs to blockchain is the provability and the verifiability of both the technologies. So in hash graph, the transaction can be verified within a few seconds. Every node will be aware of the occurrences of new transactions, and everyone in the community knows where the transaction is directed. Moreover, everyone will be aware that all the community members know about the transaction, and eventually the transaction gets deleted. Now, in a blockchain, the transactions are available to everyone, considering it's a public blockchain, and the transactions are recorded forever in an immutable ledger. Now, unlike blockchain, there is no need to carry the previous record in the ledger. That is why less than 1 gigabyte of storage is needed in hash graphs, whereas Bitcoin uses around 60 gigabytes of storage. So even your mobile phone can be processing a node. Now, the next point that we're going to actually compare hash graphs and blockchain is a Byzantine agreement. So this term means that no single member can hold up the community from reaching a consensus. It also prohibits consensus from being disturbed, and once consensus has been reached, the smaller group or individual cannot change it, and every member will know that the network has reached consensus. On the contrary, blockchain is not Byzantine protected. The blockchain architecture is organized in such a way that miners are pigeonholed into boxes, and advancement of the block is dependent on the computing power of participating nodes. In such a scenario, a group of miners can discard the current consensus, and then they can create their own consensus by forking from the original chain. They can also exploit their hardware superiority to guide or stall the progress of the entire blockchain. So moving on to the next point is cost and performance. Now, no mined transactions ever become stale. This is because the list of transactions, or what's equivalent to the blockchain, is never discarded by the community. All transactions are utilized to reach consensus, whereas in the blockchain, transactions are put into the containers called blocks that form a single long chain. If two miners create two blocks at the same time, the community will eventually select one and discard the other, resulting in wastage of efforts. So in hash graphs, every container is used and none are discarded. And as we have seen with the Bitcoin blockchain, public networks can be expensive to run and have a number of efficiency issues tied to the proof of work mechanism. Since Hashgraph is proven to be fully asynchronous Byzantine, this means it makes no assumptions about how fast messages are passed over the internet, and no proof of work is needed, which makes Hashgraph both cheap and efficient. Now, the next point we are going to compare them is security, and especially the security from DDoS attacks. Now, Hashgraphs is safe from denial of service attacks because an attack on one member of a network will not stop the community from continuing processing transactions successfully. A total DOS attack is impossible as the attacker has to penetrate into every node system at the same time. The blockchain is resistant to DOS attacks as well. So are you guys already having a feeling that Hashgraph is better? Well, give it a thought. Now, despite its obvious benefits, Hashgraph has some way to go before it can boast of the network effects enjoyed by both Bitcoin and Ethereum. So first of all, it's not open source. One of the biggest buzzes about Hashgraph in the community is the fact that it is patented. This means that Lehman Baird decides who can build on it, who can't. For now, while he uses this to build on commercial networks such as a COL ledger. Also, currently, it can operate in a permission setting. Today, there is no public distributed ledger, and what will happen when the verification script will have to run at every gossip? There exactly is no clarity. So the adoption process for a distributed ledger seems to be very challenging. Now, in the Hashgraph protocol, each node has to store the totality of the Hashgraph, and we really don't know how restrictive that could be. So overall, when we compare Hashgraph versus a blockchain, Hashgraph seems like a superior distributed ledger technology, and it has also all the core features of a blockchain. So let us all appreciate the underlying technology in Hashgraph, but not with closed or blind eyes. And while we appreciate Hashgraph, we should also appreciate blockchains which have paved ways to likes of Hashgraph in just the same way they have paved the way for Ethereum, EOS, NEO, and many more.
Now, before I tell you what Hyperledger is, let me tell you what Hyperledger isn't, because it's really easy to get confused in today's world with so many blockchain platforms around. So firstly, Hyperledger is not a cryptocurrency that so many people seem to be interested in today's world. Above that, Hyperledger is not a blockchain, and neither is it a company. So what exactly is Hyperledger? Well, to begin with, Hyperledger is a project under the Linux Foundation. So like other projects under the Linux Foundation, for example, Node.js, Aljoin, DroneCode, and many more, Hyperledger is also an open source development project where people from all over the planet can come and help Hyperledger get developed as a software and as a platform. Now, according to the executive director of Hyperledger, Brian Behlendorf, Hyperledger is an open source community of communities to benefit an ecosystem of Hyperledger-based solution providers and users focused on blockchain-related use cases that will work across a variety of industrial sectors. So what exactly does that mean? Well, in simpler terms and analogies, Hyperledger can be thought of as a software that enables developers all across the globe to develop blockchain-based solutions for their particular businesses. At this point, some of you who are slightly versed with the blockchain technology might be thinking that, hey, we have platforms like Ethereum. Why can't they do what Hyperledger does? Well, the ethos of Hyperledger is that it believes every business or industry is unique in its own ways, and applications tending to that service must be personalized, unlike the Ethereum blockchain, which runs on a very generalized protocol for everything that runs on its network. You will see what I mean in a short while. Now, let me give you a brief history about Hyperledger before delving deeper into its mechanics. So first of all, Hyperledger began as a small project by a limited number of developers who came from various sectors like finance, supply, and data management. All these people had one common goal in mind, and that is to make the blockchain as a technology more accessible to the world. So with these things in mind, developers started testing the interactions between applications and secure blockchain networks. While rigorous testing between the two, developers involved realized that public blockchains that require each peer to execute each and every transaction and run consensus at the same time too takes a huge blow when it comes to scalability, as the network takes a really exhaustive measure to ensure security. Above that, any transaction that has a measure of confidentiality and privacy attached to it cannot be executed on the blockchain due to its public nature, as every ledger on the network will get updated and confidentiality is lost. To understand the concept of a private and confidential contract, look at a simplistic example. Let's say Bob in India wants to buy chocolates from his friend Alice, who lives in Switzerland. As they were old friends, Alice decides to sell Bob her chocolates at a pretty generous discount. But the catch here is that Alice also supplies to a number of different markets, which still need to buy chocolates from her at the standard rate. Above that, to actually get her chocolates from Switzerland to India, there are a number of procedures to fulfill. For example, firstly, she sends her chocolates to the mailing service, which in turn validates the supply. After a product is packed and sealed, logistic verification takes place. After that, during shipping, distribution logic is verified and validated, and in the end, payment verification is done before the package finally reaches Bob. But the point here is that even though there are so many third parties involved in the transaction, they do not need to know about Alice's and Bob's special deal. Now, when this whole transaction is run on a public blockchain network, where every peer has to go through every transaction, confidentiality of the deal becomes void, and every single ledger on the network gets updated about Alice's and Bob's special deal. This is where Hyperledger comes and wins the game. On a Hyperledger-based network, the parties who are directly affiliated with the deal are connected. The ledgers that get updated about the special deal are only Alice and Bob, thus maintaining the private and confidential aspect of the contract. Let's see how Hyperledger actually pulls this off. It all starts with Alice looking up Bob through an app, which in return sends the query to a membership service, and sends the transaction only to the peers directly affiliated. Both the parties now will generate a result. In this two-party agreement, both results generated need to be the same for it to get validated. But in other transactions, where there are multiple different parties, other rules can also be applied as needed. The validated transactions are then sent to a consensus cloud for ordering. These ordered transactions are sent back to the affiliated peers and then committed to their ledgers. This same pattern of a transaction is needed by multiple industries, where private and confidential obligations are need to be met by multiple parties without processing everything through a single centralized authority. Now that I've told you what Hyperledger is, how it pulls off a permissioned blockchain network, let's go through the architectural changes that make this all possible. The most notable changes can be seen in the peers, which make up the whole network. The peers are separated into two different runtimes and three distinct roles, namely endorsers, committers, and consenters. While endorsers and committer peers are executed on the same runtime, the consenter peers are run on a completely separate runtime. This allows Hyperledger's modular architecture to allow properties like consensus to be a plug-and-play feature, which in return allows a high degree of personalization to the network according to the needs of the business. Now, let us go over the peer roles. Firstly, the peer role we are going to discuss is that of a committer. The most simplistic role is that of a committer node. Their only role is to append validated and ordered transactions to the specific ledger once returned by the consenters. Normally, a committer can work as an endorser on the same network, but as more and more restrictions are imposed on the network, the merging of endorsers and committers are completely avoided. The second role is that of an endorser. These nodes simulate the transactions pertaining to the network and also prevent the occurrences of non-deterministic and unstable transactions. It is important to note that while committers may or may not be endorsers depending on the network restrictions, all endorsers act as committers on a hyperledger network. Lastly, we have the consenters, which work on a different runtime. These nodes are responsible for running the consensus algorithm on a network and can be very well thought of as the bodyguard of the network who validates every transaction, deciding whether or not it should be added to a ledger. Now that we know what Hyperledger is, where it's necessary, and how it works, let's compare Hyperledger to the two most renowned blockchain networks, and that is Bitcoin and Ethereum. Starting with cryptocurrencies, while Bitcoin and Ethereum both have their respective currencies, Hyperledger has no official coin. But if a business deems necessary that they need a coin for themselves, they can always implement one. Moving on to networks, Bitcoin and Ethereum are both highly public blockchain networks. Hyperledger, on the other hand, is a consortium blockchain, which is also known as a permission network. Talking about consensus algorithms, Bitcoin uses SHA-256, which stands for Secure Hashing Algorithm 256, and Ethereum uses another hashing algorithm called eth-hash. Erstwhile, Hyperledger uses a completely new concept called practical fault Byzantine tolerance, which basically checks how much time a transaction has resided on a machine. Bitcoin has no support for smart contracts or any sort of business logic for that matter. On the other hand, Ethereum and Hyperledger both support smart contracts. Ethereum smart contracts are mostly written in Solidity, while Hyperledger smart contracts are written in chain code. On the topic of the language each network is written in, Bitcoin is written in C++, while Ethereum and Hyperledger use a mix of Golang along with Python or Java respectively. Talking about projects under Hyperledger, there are a few noteworthy ones like Hyperledger Fabric and Sawtooth. Hyperledger Fabric is being extensively used in the supply chains and market networks, and Sawtooth has seen success in the fishing industry. There's also Hyperledger Iroha, which is used for developing blockchain-based mobile applications. Another project, Hyperledger Indy, is used for decentralized identification databases for business networks.
What is Internet of Things? Now, before we talk about IOTA, it's quite important that you understand what Internet of Things is. Now, Internet of Things has gained a lot of buzz today. Internet of Things basically lets you connect everyday things which are around us, which have an embedded technology in terms of electronics, software, or even a sensor to the internet, and which enables us to collect and exchange data to have a smarter system as a whole. Now, this in turn makes it quite easy for us to have a day-to-day experience as well. A smart home is something that we all want, and that's also something that's quite possible. In today's world, we all live with sensors and electronic devices around us. So having a smarter environment definitely is something that's quite useful as well. Although IOTA is believed to be the third generation of blockchain, let's first try to address and understand what IOTA is. IOTA basically is an open source distributed ledger system which focuses on providing secure communication and payments between machines rather than individuals on the Internet of Things platform. Now, what it does is that it implements two greatest technologies of this era, blockchain and Internet of Things, and it brings it together with respect to this platform as well. Now, you might be wondering why we cannot use any of these other implementations for the Internet of Things implementation. Now, the idea here is that each of these blockchain implementations, although has its own advantage, also has a set of disadvantage as well. Now, let's take the Bitcoin blockchain implementation itself. Now, one of the major challenges when I look at that implementation is that there is a bottleneck that happens when it comes to creation of blocks and validation in itself. What happens is that only a single block gets created every 10 minutes. Now, although there are millions of users today that are out there that are using the Bitcoin blockchain implementation, but let's think about the scalability when it comes to Internet of Things. There are close to 1 trillion Internet of Things devices that will be available by 2020. Now, handling the data coming from trillions of devices is not easy when you need to provide a secure communication channel with them, as well as validate and manage the payment that are happening between these devices. Now, the idea of building a blockchain implementation for Internet of Things is so that the machines themselves can communicate with each other and perform the transactions without human involvement. What basically I want to imply here is quite straightforward. Let's take an example to understand this better. Let's take an example of a smart home. Now, let's say I have a community where a lot of smart homes are available. One of the major requirements in a smart home is cleaning. And as you might have noticed today, there are a lot of smart home cleaners that are available today.
But let's take a realistic scenario. How many of us would actually like to buy a smart home cleaner which would actually run just once a week? Not a lot of us, to be practical. But what I can do is that I can get a few devices for the community, and let's say if I want a service of that device, what I'll basically do is that my smart home will communicate with that device. It will request a specific time slot for the cleaning up of the house, and the payment would be made by the home itself. So here the machines are communicating with each other and creating a payment based system for the service that they are providing as well. So this is how the artificial intelligence and IoT environment is growing quite rapidly. And today we have a lot of this quite possible as well. Don't think what I'm telling is something that's quite far distant into the future. This is quite realistically possible in the next few years itself. Now let's look at some of the key features which make IOTA stand up in comparison to most of the other blockchain implementations that are out there today in the market. One of the most key factors which makes IOTA quite easy and effective in the platform of Internet of Things is the capability of its scalability. Now in comparison, yes, IOTA can have a lot more cryptocurrencies generated. Yes, it can manage a lot more number of transactions as well. Now, if you are comparing one of the most essential factor for any cryptocurrency or any blockchain implementation, I would go with transactions per second. That is how much amount of information can be processed per second. Now, if you take the Bitcoin implementation, basically it can handle about 3 to 5 transactions. And if you look at Ethereum, that's close to 15 transactions per second. IOTA, on the other hand, can handle close to 1,000 transactions. And again, it can keep growing as well. Now, this is just a recent stress-based information that I'm telling you. The highest would be Ripple with about 1,200 transactions per second. But again, the ideology with respect to Ripple again is quite similar with Bitcoin, although it can handle a lot more transactions. But there's always the issue of a single information source being created here as well. Now we'll be addressing this while we go forward and how IOTA tackles this as well. So in terms of scalability, IOTA offers a lot more when you compare to most existing implementations of blockchain that are out there. Coming to the next point, modularity. Now, the IOTA protocol in itself, if we talk about it, it's quite lightweight and easy. But with the use of modularity, what they've done is that they've actually not compromised on the parallel functioning capabilities. What I basically am trying to imply that each component associated with the IOTA platform can in itself work without compromising on the overall functionality as well as the speed of the system as well. Now, one key essential factor that makes IOTA stand up in comparison to the others is microtransaction. Now, this in turn actually reduces the need for miners and thereby completely eliminating the need for transaction fees in itself. One of the biggest challenges for Bitcoin blockchain or most of the blockchain implementations that deal with cryptocurrency today is the transaction fees that are associated. Earlier, the idea of blockchain was to introduce a system that did not bring the transaction fees, but today the ideology has changed a lot. Today, even with Bitcoin, Ethereum or Ripple, most of these include a certain amount of transaction fees that are associated with any kind of transactions that you perform. On the IOTA platform, the transactions that you will be performing will be independent of transaction fees as they are microtransactions as such. Finally, let's talk about the quantum systems. Now, one of the biggest challenges most blockchain systems that are out there today face is a challenge in future that will happen is that if we use a quantum computer which has sufficiently high computing powers, then we can actually provide false transactions into the main block itself. This in turn can actually cripple the entire system, providing a chance of compromise in the security itself. Now, let's say I provide 50,000 false transactions into the Bitcoin blockchain system itself, then it becomes highly impossible for us to remove from this. Once a block of false transactions is added to the blockchain, then it becomes unremovable because of its immutable feature. And if I create newer chains based on this false transaction blocks, then it becomes harder and harder as well. So these challenges can actually be overcome in IOTA because it uses triple hash function known as 𝐶𝐿 to ensure that it's not crackable even via quantum computer as well. Now let's actually try to understand how IOTA works and how it's different from any of the other blockchain implementation. Now in IOTA, there are no blocks or even blockchains in itself. This is how it is different. IOTA uses a new data structure based on directed acyclic graph, which replaces the need for blockchain as its underlying infrastructure as well. Now, the use of Tangle thereby in itself reduces the need for minings and transaction fees as a whole. Now, how does it work? Let me just give you an idea. So here, this is a rough representation of how the Tangle would look like. Now, each of these is a directed acyclic element. Okay, basically what do I mean by directed is that there is a direction for each of these. Now, each of these circle in itself is a transaction or site for better reference. Okay, and each of them are linked to at least two other transactions as such, leaving the initial transactions. Okay, now this in turn, these two other sites validate the transaction and the direction specifies the connectivity between each other. Now, the edges that you're seeing are basically the tips of the transactions. Now, these are just new transactions which are yet to be confirmed or validated. So any edge or transactions for that matter, which is not linked to two other transactions, are unconfirmed transactions for that matter. Now, to help you understand better, let's just take a simple example. Let's say I'm going to add this transaction to the Tangle, a simple transaction for that matter. Now, when I have a new transaction, I select two edge nodes and then I connect them to this transaction. Now, once this transaction has been confirmed, then what I'm going to do is that I'm going to connect it and then going to bring new transactions and then keep connecting it then forth. So this in turn ensures that there are multiple transactions that are happening while one is being validated as a whole as well. So this in turn increases the chance for scalability and makes it quite faster as well when you compare to normal blockchain transactions. Now, what it basically also means is that if more and more transactions are going to come into the IOTA, then it also increases the speed of IOTA processing as well. So more the transactions, more the people involved with it, the faster the system will be getting as well. So like I said, IOTA has at the rate about 1,000 transfers per second. This will keep increasing as the number of people involved in this also keeps growing. Now, IOTA is still a product in development and has a lot of various options available today for people to learn and explore as well. Now, IOTA is not just restricted to one specific language implementation or is restricted to a narrow mind thought as well. Now, if you are to look at the IOTA's Git repository, you will find a lot of various applications. But one thing that you should definitely look out for is the various library implementations of IOTA that are available there. So you have Python, you have Java, you have JavaScript that has also been introduced. Then you also have Rust, you also have various other programmings like C#, and this keeps growing as well. Now, IOTA is one project that is out there that you should definitely look out for because it becomes the connecting bridge for two of the most important technologies which are revolutionizing today's market. So if you are interested in blockchain and IoT, this is definitely a project that you should really look out for.
Let's begin comparing them. Starting off with network types. Well, there are three different types of blockchain networks: public, private, and consortium. Public blockchains are accessible by everybody with access to the internet. These networks need every ledger to run consensus to validate every transaction that occurs on the network. Private blockchains are much more different. They are only accessible by a limited number of participants, as the name clearly suggests. They may or may not even have a cryptocurrency involved with the network, as the network is made to tender to very specific needs. A consortium blockchain, also known as a permission blockchain, is pretty similar to a private blockchain. Aside from its limited accessibility, it also has levels of permission levied on the network by leveraging trust. In our case, Ethereum is a public blockchain network. If you have a computer and an internet connection, you can very well participate in the Ethereum network. This also means that if you were to execute some secret transaction that you're really ashamed of, it'll be visible by everybody else on the network, and thus your secret doesn't really remain a secret anymore. Hyperledger, on the other hand, is a consortium blockchain. It was developed in such a way that you could execute those really embarrassing transactions in complete privacy and confidentiality. Talking about cryptocurrencies, Ethereum has its network-specific coin called Ether. Ether is mainly used to pay for transactions and to buy gas, which is in turn used to pay for the computations committed VM. New Ethers are mined by miners who in turn validate the committed transactions. Hyperledger has no such specific coin. Hyperledger gives the developers the freedom to implement blockchain technology however they want for their business. With this said, if a business deems it necessary that they need a token or a consensus, they can always implement one. Talking about consensus mechanism, Ethereum uses a proof-of-work mechanism for its consensus. In a proof-of-work-based algorithm, a hash function is used to create conditions under which a single participant is permitted to announce their conclusion about the submitted information. And then those conclusions can be verified by all other people in the system. False conclusions are prevented by parameters of the hash function, which ensure that false information will fail to compute in the Ethereum system. The participants who publicly verified the transaction on behalf of the entire network are rewarded for their participation with newly created Ether. On the other hand, Hyperledger allows developers to choose whether they require a consensus mechanism at all. When they do choose to opt for a consensus mechanism, an algorithm called practical Byzantine fault tolerance is used, which is also used in other popular blockchain platforms like Ripple and Stellar. Very roughly, without explaining the whole algorithm, what PBFT does is as follows. Each node on the network maintains an internal state regarding ongoing specific information or status of the network. When the node receives a message, they use the message in conjunction with the internal state to run a computation. This computation, in return, helps the node to arrive at a decision regarding the validity of the message. After reaching its individual decision about the message, it shares it with all other nodes in the network. A consensus decision is determined based on the total decisions submitted by all the nodes. The key difference between proof of work and PBFT is that in proof of work, only one node, rather the first node to solve the problem, shouts out the answer, unlike PBFT, which requires all the participating nodes in the consensus to return a decision. Moving on to smart contracts, Ethereum and Hyperledger both allow business logic to be implemented with the aid of smart contracts. Ethereum smart contracts are generally written in Ethereum-specific scripting languages like Solidity or Serpent. Hyperledger contracts, on the other hand, are written in chain code. Aside from that, to run smart contracts on Ethereum, computation fee must be paid in the form of gas. On the topic of language that each platform is written in, Ethereum uses a combination of Golang and Python, while Hyperledger uses a combination of Golang and Java. Ethereum as a platform is maintained by the Ethereum developer community, while Hyperledger comes under the Linux Foundation. So much like other Linux projects, people from all over the world can help Hyperledger get developed as a project. Now that we know the differences of both the platforms, let's go through a use case of both of them. For Ethereum, I'm going to show you all how voting can be made completely transparent. The voter will submit his information to an identity verifier running on Ethereum with the help of smart contracts. After the identity has been verified, a token key is generated which the voter will enter into the ballot interface. This token is unique and solves the problem of double voting in today's world. The voter casts his vote, and this vote is registered in a block on the blockchain network, thus maintaining transparency and integrity of the voting system. Ethereum is preferred here as a platform over Hyperledger due to its public nature, which is integral for voting. For our Hyperledger use case, I'll be explaining a drug tracing scenario so that a pharmacist knows where his medicines are being manufactured for quality assurance purposes. It is important to note that there is no need for it to be public, as that would mean revealing confidential obligations between the pharmacist and the manufacturers. Every change in the medicine's location, storage type, etc. are stored on the blockchain. These can also be automated with the help of Internet of Things sensors. In this way, the pharmacist and the patient both can verify the origin of the product and quality is assured. A very similar business model is being used under the name Hyperledger Sawtooth to track fishes after harvest till the time they're served on the table at a restaurant. Coming to the point of which platform is the best, I personally don't think there is any best, per se, as implementations of each platform should be according to the specified business models. In my opinion, in the near future, most business-to-business franchise or B2B franchise will be run on Hyperledger as they need to execute confidential obligations without passing everything through a central authority. On the other hand, Ethereum will rule the world of business-to-customer or B2C enterprise due to its global reach and public nature. So here are my 10 picks on why you should invest your time in learning blockchain. Now let us start our countdown in the reverse order. At number 10, we have blockchain as a cutting-edge technology. According to Gartner and many other such sites, blockchain ranks at the top as one of the most cutting-edge technologies of the century. The sort of data protection and privacy required by governments and businesses alike is provided by blockchain in an efficient manner. Blockchain in itself is being deemed almost as revolutionary as protocols like TCP/IP and HTTP, if not more. On number 9, we have high demands for blockchain. Blockchain is a booming sector. There are ample opportunities waiting for you in the market. If you think you have the right skill set to work in blockchain and get adapted to the trending wave, then swim in the sea of jobs and enjoy the power of this revolutionary platform. Following which, at number 8, we have calculated investment in cryptocurrencies and ICOs. There is no doubt that cryptocurrency is a word that elicits a very strong response these days. Every time Bitcoin pulls back in price, someone has something to say about it on the internet. It's a new asset class that has taken the world by a storm since Bitcoin first hit the scene. The volatility in the market often is what leads to the fear, but the excitement around the tech itself is outpacing that. Blockchain is an underlying technology of cryptocurrencies, so the understanding of the concept will help you in smart investment and trading. Also, knowing the technology will help you shortlist the best ICOs based on their concepts. The CEO of Current once said, if people are going to day trade cryptocurrencies and they do not know what they are doing, they're going to get slaughtered. Next in the list, we have blockchain as a universal infra facility. Blockchain and DLT, which stands for distributed ledger technology, essentially connects together to form a new type of market infrastructure that sits on top of and integrates into existing systems and processes. So basically, it offers a single infrastructure and solution facility connected with the other type of market. This way, you can integrate into the existing process and system. Moving on, next in the list is the most important reason for you to learn blockchain if you care about security and legitimacy of your data and digital security. If you look at the current web infrastructure, you would find how vulnerable we are right now, which brings me to the original Web 1.0 concerns about the commerce and identity online. Can my credit card and number get stolen? Most definitely. Am I being tracked? Almost 100%. Do they see my profile activity and password? Oh yes. Is it safe? Well, we thought so. In the above image, you can see how blockchain infrastructure eliminates the need for any single entity to keep and store your sensitive data, including you. So if blockchain can solve all these problems, then why not learn to use it? Next comes the exciting part. On the list at 5, I have integration with new age technology. There have been some unique concepts produced from a melding of blockchain with voting systems, commodities trading, and even real estate. But the candidate most likely to push mass adoption of blockchain is the Internet of Things. This ability to build a safe infrastructure for autonomous collaborations makes it easy to be creative without worrying about the veracity of their data. On number 4, I have industries on blockchain. Blockchain is playing a dominant role in terms of technology in the market. Banking isn't the only industry that would be affected by blockchain. Supermarkets, energy resources, healthcare, voting, and many other sectors could also have blockchain in their future. With this, you can begin the shift process and ensure that transactions at the platform of blockchain are maintained and ubiquity of value is also driven. Now, since the industries have also started adopting it, it is suspected that blockchain is soon going to be an inflection of an era. So at number 3, I have inflection point of an era. I feel the world is on the brink of another ARPANET moment, perhaps an inflection point which will directly affect the way people do business. This moment is blockchain. With financial institutions acknowledging the disruptive nature of blockchain, predictions are that blockchain will reach the critical mass around 2024. So I would suggest that it's better to surf the wave before it's too late. Another important reason why you should learn blockchain is that it can disrupt the value chain completely. Blockchain is expected to improve confidence and fidelity between the operating parties. It lessens the value chain, breaks down the workflow, and thus paces up the inter-party processes. This will, in turn, lead to refocusing of certain players in the value chain. There are going to be a lot of job opportunities since players should be sizing up their future positions and managers should be reassessing their value in the chains. At number 1, I have high job prospects and good pay. From cryptocurrency startups that have gone on to establish their own companies, the job market looks good for blockchain enthusiasts, as it is expected to grow exponentially in the coming years. The employers have been searching for the following job roles: senior software engineer, cryptocurrency analyst, blockchain developer, cryptocurrency trader, cryptocurrency mining technician, and the list goes on and on and on.
Modern technology allows people to exchange information directly. Whether it be voice, video calls, email, media files travel directly from A to B, maintaining trust between people however far apart they are. But when it comes to money, People have to trust a third party. This causes a numerous amount of problems in our day-to-day lives, as this system comes with its own shortcomings. For example, a bank may be closed, or your accounts might get frozen, or the bank itself might go bankrupt, which is a conundrum in itself. Addressing these issues became a must, and blockchain technology is challenging the status quo of the system. So let's understand what exactly is blockchain technology using a day-to-day example. Imagine you're at a table with a group of friends and together devise a system to track each other's expenditure. You have also created a protocol to keep everything systematic. Firstly, every time you spend some money, your expenditure is publicly announced to the other three friends. Every transaction also comes with a math problem. Now the first person who solves the math problem gets a chance to verify the integrity of the transaction as to whether it is truthful or not. Once the math problem is solved, everybody else participating in the protocol can verify whether the problem has been solved in an acceptable manner. If yes, the person who ended up solving the problem gets a small reward and the transaction is finally verified. Let's see how this analogy compares to blockchain technology. Now suppose one of your friends participating in the discussed protocol spends some money. He goes ahead and announces his deeds to the rest. Similarly, in a blockchain-based network, whenever a transaction is committed, it is publicly broadcasted to everybody participating in the network. Now this transaction comes with a mathematical problem. This mathematical problem is the basis of trust between the group of friends. As soon as the problem is broadcasted, a race begins between the participating members to earn the reward that comes with the computational effort. Similarly, on a blockchain network, a race starts among the participating members to solve the math. Here the math problem is referred to as consensus, while the race to solve the problem in order to earn the reward is analogous to mining. Once a member of the group solves the problem in an acceptable manner, his technique can be verified by the other participating members. If anything is fishy, they can just ignore the proposed solution and move on with solving the problem. Else, the transaction is deemed valid and the victorious person is rewarded for his triumph. On a blockchain network, particularly the Bitcoin protocol, works in a similar fashion. Once a transaction is broadcasted and consensus between participating members is reached using computational work as a basis of trust, the verifying member is rewarded with bitcoins or the network-specific cryptocurrency. Now, once the transaction is completed, the group of friends write down the result into their separate clipboards, which contain a log of all the previous transactions. These separate clipboards are called ledgers on a blockchain network, and everybody participating in the network has their own separate copy. Now, each ledger contains critical information regarding the transactions. These include timestamps, which is information which tells us when the transaction was committed, and transaction information, example the sender address, the receiver address, and the amount sent. And finally, it contains a hash of the current and previous transaction. The hash can be thought of as a secret signature which verifies the integrity of the transaction for future verification. Now the ledger data is then stored into blocks, where each block contains a hash which points to the previous block, a list of transactions leading to the currently committed transaction, and a block hash to identify the current block. The previous block hash is critical to the protocol. This system allows blocks to point at the previous transaction and thus create a chain of blocks, which gives the technology the name blockchain. Not only does hashing help in identifying the previous block up until the genesis block, but it also provides us with a way to identify any fraudulent changes someone might try to make. This is because a slight change in the input into a hash function changes the hash or digest completely, which is a clear giveaway for something fishy going on in the network protocol. So blockchain technology can be summarized as a distributed ledger technology that underlies cryptocurrencies like Bitcoin and provides a way to record and transfer data that is transparent, secure, auditable, and resistant to outages. Blockchain technology has the ability to make organizations that implement it transparent, democratic, decentralized, efficient, and secure. Blockchain technology is likely to disrupt many services in the coming 10 years. Services like payment methods, supply chain industries, real estate exchange, and identity verification like KYC have already seen the light of blockchain technology at its revolutionary attempt to decentralize the world. Now that you know about blockchain technology, jump with the crowd on the current hype train and never feel missed out.
I have divided the interview questions into two parts, namely advanced and general. We'll start with some of the basics but important questions asked in blockchain interviews. Then we'll move on to the more advanced interview questions. So let's get started with the general interview questions. So the most basic question is, what do you know about blockchain? And the answer to that is, blockchain is a decentralized distributed database of immutable records, where transactions are protected by strong cryptographic algorithms and the network status is maintained by a consensus algorithm. Now the blockchain is devised in such a way that to access any previous transaction, you have to traverse from the last created block to the block whose data you want to access. Now the second question is, what is the principle on which blockchain technology is based on? The answer to that is, basically, we can say that blockchain is a subset of distributed ledger technology. So we can say that all blockchains are DLTs, but all DLTs are not exactly blockchains. Moving on to the next question, what are the different types of blockchains that are available? So basically, at a high level, there are three different types of blockchains. One is public blockchain, which is open blockchains. So blockchain platforms like Bitcoin, Ethereum, Monero all come under public blockchains, which anyone can join. So if you want to become a part of any public network, you just have to download the software and you can start running the node on your own. You don't need to take anyone's permission, which basically makes these networks permissionless. Then the next type of blockchain is private blockchain. All permissions are kept centralized to an organization. Private blockchains allow only specific people in the organization to verify and add transactions to blocks, but everyone on the internet is generally allowed to view them. Some of the examples are multi-chain, block stacks, and so on. Now the third type of blockchain is called consortium. This is also a type of private blockchain, but this is managed by a group of individuals or by a consortium of members. Only predefined set of nodes have access to write the data or a block. Hyperledger is the most popular example of a consortium blockchain. Moving on to the next question, which is, why is blockchain called a trusted approach? Now the reason why blockchain is trusted is because of its immutability, which means that once a transaction is being written onto the ledger, you cannot modify it. Also, every participant has a shared source of truth. Basically, it distributes trust among different individuals of the network via an economic game wherein the individuals are incentivized to maintain the state and validate the transactions. Now the next question is, what type of records can be kept on the blockchain? Is there any restrictions on the same? So the answer to that is, there are no restrictions as such on any kind of data that you can actually store on the blockchain. There are different companies using different types of blockchains for holding all sorts of records. Some of common types that you see here are records of medical transactions, identity management, transaction processing, business transactions, managed activities, documentations, and so on. So there is practically no limit on the kind of data that you're pushing onto the blockchain. Alright, the next question is, blockchain is a decentralized database. How does it differ from traditional databases? So if you look at the table, it says that the record in blockchains are stored in a decentralized database. Whereas in traditional databases, the records are centralized. Talking about the operations, blockchain only has insert-only operations, while in databases, you can perform CRUD operations, which stands for create, read, update, and delete. Since the ledger in blockchain is distributed to the entire nodes of network, the traditional databases have more of a multi-master and master-slave architecture. Then there is consensus amongst the peers for coming to an agreement on the outcome of transactions, whereas in traditional databases, there is two-phase commit. Also, since blockchain is an open network, anybody can validate the transaction across the network. Whereas in traditional databases, there are integrity constraints, and not everybody is allowed to validate the transactions. Okay, the next question is, what are the key features of blockchain? So the most important feature of blockchain, you can say that it is a decentralized network also, and it runs by using a distributed ledger, where immutability is a very important feature, wherein data cannot be modified or deleted, which is why we can say that it is a safe and secure ecosystem. And the last feature is that it has the concept of mining, which is very specific to a blockchain. Okay, so the next question that we have is, what is encryption and what is its role in blockchain? So encryption is basically a way to secure the data. Encryption is used when you don't want someone else to be exposed to your data. The data is passed through some sort of cryptographic algorithm to scramble the data in such a form that it is not readable to human beings. So that data is basically protected by the keys, and only the person with the cryptographic keys can decrypt or decode the encrypted data. Now this approach is really useful in blockchain because it makes the system secure and adds to the overall authenticity of the blocks and the blockchain. Any data in blockchain is encrypted using state-of-the-art cryptographic algorithms, and the blocks are linked together using the encryption techniques. That is what makes it so useful and secure. Okay, let's move on to the next question. So the next question says, what do you mean by blocks in a blockchain technology? Well, we said that blockchain is a distributed ledger that contains a list of transactions. Now these transactions or records are stored in the form of blocks. The blocks are necessary to maintain the order of transactions in blockchain, and each of this block is linked to each other in a sequential form. So whenever a new transaction comes in, it is added to the block. This block is linked to the latest previous block, and so on and so forth. Now the next question is, how is a block recognized in the blockchain approach? So every block in the blockchain consists of a pointer which acts as a link to the block prior to it. So every blockchain has a header which has the transaction data, timestamp, and also the hash of the previous block. So every block is linked to the previous block using the hash pointer. Okay, so moving on to the next question. This should be very basic. Is it possible to modify the data once it is written in a block? So as we all know, blockchain is immutable, so the answer is obviously no. We saw earlier that transactions or records in a blockchain can only be written in once, and it cannot be changed. Since all the records are secured by cryptographic algorithms, any changes in any of these records will result in the change in the hash of all the blocks prior to it, so the chain breaks. So because of this, it cannot be modified because it will change the hash of the entire directory. Now the next question is, what are block identifiers? In a blockchain, there are ways to identify blocks, and these are called block identifiers. Basically, there are two ways to do that. Every block has a block header which points to the previous block, and then we have a block height. The block height is nothing but the number of blocks in the blockchain. So basically, you can identify the block with the block header hash or the block height. Moving on to the next question. Is it possible in blockchain to remove one or more blocks? Well, this is a very easy question, and the answer is no. This is not possible, as removing or detaching any block will disrupt the hash header of all the previous blocks, so you just cannot do this. Moving on, what exactly do you know about a security of a block? So the primary method of protecting a blockchain is by using cryptographic hash algorithms, and each block is linked to another using a hash pointer. So any modification in any records will change the hash identifier of the whole block. Also, one more thing which makes the blockchain secure is the consensus algorithm. The consensus mechanism maintains the state of a blockchain and also acts as a network servicing protocol. Moving on to the next question. What are Merkle trees and how important are Merkle trees in blockchain? So Merkle tree is also known as the hash tree. It is the data structure in blockchain in which each leaf node is a hash of a block of data and each non-leaf node is a hash of its own child nodes. Merkle tree helps you identify a specific data very quickly. Let's say we have 1,000,000 blocks and we quickly want to identify a transaction or block. So the Merkle helps us do it without traversing the entire history of transaction. Alright, let's have a look at the diagram shown here. So if you see, the Merkle tree summarizes the transactions in a block by producing a digital fingerprint of the entire set of transactions. So what do we mean by this is that Merkle trees are created by repeatedly hashing the records together until there is only one hash left. In the diagram, you can see that there is a transaction root at every block, and this transaction root is derived from Merkle tree, and this Merkle tree actually derived from hashes of pair of transactions. Moving on to the next question, what is a ledger and is blockchain an incorruptible ledger? Let's have a look at the first part of the question. So the ledger is simply a record of transactions, and these transactions are nothing but transfer of value. Person A transfers some money to person B, and that becomes a transaction, and such type of transactions are recorded in a ledger. Now blockchain is considered incorruptible, and so what do we mean by this? What we mean is that you cannot hack or corrupt the ledger simply because it is distributed, and if you want to corrupt a ledger, you have to control more than half of the network's computational power or nodes. And doing this is not an easy job because if an attacker wants to control this and try to control the money for himself, he has to invest huge computational resources. So should it happen? Basically, if someone has control of more than 51% computing power in a network, that person would take every precaution to avoid being noticed. But the resources required to take control of such a system is huge. But it is near impossible for one person or community to have such huge computational power. Alright, so let's move ahead. So the next question is, name the common type of network systems that are extensively being used in various applications. So there are three types of network systems. One, you have a centralized network. Secondly, a decentralized, and third, a distributed type. So what happens in a centralized network is that every participant or node in the network can talk to each other only through a centralized node or server. You can see that from the leftmost diagram. If you look at the second one, it represents a decentralized network. So instead of nodes talking to one single server, you can actually group nodes such that few of them have single centralized server, and each of these centralized servers talk to each other. Now in a network like Bitcoin and Ethereum, where we say that it is a distributed network, what happens is that every node talks in a peer-to-peer manner. There is no centralized server of any kind in the system at all. Moving on to the next question, how is a blockchain ledger different from the ordinary one? So in a blockchain, same copy of ledgers exists in the entire network, while in the ordinary system, the ledger may or may not be the same. In blockchain, you only have options to create and read, whereas in ordinary ledgers, you can perform all CRUD options. Now, these are some of the basic differences between blockchain and ordinary ledgers. Moving on to the next question, and this is a very interesting one, which says, what do you mean by mining? So mining is the process of transaction verification and adding those transactions to the block. Now, how does this happen? So there are special nodes called miners which use state-of-the-art cryptographic algorithms to validate the transaction across the network and add these transactions to the block. Okay, so moving on to the next question again. A distributed digital ledger is used for recording transactions on a blockchain. What does the system rely on? So the answer to that is, when we say that what we are recording transactions in a distributed ledger, the underlying network is basically composed of different nodes. So the system relies on the nodes or the full nodes and the mining nodes, which are responsible for maintaining the security and smooth running of the system. Next question, can you explain the components of a blockchain system? Okay, so the answer is pretty simple. The basic components in a blockchain ecosystem are the shared ledger, which is the digital ledger distributed among the peers. And then there is a node application which you install and run on a computer to become a part of a particular blockchain network. Then there is a virtual machine where the instructions are implemented and every participant in the ecosystem runs that virtual machine. Lastly, of course, there is a consensus mechanism which is implemented as a part of the node application. It provides the rule for how the ecosystem will arrive at a single view of the ledger. Moving on to the next question, we have state the difference between how proof of work and proof of stake. So we have properties of proof of work and proof of stake. In proof of work, the probability of mining a block depends on the amount of work a miner does for validating the mining of a block, whereas proof of work has stakeholders and they validate new blocks by utilizing their share of coins on the network. Next point is that proof of work takes more energy than proof of stake, which is why Ethereum is gradually shifting to the proof of stake consensus mechanism. Proof of work takes up computer speed for mining blocks, while in proof of stake, user needs to own a majority of coins in order to attack the network. Moving on to the next question, name some of the popular platforms for developing blockchain applications. So people are experimenting a lot with blockchain technology, which is why there are so many platforms coming up for the building of blockchain applications. Some of the popular platforms are Ethereum, Hyperledger Fabric, Corda, Cardano, IOTA, and Quorum. So some of these networks are public networks that also work in a private setting, like Ethereum is a public network, but you can also deploy it in a local setting, whereas Hyperledger Fabric is completely private and permission network where it has no concept of a coin and it is purely used in a consortium and private manner. Now moving on to the next question is, what is double spending and is it possible to double spend in a blockchain system? So double spending is a condition where one digital token is spent multiple times because the token is a digital file which can be easily copied. Now what happens is a person named A try to send some coins to person B and person C at the same time. The blockchain prevents such a case, since the transactions are confirmed by multiple parties and it is not possible to double spend a crypto token in a blockchain. Moving on to the next question, what are the benefits of blockchain that you know of? So there are some major benefits of using blockchain, which is why blockchain has become popular in recent times. Transaction settlement in blockchain happens in real time, so any transaction is peer-to-peer and the network itself verifies the transaction, which makes the transaction much faster. And since there are non-third parties involved, the transaction cost is also minimal. Again, the transaction and the system is secured by strong cryptographic algorithms, which in turn accounts for the immutability. Then there is an important property called user pseudonymity, which means that flow of transactions are tracked by user addresses. Okay guys, that was the end of the general interview questions. Now we'll move on to the more advanced section, which you might be asked to you in your interviews regarding your blockchain career. So let's dive into them. So the first question is, can you tell me about some of the widely used cryptographic algorithms used in blockchain? So some of the widely used algorithms in blockchain include algorithms like DES, where DES stands for Digital Encryption System. Then we also have the RSA algorithm, which is used in numerous areas concerned with digital certificates. Other algorithms include Twofish, Blowfish, and AES. Out of all these algorithms, AES is the strongest encryption algorithm to break. Moving on to the next question, we have, what do you know about forking in blockchain, and name the types of forking? Okay, so at the most basic level, a fork is what happens when a blockchain diverges into two potential paths forwards, either with regards to a network transaction history or new rule in deciding what makes a transaction valid. But forks can also be willingly introduced into the network. This occurs when developers seek to change the rules the software uses to decide whether a transaction is valid or not. Forking in each and every blockchain is different and based on the design architecture and use case for which the chain is meant for. So essentially, there are two types of forking. The first kind is a soft fork, and this means that in any change is backwards compatible. Then we have a hard fork, and in this the software upgrade that introduces a new rule to the network is incompatible with the older software. Okay, so the next question is, explain the significance of blind signatures and how it is useful. So let's tackle the first part of the question first. So a blind signature in cryptography is when digital signature is generated for a certain content, with the content itself being disguised or blinded. This generated blind sign can be verified against the original unblinded messages using conventional decryption techniques. The message is blinded by the author and signed by a different party. This system is generally deployed in privacy-related protocols, for example, electoral processes, polling campaigns, digital caching systems, etc. So moving on to the next question, which is, what is secret sharing and does it have any benefit in blockchain technology? So secret sharing, also called secret splitting, refers to methods for distributing a secret amongst a group of participants, each of whom is allocated a share of the secret. The secret can be reconstructed only when a sufficient number of possibly different types of shares are combined together. Individual shares are of no use on their own. Secret sharing essentially allows data to be stored in a decentralized way across n parties such that any k parties can work together to reconstruct the data. But k1 parties cannot recover any information at all. N and k can be set to any values desired. All it takes is a few simple parameters tweaks in the algorithm. Now it has its benefits in blockchain technology as it allows private content to be divided into small parts and be sent to the destination on a decentralized network. So moving on to the next question, which is, can you explain what are off-chain transactions? So off-chain transactions refer to those transactions occurring on a cryptocurrency network which move the values outside the blockchain. Due to their zero or low cost, off-chain transactions are gaining a lot of popularity, especially among large participants. Off-chain transactions can be better understood when compared to on-chain transactions. An on-chain transaction, which is simply called a transaction, occurs and is considered valid when the blockchain is modified to reflect the transaction on the public ledger. It involves the transaction being validated and authenticated by a suitable number of participants, recording of the details of the transaction on the suitable block, and broadcasting the necessary information to the whole blockchain network, which makes it irreversible. This kind of transaction can be reversed only after a majority of the network's hashing power comes to an agreement. Essentially, every step linked to an on-chain transaction occurs on the blockchain, and the blockchain status is modified to reflect the occurrence and validity in the transaction. In contrast, an off-chain transaction takes the value outside the blockchain. It can be executed using multiple methods. Okay, so moving on to the next question, which states, what do you mean by anonymity and pseudonymity in cryptocurrencies? Well, an anonymity network enables users to access the network while blocking any tracking or tracing of their identity on the internet. This type of online anonymity moves internet traffic through a worldwide network of volunteer servers. Anonymity networks prevent traffic analysis and network surveillance, or at least make it very, very difficult. A good example of this is Zcash. Now, let's discuss pseudonymity. So sometimes it is desired that a person can establish a long-term relationship with some other entity without necessarily disclosing personal identifying information to that entity. In this case, it may be useful for the person to establish a unique identifier called a pseudonym with other entities. Examples of pseudonyms are pen names, nicknames, credit card numbers or student numbers, bank account numbers, etc. Well, for a blockchain, it is mostly the block address or the account address. A pseudonym enables the other entity to link different messages from the same person and thereby to establish a long-term relationship. Now let's move on to the next question, which says, how does peer discovery work in a P2P network? So the answer to that is, on a decentralized network, when a node boots up, it has no idea about the network. Since there is no centralized resource, the most practical way would be to connect to the first discoverable node. This has certain drawbacks though, as the trust and integrity of that node is completely unknown. To address this problem, developers have hard-coded a list of trusted node parties into the network. When a node boots up, it initially connects to these trusted nodes and then begin their node discovery process by just connecting to the other node connected to these trusted nodes. This trusted list is a very small fraction of the entire number of systems on the network and therefore do not hurt the decentralized aspect of the entire system. Moving on to the next question, which is what is a 51% attack? In my opinion, this is one of the most important questions when looking at a blockchain interview. So let's see the answer. So as its name implies, a blockchain is a chain of blocks, bundles of data that record all completed transactions during a given period of time. Once a block is finalized, mined, in the jargon it cannot be altered since a fraudulent version of the public ledger would quickly be spotted, rejected by the network's users. However, by controlling a majority of the computing power of the network, which is basically 51%, an attacker or group of attackers can interfere with the process of recording new blocks. They can prevent other miners from completing blocks, theoretically allowing them to monopolize the mining of new blocks and earn all of the rewards. They can block other users' transactions also. They can send transactions, then reverse it, making it appear as though they still had the coin that they just spent. This vulnerability, known as double spending, is the digital equivalent of a perfect counterfeit and the basic cryptographic hurdle the blockchain was built to overcome. So a network that allowed for double spending would quickly suffer a loss of confidence. Now moving on to the next question, which says name organizations that can use blockchain technology. So any service that follows the current centralized architecture could implement blockchain in their business. Services that have any sort of online or financial transactions could make their process seamless with the help of blockchain. Nowadays, with private blockchain services like Hyperledger, even confidential processes regarding government and defense could be implemented through blockchain. The possibilities are really endless, and we are just on the road of discovery. Moving on to the next question, we have what are the core requirements for a business blockchain? So let's first look at what exactly is a business blockchain. So business blockchain, as the name suggests, is a blockchain service that can be implemented for businesses mostly private in nature. In these cases, mostly a private or consortium blockchain is used. The requirements of a business blockchain are as follows. Firstly, we need a shared ledger, which is a common aspect of every blockchain. Secondly, there needs to be privacy and permissions. Most businesses have certain rules regarding content sharing amongst this organization. In this case, a high amount of privacy and permissions at different levels of the network are required. This is essentially provided by a consortium blockchain. Thirdly, we need smart contracts. The business always needs to implement business logic on the blockchain, and the only way to do this currently is with the implementation of smart contracts on the system. Last but not the least, we need a consensus algorithm. Just like every blockchain, a consensus protocol is obviously required for the validation of blocks into the new chain. Now moving on to the next question. What are the key principles in blockchain that are helpful in eliminating the security threats that needs to be followed? Okay, so there are a few principles to be followed for eliminating proper security threats, but this is not specific to blockchain as they can be applied to any general network. So firstly, we need to have a proper auditing process. Secondly, applications must be secured with proper role-based access control system, and there should be proper testing of every unit and the integration also. Next, the database, that is distributed ledger in this case, must be secured and encrypted using up-to-date encryption functions. Also, there should be sufficient continuity planning, and there must be ample training of the workforce to follow these best practices. Okay, so moving on to the next question, which is the blockchain different from banking ledgers? Okay, so banking uses ledgers for timestamps and transaction records just like a blockchain, but the main difference lies is in the fact that bank ledgers are not public. They're controlled by centralized authorities, that is the bank, unlike a blockchain which is completely public and open source. Moving on to the next question, can you list some of the popular consensus algorithms and why do we need different consensus mechanisms? Okay, so some of the most popular consensus mechanisms are PBFT, which stands for Practical Byzantine Fault Tolerance, Proof of Work, Proof of Stake, then there's also Proof of Burn, Delegated Proof of Stake, and Proof of Elapsed Time. Now we need different consensus mechanisms, mostly to cater to different business models. Also new consensus mostly provide an optimization in terms of storage and performance. Other things can also be implemented like regularization requirements, implementation, performance, tokenization, security, privacy, etc. So moving on to the next question is there any network-specific conditions for using blockchain technology in an organization? So the only basic requirements for a network to implement blockchain is that it must be a P2P network. It helps validate the new blocks simply and helps organizations to keep up the pace in this matter without investing in third-party applications. Moving on to the next question, name the steps that are involved in the blockchain project implementations. Well, there are a total of 6 steps involved in this process. Firstly, we need to decide if we can use an existing blockchain for our purposes. For this, we need to do some requirement identification. After the requirement identification has been done, we need to screen all the ideas that have been come up while the brainstorming was being done. Next, we actually take the idea that has been chosen and implement it through some successful project development cycle. Next, we have to do some feasible study on the security and implementation. Last but not the least, we have to also take care of controlling and monitoring the project. So these are the 6 simple steps that you need to follow when deploying your blockchain project. Moving on, explain a real-life use case where blockchain is being used. So this is very easy. I have an example in front of you, which is 𝐶. So 𝐶 is an open source, decentralized file storage solution. It uses encryption, file sharding, and a blockchain-based hash table to store files on a peer-to-peer network. The goal is to make cloud file storage faster, cheaper, and private. Traditionally, cloud storage solutions like Dropbox or Google Drive have limitations. While files are backed up redundantly, bandwidth from a data center or unexpected outages can restrict access to your files. There are also issues of privacy, and these companies have complete control over your files, including the ability to access them. The 𝐶 project uses blockchain and peer-to-peer network to solve these problems. It distributes the files, so redundancy is well established. It also guarantees you're only one who can access your files. Now moving on to the next question, which is, what are sidechains? So a sidechain is a separate blockchain that is attached to its parent blockchain using a two-way peg. The two-way peg enables interchangeability of assets at a predetermined rate between the parent blockchain and the sidechain. The original blockchain is usually referred to as the main chain, and all additional blockchains are referred to the sidechain. The blockchain platform Ardor refers to its sidechains as child chains. A user on the parent chain first has to send their coins to an output address, but the coins become locked, so the user is unable to spend them elsewhere. Once a transaction has been completed, a confirmation is communicated across the chains, followed by a waiting period for extra security. After waiting the period, the equivalent number of coins is released on the sidechain, allowing the user to access and spend them there. The reverse happens when moving back from a sidechain to the main chain. Now moving on to the next question is, can you name one major limitation of blockchain? So as everyone knows, cryptocurrencies has had a fantastic year in 2017. But now with more tokens, users, investors, exchanges, and startups involved than ever, scalability is emerging as a serious issue. With transaction data piling up, the current system is beginning to strain under its own weight. With every purchase, the blockchain adds one more block to its ladder of transactions, and every block increases with data as it carries the history of the block before it. As more users join the network and transaction histories of individual coins grow, the current system is in danger of buckling. So, as we see, scalability is basically the major issue in blockchains today. Now moving on to the next questions, are there any alternatives to blockchain? So, yeah, there are actually alternatives to blockchain. Hashgraph is a new consensus alternative to blockchain. It uses a gossip protocol that works in the following manner. Every node in Hashgraph can spread signed information called events on newly created transactions and transactions received from others to its randomly chosen neighbors. These neighbors will aggregate received events with information received from other nodes into a new event and then send it on to another randomly chosen neighbor. This process continues until all the nodes are aware of information created or received at the beginning. Due to the rapid convergence property of gossip protocol, every piece of new information can reach each node in the network in a fast and very easy manner. Okay, now moving on to the next questions. Do you know the means to scale a blockchain technology? Well, the first method to actually scale a blockchain technology is a Lightning Network. Now this was proposed to a solution to Bitcoin scalability. So what it does is implement off-chain transactions, which means basically not the entire list of transactions happen on the main chain. Only the first transaction may happen on the chain, then all the following transactions happen on a side chain, which takes lesser work and lesser space. And then the final transaction is again updated on the main chain, maintaining the integrity of the network. While this is a skewed approach, it kind of works in today's world. Next, we have SegWit, which stands for segregated witness. So in SegWit, the signature data will move on from the main chain to the extended block in the parallel chain. What this will do is that it will free up a lot of space in the block itself for more transaction. It was envisioned that the signature data would be arranged in the form of a Merkle tree in the sidechain. The Merkle root of the transaction was placed in the block along with the coin-based transactions. However, on doing this, developers stumbled upon something unexpected. They discovered that on putting the Merkle root in the particular place, they somehow increased the overall block size without actually increasing the block size limit. After that, we have another practical approach, which is increasing the block size. So with increasing transactions, the possible solution is to actually increase the block size to just accommodate more transactions. But in my opinion, that's just a lazy approach. Lastly, we have sharding. Now, sharding is a scaling technique that was inspired by a traditional concept of databases sharding, whereby a database is partitioned into several pieces and placed on different servers. In the context of a public blockchain, the transaction load on the network would be divided into different shards comprising different nodes on the network. As a consequence, each node would process only a fraction of incoming transactions, and it would do so in parallel with other nodes on the network. Breaking the network into shards would result in more transactions being processed and verified simultaneously. As a result, it becomes possible to process more and more transactions as the network grows. This property is also referred to as horizontal scaling. Now, we could imagine that existing blockchain operates like a busy highway with one toll station operating only on one toll booth. The result would be a traffic jam as people wait in long lines to pass the toll station. Implementing a sharding-based blockchain is like adding 15 or 20 toll booths to the highway. It would dramatically improve the rate at which traffic can progress through the stations. Sharding would make a tremendous amount of difference and dramatically improve transaction speeds. So moving on to the last question of the session for today, we have, with blockchain came the Web 3.0. Can you name some of the decentralized blockchain-based applications that will bring about the next level of the internet? So the answer to that is, you could name some of the applications that have been actually implemented through blockchain. For example, browsers like Chrome have been implemented in a decentralized manner called a Brave browser. Then we have storage file systems like Storj and IPFS. We have operating systems like Essentia and EOS, and social networks like Steemit. So as you guys can see, there are a lot of blockchain-based applications that are actually replacing all the currently centralized services. So yes, indeed, we can actually call the internet run on blockchain the Web 3.0. So guys, that was the end of all the blockchain-based questions that you might face during your interviews. I wish you the best of luck for all the interviews that you might be appearing for. That's it from me. Goodbye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!